Hi, and welcome to the course C Programming Made Easy for Beginners Step by Step Approach. I am Sharif, your instructor for this course. Before you proceed to start the course, let me guide you how exactly you should follow this course. First, let us look at the course contents. Then I'll guide you what exactly should be your approach to follow this particular course such that you can gain maximum benefit out of this course. And of course, what exactly the resources provided by this course. And at the end, if you have any doubts, then what you should do. Let us begin with the actual course contents. The course is broadly divided into 12 chapters. And among them, the first chapter is the introduction part. This introduction is about the language, that is C language, and what exactly we mean by higher level language, lower level language, machine language, what do we mean by compiler, interpreter, debugger, etc. Then we will move on to the basics of C programming and a brief history, who has created it and when this particular language came into existence. These are going to be the building blocks of C programming, that is going to be keywords, identifiers, constants and variables, and also we will see how do we write down comments in C language. There are huge collection of operators which are supported by C language. Among them, arithmetic operators, relational operators, logical operators, bitwise operators, ternary operators, assignment operators, etc. Then comes the conditional structures. If at all any statement has to be executed based upon certain conditions, then C programming supports simple if, nested if else ladder, switch case, etc. Looping structure. Here, this particular chapter, every programmer must spend some time, and even I have spent a lot of time and lot of examples to practice, and I'll make you to practice lot of examples through programming challenges as well as online coding challenges. Then we will see functions. We have user defined functions, built-in functions as well as recursive functions. Then have arrays, one-dimensional arrays, two-dimensional arrays, three-dimensional arrays, and the chapter which is going to be a very interesting one for the programmers is pointers. I have specifically spent a lot of time in discussing this particular topic, pointers, such that you will feel this topic to be very easy, and after completing this chapter you will feel comfortable to do any type of programming with pointers. Then we have user defined strings as well as built-in strings, and then we have structures and unions covered in a separate chapter, such that we have seen structures with arrays, structures with strings, structures with pointers, and structures with functions. And the last chapter is files. We will see different types of files that is going to be covered in C language, that is binary files, text files, and different types of modes in which a file can be opened, and we will cover it through different examples. So these are going to be different chapters. We have classified it so that you can find each topic separately and do the programming according to that particular topic. And the most important part of the course is here. As the name suggests, that it is a step-by-step approach. That means that first we have covered the concepts of the programming language C, and based on this particular concept we have demonstrated it through some practice programs, how exactly these concepts can be implemented in C language. Then once you got the idea how exactly we can develop the logic and how we can solve the problems, then some programming challenges are given to you. If you can able to solve the programming challenge, it is well and good. Otherwise, we will be having a separate video covering the solution to this particular programming challenge. And also we have attached the source code for your help. Once you are familiar with solving programming challenges, then we will have the last one, that is going to be online coding challenges. These online coding challenges will help you in developing different logic with each and every topic what we have covered over here. So this is going to be a step-by-step approach. First, we have covered the basic concepts of the programming language. Then we have demonstrated those particular concepts in the form of programs. Then we have made you to solve the programming challenges by yourself. Once you are familiar with it, then you can go to solve any online coding challenge. Now, what should be your approach to follow this particular course? If you are a beginner, then I'll suggest you should not skip any one of the chapter what we have listed just now. And if you are familiar with some of the programming concepts, then you can skip the initial chapters and you can start with the operators. We have started our programming challenges and online coding challenges from this particular chapter. And if you are preparing for any interviews, then I suggest you to watch each and every video and follow the practice program and solve the programming challenge by yourself. If you are able to solve it by yourself, then you can solve the coding challenge that is provided as online coding challenges very easily. And this particular online coding challenges will help you in cracking many of the interviews. So as a whole, the approach to follow this particular course should be sequential, that is chapter by chapter. Follow each chapter sequentially, one after the other, and solve the problems according to the chapters. This course provides the resources in the form of source code. For every practice program or any programming challenge or any online coding challenge, we have attached the source code as the resources. You can easily click that resource and download it. And if you have any doubts, then you can write down your doubts under question answer section or message me directly. And if you are executing the program and finding some errors, do simply copy the code and paste the code. This will help me to identify the errors easily so that I can reply you very quickly. And of course, where exactly the problem is, you can just share the screenshot. So all the best and continue with the course. Thank you. Hi and welcome to the installation process of our software CodeBlocks. Select your favorite browser. Here I am opting for Google Chrome and search for CodeBlocks. The first option what you have over here is codeblocks.org site. When you click this, you will go to the site of CodeBlocks. CodeBlocks is a open source cross-platform software. Right now we want to download it, so select downloads here. There are 3 different types of CodeBlocks versions are available to download. Download the binary release, download the source code, and here is a retrieve source code from SVN. Select binary release and the operating system in which you want to install. Select the platform. For Mac, you can go for this. CodeBlocks for Mac.zip file is available. There are 2 sources from which you can download it. Just if you click, it will start download. Here is the environment we are working is Windows 10. So I am going to select now Windows 10 option. There are different types of files available for download. For C and C++ GNU compiler, you select CodeBlocks 17.12 MinGW setup. And here are the 2 sources from which you can get it. I am selecting source4.net. You can see a message over here. Your download will start shortly, and here is the download is getting started. The size of the file is around 86 MB. It will take some time. Now that the download has been completed, you can just see here and click this exe file. You will get a message. Do you want to allow this app? Select yes. Welcome to CodeBlocks setup. Select next. Here is the license agreement. I'll say I agree. And here are the components shown, which features you want to select. By default, all are selected. This is the memory required in your system to install CodeBlocks. Select next, and here is the location of the CodeBlocks folder where it is placed in your computer's memory. Space required is this much, and this is the space that is available. If you want to change the location, you can select browse and change the location. I am keeping the same location. Select install. Now it's getting installed. Once it has done the installation process, you are getting one message. Do you want to run the code blocks now? Right now we don't want to run it. I'll just say no here, and setup was completed successfully is the message. I'll select next and say finish. We will run the code block and see the environment. Click the code blocks icon. Here is the integrated development environment provided by code blocks, and the version is 17.12. You can see over here code block 17.12. If you want to create a new project, just select file, new and project. Here are the categories available. I'll go for console application and say go. You have two options over here. Make a selection, or either you want to work with C or C++. Let us select C and say next. Say you want to give the project title. Let us say test. Here is the folder location available, and here is the complete path, and the extension used is CBP, that is code block project. Select next, and here is the compiler, GNU compiler, which is going to be used for compiling our programs. Select finish. You are ready with the IDE, and here is the file which is created as main.c. You want to create your own file, just remove this one and select new, empty file, select yes, select my first program.c. Multiple selection here for debug and release. Just say OK and you are done. You can just see over here the file name my first program.c is available over here. Here is the editor provided by code blocks, and you want to perform any settings over here. You have settings, compiler, which compiler we are running with. Here is selected compiler is GNU, GCC compiler it is. So by default it is there. If it is not there, you select that compiler from the list of compilers and select OK. You want to set the settings for debugger. Here is the default debugger available. If it is not selected, select the debugger and say OK. You are ready with the programs to execute. That's all for this particular session. We will see the program executions in the next videos. Thank you. Hi and welcome to the first program in C language. The screen what you are seeing right now is the integrated development environment, that is the IDE of code blocks. Code blocks is an open source software which we will be using in our course to execute the programs. Let us begin over here. We want to create a new project. First thing what you need to do is select files, new, and the option over here is project. We got multiple options over here right now. Go for console application and select go. Then you have two options over here, either C language or C++. Right now we are working with C language, so select C and say next. Now here there is a text box to enter the project title. I'll give the name of the project as my project. Here the title of the project, that is the name of the project what we have given. It's a user defined name, and the location where exactly the project is going to be stored in the memory. Right now it is C:, and the project file name will be having the extension .cbp. So it is code blocks project, and the complete path where exactly the project is located. After selecting this one, go for next. The next step is it's asking for the type of compiler in which we are going to execute our programs. By default GNU is the compiler, and we are going to enable both the options of debugging and make this option to be checked. By default it is already checked. Then go for the next one, that is finish. I want to add new file, say new empty file. Do you want to add this new file in the active project? Yes. Then where exactly you want to store it? It's storing within the same folder, my project name, and let us say I'll give the file name as my first program.c or .cpp, and select the targets this file should belongs to, both debug as well as release. Just it's automatically checked, so just click OK. So you can see over here the source file, the file name what we have given, is currently available over here. Right now, this is the logs window. You can see it over here. When you compile the program and check for any errors, this window will be helpful. Right now, this is the editor using which we are going to write down the program. And this editor is the editor of code blocks. I have made it full screen over here. You can just see the file name and code blocks 17.12 is the current version. Let's continue with the program. The program structure of C language starts with the first preprocessor directive, that is including the files, something called as header files. The first and most important header file that is used in C language is stdio.h. stdio.h stands for standard input output header file, and hash include is one of the preprocessor directive. So right now you don't need to worry about what exactly a preprocessor directive is and what exactly a header file is. We will be seeing all these topics in the coming videos. stdio we are using it because we are going to use printf statement to print the message. Main function is right now we are not taking any parameter, but main function can also take two parameters, that is called as command line arguments, argc and argv. Let us just simply give a message to the user using one function called as printf function. When you type printf over here, you can see the syntax for it. Printf taking constant string as a parameter followed by the variables whatever we have separated by comma. Let us just give a simple message over here. Hello and welcome is the only message what I am printing it. Since main function is expecting some return value over here, we will give say return 0. This return 0 will return the value 0 to the calling environment, that is the operating system through which the main function gets called. Now, once the program code is over, I haven't given a complex code over here. It's beginning, that is the first program. So just want to give you a look and feel of how exactly your programs are going to be. So here once you are done with this program, here is the option now to build. Shortcuts are also available here, Control F9, or directly you can click over here build. Build will check for the errors and you can see it in the log over here. So downwards you can see a message over here indicating that 0 errors and 0 warnings is the message. If at all, let's say I'll intentionally make some mistake, I'll remove this semicolon. What this semicolon is, every statement in C language terminates with a semicolon. So I have given semicolon for printf, I have given a semicolon for return 0. Let us say intentionally I have removed the semicolon from here, and if I want to now build and check, you can see the errors over here. Downwards you can easily see the error over here, expected semicolon before return. That means that before this return there is something to be expected over here. That means that before return one semicolon was expected over here. After semicolon, the immediate next instruction is return only. So this error says that expected semicolon before return, and you can see the line number as well, the line number in which the error is there. Go to that line number and remove the error. Say I'll give semicolon and now I'll build it once again. Now you can see 0 errors and 0 warning once again. Once you are done with building the project, now you can execute the project. What we have done in building up the project is giving the code to the compiler. So compiler will have many phases. We will see that one in a separate video, how exactly the sequence of steps will carry out. So right now that first phase is completed, that is compilation phase is done. Now the execution phase. Execution is to run the program. There is a shortcut called as Control F10 also. You can run and check for the output. Here is the output, what you can see it. We have given in double quotation mark over here using printf function, and that one has terminated over here with semicolon. That is the only one statement given. If you want to add some more statements, let us say I want to give one more printf statement. Hello and welcome was the first message. To the course of C language is another message. Let's build. Separately, instead of doing it separate actions here, you can build and run at once. There is a semicolon missing over here again. Build and run. you can see the output. Hello and welcome to the course of C language. One thing you can observe over here is we have given these messages in two different printf statements, but even though in spite of giving these messages in two different printf statements, we are getting the output in the same line. Why? Here we required the carriage return, that is the new line function, say /n. Either you can give /n at the end of the first one, or you can give this /n at the beginning of this message as well. Let us build and run. Now you can see the difference. Hello and welcome is printed in the first line, to the course of C language is printed in the next line. So here, what are the things we have seen over here is the environment in which we are going to work is the code blocks IDE, and how to create a project, how to create a simple file, how to write down the code within that one, and the extension of this file is .c. Then once you are done with writing down the program, we have to compile the program using Control F9, and we have to execute the program using Control F10. If at all any errors are there, that you can see it over here in the logs and remove the errors accordingly. That's all for now. We will see the remaining topics in the coming videos. Thank you. Hello and welcome to the online coding challenge. In this series of online coding challenge, we will be solving some online coding challenges on the very popular website HackerRank. I have created an ID specially to show you how we can go on solving a series of challenges. Here we have many programming languages like C, C++, C#, Java, Julia, JavaScript, Python, Perl, and many more languages are there. We will start with C language. Here is your first challenge. This is an introductory challenge to help you get familiar with the HackerRank coding environment. Complete the function solve me first to compute the sum of two integers. Let us see. The prototype of this function is solve me first is the name of the function, takes two integer parameters and returns an integer value, where a is the first integer input and b is the second integer input, and the return value is the sum of the above two integers. Say for example, if a value is 2 and b value is 3, sample output should be 5. Here is some detailed explanation given, and this will be the same template to be followed for all the programming challenges. The name of the challenge will be here, brief description with sample input, sample output, and some brief description and explanation about the challenge. The sum of the two integer a and b is computed as 2 plus 3 is equals to 5. And here you can see the code is provided, and here is the function definition, and here is the function call. We need not input the values here, automatically the values will be inputted. So just need to complete this formality here. Hint is given as type return a plus b. Since it is the first one, hint is given a plus b, we will be writing it. Once we complete filling up the blank code, then we will test using a button called as run code. Now here is the message, congrats, you just solved the first challenge. So we want to continue further, so we'll press continue. Are you a student or a professional? Since you people are student, and if you are professional, you can opt for this one. We will be solving some from students and some from professional options. Proceed to dashboard. Here is the C options, and you can see here at the right side, here is my login ID, and 15 more points to get your first star. We haven't score any points over here, so that's 0 out of 15. Let's start solving the first challenge, that is hello world program. I'll click solve challenge. Here is the problem definition. Objective is given, the task what we need to perform, input format, output format, sample input, and the desired output what is expected is given. Let us first begin with the problem. Here in this challenge we will learn some basic concepts of C that will get you started with a language. You will need to use the same syntax to read input and write output in many C challenges. Here is the task. The task is to print hello world on a single line and then print the already provided input string. Here, given in the input format, you do not need to read any input in this challenge. So the task is to print hello world in a single line and then print already provided input string into the console, and there is no input in this one. Output format, we need to print hello world in the first line and the string from the given input that is to be printed into the second line. This is the second line option, that is this option should be printed into the next line. Here is the code. Required header files. A character array is declared and reading that string over here. The format in which we are reading it a string, this type of format is useful to read the string until the end of the line. Here is the code what we need to enter. It's already entered over here. Since this one is the first programming challenge, we need not enter it any code. Hello world is already printed. Within the next line, using /n, %s, that is %s will be this one, this string. Welcome to C programming will be printed immediately in the next line with this %s, that is stored in a string called as s. What we need to do here is just run the code and see the sample test case 0. Congratulations, you have passed the sample test case. Here is the input provided using stdin, and hello world was already given in the printf statement. This was attached here in the next line using this /n, and expected output, it matches. Since the output what we have generated is matching with the expected output, it's saying congratulations and passing the sample test. Let's submit the code, and it's having only one test case. In the coming challenges, you may be having more than one test case. Congratulations is the message. You have solved this one, and here more importantly, you have earned 5 points. 5 points among 15 you have earned, that is 33% of the points. So here you can see 10 more points to get your first star. This is how the first challenge we have solved. I hope the way we have solved the challenge is clear. This is just to demonstrate how exactly the challenges can be solved in HackerRank.
Hi, in this section, we will learn about the following. First, what do we mean by computer programming? Next, why do we need programming? And at the end, we will see the benefits of computer programming and how it helps to develop problem-solving abilities. Let's start with what is computer programming is. It is as simple as giving a detailed explanation to the computer to solve a particular task. Hence, we can say it is the process of writing program, that is giving instructions to the computer to execute it and give the solution back. Writing a program involves sequence of instructions which will be given to the computer to perform a specific task. This sequence of instructions enables the computer to do some action. We are actually guiding the computer in solving a particular problem. Therefore, we can say by using computer programming, we are teaching the computer to solve a given problem. So it is an act of teaching the computer to solve a given problem. Then comes a question, why do we need programming? Can't computer solve the problems by itself? The answer to this question is no, because computer can't perform any action by itself. As humans have brains, computers doesn't have brains. It is just a dumb machine with lots of electronic mechanisms in it, and it is just a box which cannot do anything by itself. Everything has to be fetched in the form of instructions. So machine like computer has no brains. We have to give instructions so that computer can execute it. Then who will instruct the computer? It is the user who guides through the instructions what action computer should perform to solve a particular problem, what it has to do. Like we teach human beings some language. Say I want to learn English language or French language or Spanish language, etc. so that I can easily communicate in that particular language. Similar to that, we teach human beings some languages. Here we can teach the computer through communication and interacts with us to solve a particular problem. Then immediate question that comes into our mind is, which language computer understands? Computer understands only one language called as machine language, which is also known as binary language. Binary language is built up with only zeros and ones. As a programmer or user of computers, we can provide complete set of instructions to the computer which will help computer to solve a specific problem. So as a user, we give detailed instructions to the computer to solve a specific task. Now let's define what exactly we mean by programming is. Programming is a process of making computer learn. So we can say it is the term which refers to teaching or instructing set of commands to the computer, like a boss instructs the subordinate to accomplish a given task. As a programmer, we are the boss and we are giving the commands to the computer to solve a particular problem. Let's move on to the last part of this section, that is the advantages of learning programming. Once we start learning any programming language, it will definitely improve your ability to understand, analyze and plan accordingly and solve the problem based on the analysis and the plans what we made. So programming teaches you how to understand, analyze, plan and solve the problems. Another major benefit of programming is it improves your analytical skills and definitely helps in solving your day-to-day real-time problems as well. The logic what we develop to solve the problems will definitely helps in solving real-time day-to-day problems. Another major advantage of programming is, say, we may know some basics of solving the problem, but in what way shall we proceed? Here is some problem. Say, for example, 3 plus 4 multiplied by 5 is there. Is almost everyone can solve. But shall we add 3 and 4 and the result must be multiplied by 5 to get 35? Or shall we multiply 4 and 5 and then add 3 to the result to get 23? This type of skills will be definitely enhanced. So programming is not just writing down the code. It is more about problem solving skills rather than just writing the code. Since programming helps in solving different types of problems, it will support to develop the analytical and problem solving skills. As a child improves their minds by solving different puzzles. So learning programming is important because it also develops analytical and problem solving abilities in a programmer. These are some of the advantages of computer programming. That's all regarding computer programming and their advantages. In the coming videos, we will see the remaining concepts. Thank you. Hi. In this section, we will learn about the following. What is a program? Who is called programmer? What is programming language? Most popular programming languages. Before looking into what exactly a program is, we will start with first what is an instruction. An instruction is any command which tells the computer to do something. To understand this one, let's have an example. Say, add two variables x and y, display the result, read the file from the disk. Say these are the three instructions or commands. First one, here in this instruction, we are giving command to perform addition of two numbers whose values are placed in variables x and y respectively. Now these instructions are just like our English language commands. Result is equals to x plus y. Next instruction says display the result. If we write using C language, the same will be something like this. That is using printf function. Printf The result is percentile d, the value stored in a variable result. And the next one, read the file from the disk. If we write using C language, the same will be something like this. File pointer is equals to fopen is a function which use two parameters. First, the file name, and the next one is the mode in which we are going to open the file. Here is RB, that is read a binary file. Each of these above instructions are individually, they are commands. So what exactly a instruction is? It is a command given to a computer to perform some task. After understanding what is an instruction is, let's see what exactly a program is. One individual instruction commands the computer to do something. Similarly, next instruction will command to do something else. Like this, if we collect all instructions together which are used to perform a specific task, are simply referred as a program. Formally, if we want to define a program, it is a collection of instructions to do a specific task. It is a sequence of instructions that are interpreted and executed by a computer. Let us understand this one with the help of an example. We want to calculate average of three numbers. Then calculators may not have a direct button or a solution to calculate the average. Then what we need is a program. We need to give multiple instructions to the computer to do these tasks, and it is as follows. Instruction 1. Get first number from the user and store it in a variable A. Similarly, get the second number from the user and store it in a variable say B. Next instruction, get the third number from the user and store it in a variable C. Next instruction immediately says add A, B, C and store the result in a variable sum, which is something say sum is equals to A plus B plus C. Next instruction is to divide the sum, the total, by 3 because there are 3 numbers, and store the result in a variable called AVG. Lastly, once we got average, we are now going to display the average to the user. Now you can notice one thing over here. The instructions, that is from 1 to 6, are used to solve a single problem. These collection of instructions are called as a single program. For one particular task, you will be having one program. Now let's move on to the next point, that is who is called a programmer. Obviously, the person who gives the instruction, that is commands in the form of a program to the computer, is known as the programmer. More technically, we can say a person who prepares coding, that is designs and write the computer program, is known as the programmer. Next, we will move to understand what a programming language is. There are several programming languages available in the software market, and each one is having some or the other feature which makes it unique in their own way. At the end of this section, we will look at the popularity of these programming languages in the software industry and in the academia. Let's see what a programming language is. A programming language is a virtual language or simulated language designed to communicate to a computer using instructions, that is commands, or we can say simply using a program. It is a notation or code used to write programs. Every programming language consists of some vocabulary and set of grammatical rules which are commonly known as syntax for instructing a computer to perform specific task. Each language has a unique set of keywords which are special words that it understands. There are many programming languages in the software market. For example, C, C++, Java, Ruby, Python, C#, to list some of them. Some are compiler based languages and some are interpreter based languages. At the end of this section, we will look at the most popular programming languages for the past 5 decades or so. The graph shows the position of C language, that is at the top at one timeline. And even though it is not at the top right now, but still is considered as one of the all-time popular programming languages ever used by the computer world programmers. For almost all successful programmers in the software industry or academics, C used to be the first programming language they starts with. Even in my case, personally,
I have been teaching several programming languages, but C language is a very special language for me, and I really loves doing programming using C. And I can guarantee the same will be the case with you. So enjoy programming with C as we proceed to learn it in detail. The most popular programming languages ever produced by the software industry, and it is a very dynamic language and has a good feature and easy to understand features. All the best for you to start learning such a great language. That's all for this section. We will continue with remaining topics in the coming videos. Thank you.
Hi, in this section, we will learn about the following. How many different types of programming languages are there? And each type of programming languages with detailed understanding. Let's start with the classification, that is how many different types of programming languages are there. There are three types of programming languages, and these are named: first, low-level programming languages, next, high-level programming languages, and middle-level programming languages. Let's start with low-level programming languages and try to understand what do we mean by low-level programming language. Let's say there are two entities are involved. Say one is computer, that is a machine, and the second one is a human, say programmer. This type of language, which is called as a low-level programming language, are closed to the first entity, that is computer, in the sense it is easily understood or interpreted by computers when compared to programmers. So we can say a low-level language is one which is closer to the machine. It is faster in execution as compared to high and middle level languages. It is obvious how it is faster, since this language is directly understood by the computer machine, so it doesn't take much time to execute it. So it is the most fastest one in execution when compared to other types of programming languages. There are two types of low-level languages are there. One is called as machine language, another one is assembly language. Let's start with machine language. It is one of the low-level languages, and it is completely built up with zeros and ones. Hence, it is also called as binary language as well. This is the only language which is directly understood by the computer. While easily understood by computers, machine languages are almost impossible for humans to use, because the code is completely consists of zeros and ones. So it is a native language, that is inbuilt language for machines. Let's see some examples over here to understand how the binary code will be and how it is difficult for the programmers to understand. For example, say in order to perform addition, the code is 100100001. In order to increment a number by 1, the code is 1101111. In order to move data, the code is 100001111. It is very obvious from these instructions that we can't remember these particular codes every time when we write down a program. Assembly language is same as machine language but uses English-like words to represent individual operations. For example, instead of using binary codes, we will be having symbolic code over here: add, move, subtract, increment. Assembly language uses symbolic codes. So add 100, we have already came across these particular codes, binary codes equivalent for add, move, subtract and increment. Even though it is much easier than machine language, but still this type of language is really difficult or cumbersome or headache when the program is very large. Assembly language contains English-like words which will not be understood by the computer because computer understands only zeros and ones. Then how do
we make computer to understand a program written under assembly language, we required a translator. A translator which can convert an assembly language program into machine language program. So this particular translator which is used to convert an assembly language program into a machine language program is called as an assembler. An assembler is a software which will be converting the assembly language code into binary code. Let's see another category of programming languages, that is high level language. Same two entities, computer that is machine and human that is a programmer. If there is a communication between these two entities, then where exactly the language will be? Language will be closer here in this case to humans, that is programmer, which means that this type of language is much easier or much easy for the programmer to understand and write down the code. So a language which is close to human is a high level language. A high level language is one which is closer to the human. It is easier for human to understand and difficult for machines to process. It is slower in execution as compared to low level languages. When we compare it with low level language, it is much slow because we require translation. It is not directly understood by the machine. Like assembly language, it also uses English-like words, but these words are not symbolic words. We will be calling here as keywords. For example, for, if, else, break, so on. C provides a set of 32 keywords. It is much easier when compared to assembly language. But here also we required a translator to convert a high level language code into a low level language code. Here one of the translator can be either compiler or interpreters. Some of the high level programming languages used in software industry are C, C++, Java, COBOL, Python, Ruby, PHP. There are many to name, some over here. Let's see some sample high level language code. Int main, flower braces starts, flower braces closes. The body of the program will be within this flower braces. Declaring two variables a and b of some integer type. Comparing two numbers a and b. Here a value is 50, b value is 33. So by seeing this code itself, a human can clearly understand what exactly this language is. But for a machine, it will be really difficult to understand what exactly we mean by if a greater than b, printf first number is greater, else second number is greater. So if the condition is true, we are trying to give a message to the user that the first number is greater. Otherwise, we give a message that second number is greater. But how a machine can understand this one? So we required a translator for this. In this particular case, the translator will be either interpreter or a compiler. Let's move on to the last category of programming languages. Same in two entities, machine and humans, that is programmers. Language which fits exactly in between a machine and a programmer is a middle level language. So a language which is closer to both humans as well as for machines. We call it as a middle level language. So a middle level language is one which is closer to both machine as well as humans. A language that has the features of both low level and high level languages. That means that there is a flexibility in this type of language, that if a programmer wants to write down the code in both low level as well as high level, then there is a flexibility available in this type of language. We call it as a middle level language. More formally, we can say we are having a high level language which is allowing you to write down the code of low level programs. So we say it is a middle level language. Here is the most important point. We have seen so many programming languages, but C is one of the language which comes under this particular category of middle level language. That means that using C language, we can perform both the tasks of writing down high level programming language or low level programming language as well. That's all regarding programming languages and the types of programming languages. That's all for this section. The remaining topics we will see in the coming videos. Thank you.
Hi, in this section, you will learn about what is structured programming and what are the advantages of structured programming language. Structured programming is a programming paradigm aimed at improving the clarity, quality, and development time of a computer program by making extensive use of the structured control flow constructs of the selections, that is using if, else, while, for blocks. Now let's see some of the advantages of structured programming language. First, when we divide the program into small chunk of codes, that is functions, it makes programs much easier to read and learn. The reason for this is each function has its own task which is clearly defined. So it makes much easy for anybody to read and learn. Next, see, when we write a program to solve some problem, at every stage of coding, we need to maintain the basic criterias which problem must satisfy. Structured programming helps in easy maintenance of these programs. So you can see over here, some part is difficult to maintain and some are easy to maintain. Structured programming provides easy maintenance. Now, since the code is divided into different functions, there is always less chance of having confusion and ambiguity. Therefore, the complexity is reduced to maximum extent. As the image has lot of wires mixed into one another, which creates lot of confusion, and of course it increases the complexity. So here structured programming tries to reduce the complexity. This is another advantage of structured programming. Application programs are less likely to contain logical errors. There is a separate video on errors and types of errors in which you can see what logical errors are there in detail. Anything which is not so user friendly will always ends up in a mess, or at least you will be frustrated enough and you will definitely not continue with it. But on the other hand, structured programming is very user friendly programming language. Therefore, many new learners feels it very happy and comfortable with C language. Last but not the least, debugging, that is finding and fixing of errors, are very easy because a programmer knows where exactly the problem is, as the code is divided into functions and which function is having error. Okay, these were some of the advantages of structured programming language, and C language is one of the finest structured programming language. That's all for now. We will see the remaining topics in the coming videos. Thank you. Hi, in this section, we will learn about what is program development and execution is, what are the steps involved under program development and execution of a C program. Every program has to go through some stages or steps to finally generate the output. And among these steps, the very first one is the editing one, that is writing a program. A program is written as a source code using some editor. Then the source code is given to the preprocessor directive of C language. The name preprocessor itself tells that this is the step performed before processing or compiling. The details of this preprocessor we will see soon. Then the source code is given to the compiler, that is a system software, to generate the object code. Then the object code is linked with various library files by another system software called linker. Next, the linked object code is loaded into the main memory for execution using a software class loader, or simply called as a loader. And finally, the object code gets executed by the runtime environment of C language to generate the output. So these are the sequence of steps. That is, the first step is editing, that is writing the program using editor. Next step is a preprocessor. Then the source code is given to the compiler called as compilation step. Then linker links the files called as linking phase. Then the system software loader will load the data from disk into main memory. And finally, the runtime environment will execute the program to generate the desired output. Now, let's see this sequence of steps for developing and executing a program in detail. The first one is editing. Editing is a process of writing a program. To write a program, we need an editor. So use an editor to write the program, which is referred as the source code. Once we are done with writing the source code, save the program in a file with .c extension. Now, where do we write the program? We write the program in an editor. There are many editors available for writing a C program. Some of the popular editors are: first, CodeBlocks IDE. We will be using this editor for writing and demonstrating the program throughout our course. There are some other popular editors freely available as a open source software. You can even work on these editors as well, and CodeLite is one among them. And NetBeans is also one of the popular editor you can opt for. Now, next is a preprocessor step. Once we are done with writing the source code, the next step is preprocessor directive. The C preprocessor is a microprocessor that is used automatically by the C compiler to transform your program before actual compilation. It is called a macroprocessor because it allows you to define macros, which are brief abbreviation for longer constructs. It is a system software which resides in between the application software and the computer hardware. The C preprocessor provides 4 tasks. First one is macro expansion. You can define your own macros, which are abbreviations for arbitrary fragments of C code, and then the C preprocessor will replace the macros with their definitions throughout the program. Next one is inclusion of header files. These are files of declarations that can be substituted in your program. Next, conditional compilation. Using special preprocessing directives, you can include or exclude parts of the program according to various conditions. And the final, it removes the comments. As comments are non-executable part of the program, they are just removed by the preprocessor directive before starting the compilation phase. Here you can see both types of comments are used. Now, next is compilation. Now, what is a compiler? A compiler is a system software or a computer program that converts a high-level programming language code, that is the source code, into binary, that is machine code, which consists of binary or hexadecimal instructions that a computer can understand and respond to the user directly. So, given a source code to the compiler, it converts it into object code, that is machine code. Now, next is linking. Let's try to understand what we mean by linking. When the program in the form of source code was being processed into machine code, there are some pieces of program that are out of order based on different type of statements or functions used. Then it is the job of a linker to rearrange and fill in missing pieces or various functions of our program and form it into one single unit. By doing so, the linker will allow our patched up machine code to successfully call functions before it gets executed. So, linker is a system software which links all the related function calls with their function definitions. Once the program is linked properly and the linking process is done, the program has to be executed. And to execute the program, it has to be available in the main memory, which we usually call random access memory, in short RAM. So we need a program which can bring the program from disk into main memory. Then comes loading process into picture. So here load refers to the beginning or executing a program by moving the necessary information from a drive such as hard disk or magnetic tape into the computer's memory, that is primary memory RAM. Now what do we mean by loading?
Loading is the process of moving the program into the main memory for execution from the disk. Loader is a program or a software which initiates the execution of the process. And finally, a loader is a system software that performs the loading function, that is moving the program into main memory. Now, finally, the last step in the program development and execution is obviously execution part, which is the only dynamic process among all the steps involved. The executable code is loaded into memory and then it is executed. It is also referred as runtime process. And the outcome of this step is a .exe file. Let's have a look at the complete process at one glance. We can see here a source code. First step, that is editing. Source code is given to the compiler. Command used is Alt F9. Then if at all any errors are there, that list of errors, again the source code is edited. Once the program does not contain any compilation error, it generates object code. And that object code is given to the linker. Linker links all required header files, and here is the command which is given to the CPU, and it generates the output, that is the runtime environment will execute the program and the desired output is generated on the monitor or screen of the user. So this was all about the program development and execution of a program. That's all for this section. We will see the remaining topics in the coming videos. Thank you.
Hi, in this section, we will look at some of the benefits of C language over other programming languages, which makes C a unique programming language in its own way. Let's start with the first one, middle level programming language. C language provides the flexibility of developing system softwares like operating systems, compilers, linkers, interpreters, debuggers, etc. At the same time, it provides the flexibility and ease of developing application softwares like banking applications, medical applications, database applications, etc. using low-level as well as high-level programming languages. Next, since C provides direct access to machine-level APIs, that is application programming interfaces, which is a software mediator that allows two applications to communicate to each other. This makes C language a perfect choice for scripting applications and drivers for embedded systems like Arduino, Raspberry Pi, etc. For your information, Arduino is an open source hardware and software company, project, and user community that designs and manufactures single board microcontrollers and microcontroller kits for building digital devices. And Raspberry Pi is a series of small single board computers developed in UK by the Raspberry Pi Foundation to promote teaching of basic computer science in schools and in developing countries. Next, some programming languages are case sensitive and some other are case insensitive. C language is case sensitive language. Reason for C language to be case sensitive is C has 32 keywords and the process of parsing and tokenizing will decide the execution time of a program. Because it makes the tokenizer simpler, C language executes faster. This was a strong reason way back when memory and program size was measured in kilobytes. So, uppercase and lowercase are different. All keywords are in lowercase and they cannot be used by the programmer for their own purpose. And all user-defined words can be a combination of both lower as well as upper cases. Therefore, compiler distinguishes between keywords and user-defined words based
on their cases. Here we can see lowercase and uppercase is clearly identified by the compiler. Next, C is highly portable and is used for scripting system applications which form a major part of Windows, Unix and Linux operating system. Once a C program is written on one system and has to be shifted on another platform, as far as your desired target platform has a working C compiler available, you can move your C source code to that target platform by just recompiling it. And moreover, we need not do any modifications in the source code. And nowadays, almost all the target platforms has a C compiler available easily. C is considered as a highly portable language, and C is a general purpose programming language which can efficiently work on enterprise applications like ERP packages for large databases, gaming applications. Most of the early days of Windows operating systems, games were developed using C language, and graphics design used in many screensavers and supporting applications. And of course, applications requiring calculations of some accounts or mathematics can be easily developed using C language. And the most important feature or benefit of C is the ability to divide the program in the form of functions, which makes C as one of the powerful structured programming languages. A separate video is available which gives the details about structured programming languages and their advantages. There are some other minor benefits are also there which we have not included in our discussion here. So the benefits what we have seen, we will be just summarizing it. We have started with as C is a middle level programming language. That means that it provides both the flexibilities of low level as well as high level language. Next, C is case sensitive language, as well as it provides direct access to machine level APIs, and C is highly portable and it is a structured programming language. These are the common benefits or advantages of C language. That's all about the benefits of C language. Remaining topics are covered in the coming videos. Thank you. Hi, in this section we will learn about three different types of system softwares, that is assemblers, compilers and interpreters. Initially, we will see what do we mean by source and object code is, what language translator is, and how many types of language translators are there. And at the end, we will look at the difference between compilers and interpreters. Let's try to understand what is source code and what is object code is. The set of instructions written in any language other than machine language is called as source code. Here, any language means programming language either from higher level language or lower level language category. Let's see object code. The set of instructions written in machine language is called as object code. It is also called as machine code. Now, source code is not directly understood by the machine or computer since it is not written in machine language which computer can understand. On the other hand, the object code is the only code which is directly understood by the machine. Now, after understanding what is source code and object code is, let's see some of the differences between source and the object code. First, source code will be always in the form of text, whereas object code will be in the form of zeros and ones. Mostly, source code is written using higher level language, therefore it is easily readable by humans, whereas object code is generated by language translators. It is machine readable. It is generated by humans, that is programmers. So we as a programmer create a file, that is either .c extension or .java extension or .cpp extension. So this is called as source code file. So it is generated by a programmer, whereas object code is generated by language translator. Lastly, this is the input to the language translator. That means we give the source code as an input to the language translator, whereas it's exactly opposite in the case of object code. That is, this one is the output of the language translator. Now we came across a terminology while seeing the difference between source code and object code, that is a language translator. Then who is a language translator is? As it is clear from the image, which shows the dual role of a person in the middle trying to listen from person on the left and convey the same to the person on the right. This shows the part of a language translator is trying to understand something from the person who is sitting on the left and trying to convey the same message to the person who is sitting on the right side. That is the role of a language translator. So a language translator is a program or a software that converts the source code into the object code. Left hand side person is a source code, right hand side person is a object code. Let's say the input that is given as a source code, which takes input as a source code and convert it into object code. So here is the role of a translator. It converts it into object code. Then why we need a language translator? As we know, computer only understands object code, that is machine language, and the programs are written using high-level language like C or C++, Java. It does not understand that source code. There must be a program or software that converts source code into the object code so that computer can understand it. And this task is done by language translators. We as a programmer writes the source code and then translator converts it in machine readable format, that is object code. Let's see how many types of language translators are there. There are 3 types of language translators, and these are assembler, compiler, interpreter. First, let's try to understand what is an assembler is. An assembler is a software that is, for us, it is the language translator that converts assembly language code into the object code. So assembly source code, that is a program written under assembly language, is considered to be assembly source code, is given to the translator, that is assembler, as a system software. It converts it into object code. Examples: currently available system software which is popularly known, which is Keil's A51. Now let's see what is a compiler is. A compiler is the language translator that converts high-level programming language, that is source code, into the object code. It converts the whole code at a time. What do we mean by this one? Let's try to understand this. But before this, let's see what compiler does. Given a high-level source code to the compiler as a language translator in the middle, it converts it into the object code. Example compilers: Turbo C, Borland C, GCC are some of the common compilers for C language. Here is the example. Let's try to understand how a compiler works. Let's say these are the instructions. Then this program is given to the compiler. Compiler reads the whole program. Then it converts the whole program into the object code at once. Then object code gets executed. These are the sequence of steps to be followed. First, reads the program, that is whole program is read at a time. Convert the whole program into the object code. Then last step is to execute that object code. On the other hand, this is also one of the language translator which converts high level language into object code. But the difference and the most important point to be noted regarding interpreters are it converts the code line by line. Similar as compilers, interpreter takes high-level source code as input, and as a language translator in the middle, it converts it into object code. Some of the popular interpreters used nowadays are Ruby, Python, Perl, etc. Let's see how interpreter works. Same set of instructions, if it is given to interpreter, what it does? It reads line number 1 first, that is first instruction, which is written at line number 1. It converts it into the object code, executes it. Then read line number 2, convert it into object code and execute it. Read line number 3, convert it into object code and execute it, and so on till the last line the same procedure is followed. Now, at the end of this section, let's see the differences between compilers and interpreters. Compilers. It converts the whole code at a time. We have seen the example. It converts the code line by line. It is faster in execution, whereas interpreters are slow when compared to compilers. But when compared to memory, compiler requires more memory, whereas interpreter takes less memory. Errors are displayed after the entire program gets compiled. So we may be getting, say, for example, 100 errors or 20 errors or 15 errors as a whole. But interpreter, what it does is, whenever an error is encountered, it will not go to the next line unless and until that error is removed. So errors are displayed for every instruction which is interpreted. Examples of compilers: C, C++, Java, compiler based languages. These are interpreter based languages. That's all regarding compilers, assemblers and interpreters. We will see the remaining topics in the next section. Thank you.
Hi, in this section, we will learn about what are bugs or errors, how many types of errors are there, and at the end, what is debugging and how to debug. It is a harmful microorganism, typically bacterium, a small insect. In computer terminology, a bug is a coding error in a computer program. Let's define it formally. An error or defect occurred inside a computer program or hardware that causes it to produce an incorrect or unexpected result, or to behave in unintended ways, is called a bug. Most of the bugs arises by the mistakes and errors done by the programmer in source code. The term bug was used by Grace Bristow Murray Hopper was an American computer scientist and United States Navy Rear Admiral, one of the first programmers of the Harvard Mark I computer. She was a pioneer of computer programming who invented one of the first linkers, that is a system software. She popularized the idea of machine-independent programming languages, which led to the development of programming language like COBOL in the early days of high-level programming languages, which is still in use. Hopper used to work on Mark I and Mark II computers. There, some error occurred in the system that caused the error. The cause of the error was a moth, that is a bug, was trapped in a relay creating short circuit. That caused the term bug to be coined. Let's now see how many types of errors are there. Generally, we classify the errors into three categories: syntax errors, runtime errors, and logical errors. For a program to execute, there are two phases. One is compilation phase, another one is runtime, that is execution phase. Syntax errors occurs at compilation phase and runtime errors occurs at execution phase. Let's see in detail what exactly these errors are. Let's start with the first one, that is syntax errors. In computer science, a syntax error is an error in the syntax of a sequence of characters or tokens that is intended to be returned in compile time. A program will not compile until all syntax errors are corrected. Example, say missing semicolon. If any one of the C statement misses one semicolon, then one error will be there at compilation time. A variable which is not declared and used in a program, missing some parenthesis, will be some common syntax errors. Let's see the example of syntax error. Here is a program
in which a variable a is initialized here to 0, which is a compile time error, because here a is not defined but it is used in the program. So at the down we can see an error at line number 6 which says undefined symbol a. This type of errors are generated at compilation phase, that is at compilation time. Let's see the second type of error, that is runtime error. A runtime error is a program error that occurs while the program is running, that is executing, that is at the second phase, execution phase. Some of the common runtime errors. First one, invalid memory access during runtime. What do we mean by this one is, when a programmer tries to access a memory which is not currently available, say usually we call this one as a dangling pointers. When we come for pointers, we will see in detail about this type of problem. Second, trying to access the incorrect memory address. Divide by 0. Usually when we divide a value with 0, a undefined value is there, that is infinity. So this particular type of error is also called as a runtime error, and these errors are generated at execution time. Let's see the last category of errors, that is logical errors. A logical error is a mistake in a program's source code that results in incorrect output. It is a type of runtime error, a special form of runtime error that may simply produce the wrong output or may cause a program to terminate abruptly or to crash while running the program. Many different types of programming mistakes are there that can cause logical errors. It is a programmer's mistake by which a logical error occurs. Logical errors are the hardest to find and fix because it is not identified at compilation phase. So compiler does not detect these type of errors. There is no indication of error when the program is executed. That means at execution phase also there is no such error. The program may produce correct results for some input data and may produce wrong results for some other input data elements. That means that if you provide some input data elements to sort for a sorting program, that may sort the data correctly, but for some other input values it may produce a wrong output. So that is nothing but a logical error, and it is the most difficult error to find. Example, we are trying to delete an element from an empty array. Since an array does not contain any single element, but still we are trying to delete an element, it is one of the logical error. Let's see the last topic of this particular section, that is debugging. How to remove the bug. It is the process of finding and fixing the bugs in the program. So where exactly the problem is, where exactly the error is there in the program, let's try to find out it and let's try to remove that problem or solve the problem, is a process called as debugging process. It is the process of removing errors. Simply identify where exactly the problem is or error is, remove that one. The programmer manually does this by examining the source code with the help of some tools, or you can say system softwares, which are something referred to be as debuggers. Commonly used debuggers are GDB, that is GNU debugger, used for Unix and Linux operating system, and advanced debugger is also a debugger for Unix operating system. These are some of the commonly used debugger tool, that is a system softwares. That's all regarding errors, bugs and debugging. We will see the remaining topics in the coming videos. Thank you.
Hi. Before learning any programming language, it always gives satisfaction when we know some background about that programming language. Let's have a brief history of C language. The first thing that comes in our mind is who developed this language, which we are going to learn. That is the first question. Here, he is the person who developed C language, and he is Dennis Ritchie. C was developed in the year 1972. Dennis Ritchie developed this language while working at AT&T Bell Laboratories, US. The name C is
unusual name for any programming language, but it is a successor of B language, where B is a successor of BCPL. BCPL stands for Basic Combined Programming Language, developed by Martin Richards in 1966, followed by B language has taken some features of BCPL, where it was very difficult for a programmer to do some programming in BCPL. So Ken Thompson and Dennis Ritchie developed B language, extracting some features of BCPL, or you can say it takes almost the same syntax of BCPL. Both BCPL and B language are typeless languages. They does not provide any data types. So it's really difficult for the programmers to do the programming. Dennis Ritchie worked out on the loopholes of B and BCPL languages and developed a language and named it as C language. C language has a variety of data types. Unlike B and BCPL, those are typeless languages. This provides variety of data types such as char, int, float, double. These are basic data types provided by C language. Some other data types are also there, which we will be learning in details when we come for data types. Here is the hierarchy from where the language C is developed. As we have already seen that traditional C that is developed by Dennis Ritchie in the year 1972, then followed by in 1978, Ritchie worked with Kernighan and added some more feature and named it as KNRC. After many years of working, for many years, the definition of C was the reference manual in the first edition of C programming language. At last, in 1989, the American National Standards Institute established a committee to provide a modern, comprehensive definition of C. The resulting definition, the ANSI standard, combined with ISO committee, is developed in 1990. The most recent standard of the C language is C18. That is the most recent standard of C programming language, which is preceded by C11, which was developed in the year 2011. This is the current latest version of C language we are going to work out with, that is C18. That's all regarding a brief history about C language. We will be looking at the different concepts in the coming videos. Thank you.
Hi, in this section we will see what are keywords and identifiers in C language. There are two things we are going to concentrate here. What are keywords and identifiers, and how to name the identifiers in C language. First of all, let's try to understand what do you mean by keywords. Keywords are reserved words used in any programming language whose meaning is already known to the compiler or interpreter used by that language. Keywords are part of the syntax, which means that they cannot be used by the programmer or user for their own usage. For example, let's see this statement, int quantity. This statement tells the C compiler that quantity is of type integer, and here int is a keyword. That means that the meaning of int is already known to the C compiler. Then immediate question that how should we know which one is a keyword and which one is not? C provides many keywords, and the list of keywords in C language are here. You can see there are total of 32 keywords provided by C, and int is one among them. As we proceed to learn, we will come across all of these keywords in the coming sections one by one. But here, I'll give a brief details about few of them. Like the first one is auto. It is one of the storage classes provided by C language. Break is one of the keyword which is used to terminate the loop based upon certain conditions.
So it is used mainly in iteration, that is in loops. Similarly, we have here char, float, long, int. Many data types are here and some are used as, say for example, size of is one of the operator in C language. In the coming section we will see in detail about it. This is regarding keywords in C language. Let's move on to identifiers. Identifier refers to the name given to entities such as variables, functions, structures, union, arrays, etc. Identifiers must be unique, means that they are created to give a unique name to an entity to identify during the execution of the program. For example, here are the two declarations, say int quantity, float salary. Here quantity and salary are the identifiers and float and int are the keywords. Can I give any name for the identifiers I wish? No, you cannot give as you wish for the names of the identifiers. Then what are the rules we should follow it to name the identifiers? Here are the rules to name the identifiers. Very simple rules are there. Here is the first one, that is a valid identifier can have letters, that is both in uppercase capital letters and lowercase, that is small letters, digits from 0 to 9 and underscore it can contain. The first letter of an identifier should be either a letter or an underscore. This is mandatory, that is you cannot have anything else to start with, that is either a special character or a numerical value. We cannot have it as the first letter to name the identifier. We cannot use keywords, obviously. Keywords we just came across, the 32 set of keywords provided by C language. We cannot use it for our own purpose, that is to give it the name of an identifier. And the last one is, there is no such rule how long the name should be of an identifier, but we may get into some problems if the identifier name exceeds 31 characters. Some compiler doesn't support more than 31 characters, some compiler supports more than 31 characters as well. Let's see some example identifiers and verify whether they are according to the rules what we just saw. Among the list of identifiers here, some are valid and some are invalid. By seeing this, can we tell which one is valid and which one is invalid? The first one is valid, second one is valid, whereas the last three are invalid. The reason, very simple one, the first one doesn't have any special character within it and it's starting with the first one as a character, letter that is, and there is no special character within it, there is no space also. Second one is also valid because it uses one underscore within it, total underscore sales. Whereas the third one uses a dot as a special operator or special symbol, which is not allowed. Fourth one is not valid because it starts with a number, numerical value. And the last one also uses a special character. That's all regarding keywords and identifiers. Remaining topics we will see in the coming videos. Thank you.
Hi and welcome to the practice program using keywords and identifiers in C language. As we have already covered the concepts of keywords and identifiers in the earlier video, where we have seen there are 32 keywords provided by C language which cannot be used as a identifier in your program. So here this program is going to demonstrate and make use of clear distinguish between what exactly a keyword is and what exactly an identifier is. Here these are the identifiers which are used in our program. Say quantity is the name of the identifier. Is it a valid identifier? Yes, it is perfectly valid. Another identifier I am trying to use as a variable here as else, but else is not an identifier. Else is a keyword in C language. So I cannot use this particular one, but intentionally I am declaring this one here, so that let us try to see what exactly compiler says about it. Same variable name, I am trying to assign some value, say 100. This is the first keyword, else I am trying to use it as an identifier. And the second one is here. An identifier should not start with a numerical value, that is a number. So here identifier should not start with a digit, that is the comments what we have written over here. And the remaining things, that is another identifier, my code number 2 is a valid identifier, because number can be at the middle or number can be at the end of an identifier. Then we have EMP number followed by dollar symbol is a perfectly valid identifier. Then total underscore sale is also a valid identifier. And I am declaring another identifier with a set of 28 characters. I can provide a maximum of 31 characters to give the identifier names, what we have seen in the rules for declaring an identifier. So here, say for example, a bank account number is there which is going to store some large value. That's the reason we have declared it over here long. And even the name of an identifier itself is very long here. Number of characters are more. Intentionally, one more time, we are trying to declare a keyword break as an identifier. We are trying to use it as a variable. And let us try to declare here. So two keywords, one is else, another one is a break, what we are trying to use it as an identifier. The remaining all other are valid identifiers. And we are trying to assign some values here for quantity and underscore my code number. Underscore my code number is also perfectly valid because an identifier can start with underscore. Numerical, that is digit, you cannot have it, so it's an invalid one. This is a perfectly valid assignment, this is perfectly valid one, this is also perfectly valid one. What about this salary? No problem with this one as well. So we are trying to print the values here using this identifier names. Quantity is using quantity, perfectly okay. Salary using 0.2, that is precision value. 2 digits you want to print it after a decimal value, that's why here 0.2f is used. Then underscore my code number is a perfectly valid identifier. Here you will have a problem with this statement because it's using 1 as a digit. And here also we will have a problem because we are using a break. Okay, so this is just to demonstrate how exactly we can use identifiers and keywords. Let us try to build and check for the errors. Here what it says at line number 10 is expected identifier or parenthesis before else. This means that else is not an identifier. It's a keyword, you cannot use it for our own purpose. I'll comment it now. Wherever else is there and the usage of else is there, now I'm commenting it. And let us build once again to check the next error. Here is the next error at line number 14. You can say exponent has no digits, so it should not be started with a digit. I'll comment this part. I'll continue again and build. Let's see, the next error is at break. At line number 19 you can see expected identifier, so this is also not an identifier. I'll comment again this part wherever it is used. So this one, let's compile it once again, and here you can see cannot have digits. And let us comment those statements which are using these identifiers. One employee number, that is I have commented, and break again I have commented it. Let's try to build and check for errors now. Here you can see there are no errors and no warnings, 0 errors and 0 warnings here. Perfect. So this means that the keywords which are used by the C runtime environment, we cannot use it in our program as an identifier. Let us run and check the output. Here is the output what we are trying to print. The value of quantity is quantity value what we have assigned over here is 500, so we are getting an output 500 here. And salary is 0.2, that is a precision decimal point. After decimal point we are getting only 2 digits because of this 0.2f. If we don't give this 0.2f, what will happen, that also we will see. I'll just remove that 0.2f and show you. And the remaining output, you can see the remaining outputs. Okay, that's perfectly working with keywords and identifiers. Let's remove this 0.2 and run and check the output now. You can see here we have assigned 0.50 here and we are getting the output as 0.500000. These many number of zeros, you want to truncate it, then we have already used here 0.2. So this is just a program to demonstrate how exactly keywords and identifiers are used in C language. That's all for now. We will see the remaining topics in the coming videos. Thank you.
Hi, comments in C. In this section, you will learn about first thing, what are comments, how many types of comments are there in C language, and importance of using comments. Comments is a very small topic in programming language like C, which has many features. So comments is a very small topic comparative to other topics, but it has its own significance. Let's start with the first thing. What are comments? See, when we write a program as a programmer, we have options that we can write down a program in a indented manner, well documented manner, or we can directly type the program. C supports or C allows you to write down a program without bothering about how many spaces you have given and without bothering about another statement is coming immediately after one statement. So you need not worry about each and everything, the where exactly the line is going, is it properly placed exactly below that line or not. Say for example, if anybody is having some programming background, if at all, if condition has to be checked. If condition true, then execute some set of statements, else it will have else. So I can place else up immediately after the statements. That is not a good practice of placing the code in its proper margining one. Say for example, if I am placing it in an indented way, so else will be immediately placed exactly below the if. Same way, if there is a block of statements to be executed, even though C supports non-indented version of program to be executed and gives the same result, it doesn't give a wrong answer. You can see desired output, whatever we are expecting, the same output you will get it. But a programmer is a good programmer who always practice to write a well indented program and well documented program. So it makes a program more readable and error finding becomes easier. When we are able to read the program clearly, then we can able to find out the errors also very easily. So debugging will become much easier. One significant amount of having good documentation is comments. So comments makes a program to be well documented one. In programming, what exactly we mean by comment is whatever a programmer wants to tell or explain regarding the source code, what he has written. Say for example, I am a programmer. I want to solve a problem of finding whether a given number is a prime number or not. There might be many techniques to find whether a given number is prime or not. So which technique I am following it, how I am solving the problem. If I give each and every line comments that this line is doing this particular task and second line is doing this particular task, third line is doing this particular task, so on, the loop is executing for these many number of time and it is terminating after the condition satisfies. So using that description and explanation written by myself will help me to understand the source code very easily. So it is the explanation or annotation in the source code of a computer program. Comments are those statements which are simply ignored by the compiler. Let's see how many types of comments are there in C language? There are basically two types of comments supported by C language. First one is a single line comment and second one is multi-line comment. Single line comment will be starting with two double slashes. These are forward slashes. Any text which continues after those two slashes will be simply ignored by the compiler. It is treated as comments. And in multi-line comments, you have starting and ending notation is given. One with slash star, which indicates the starting of comment, and whatever text you give it after this slash asterisk will be treated as comments and will be ignored by the compiler, and the ending point is asterisk slash. Let's see the importance of using comments. As I said earlier, it is a very small topic, but it has a very significant role in the programming language. Writing comments is a technique to make a code more readable by providing more description. Obviously, you give description about the program, it becomes more readable. So this is a technique using which you can make your program more readable. It can be read by anyone. As a end user also it can be read. Comments can include a detailed explanation of a program to make the code more understandable. So as you provide the code, that is non-executable code, where you can provide your detailed explanation by reading which anyone can easily understand your program. If I am writing a very large program, so once I get the logic, I'll start continuing writing the program. But as I'm getting the ideas, I'll be writing down the program. But anyone sees the program will be getting confused if there is no explanation provided over there. So comments will help you in clearly understanding and getting back the old, or you can say clicking the same ideas once again. Yes, that is the logic of what I have used it, then what this line is doing, and what this loop is doing, and what about the function call and how many times I am calling it, each and everything. That's all regarding comments. We will see the next topics in the coming videos. Thank you. Hi, welcome to the demonstration session of comments. As we have seen that there are two types of comments C language supports. Earlier versions of C supports only one type of comment, that is multi-line comment, that we have seen it starts with slash and asterisk and ends with asterisk and slash. Here is the first one, is a multi-line comment. The text, as many number of lines you want, you can give it over here. The message what we have given over here is to demonstrate the usage of comments in C language. Both the types are demonstrated in this particular program. This one is a multi-line comment. We can give description for each line in a program. Let us see the varieties in which we can specify these comments. First one, hash include, is a single line comment. We are saying that it is a preprocessor directive. What exactly this one is a main function. Let's say what exactly this first line is doing. We are declaring an integer variable, and the variable or identifier name used is age, which is of type integer. Printf function, what it is doing, we are giving a comment over here that it is used to prompt a user with a message. Here single line comment is used, here also single line comment is used. Here also we could have used a single line comment, but you can even use multi-line comment also. Here you can see comments are used inside a printf statement. Let's build the project. You can see there are no errors, no warnings. Let's run. Program is asking for the age. Enter the age. You can see here there are many lines in the program, even though these text which are placed under comments are not executed. They are just ignored by the compiler during execution. Let's enter the age. Say for example, age is 30. That is a message what we are giving it over here. And you can see your age here will be displayed. Age is 30, that is displayed over here. So that is a comment for a user.
Let's quickly recollect the things what we have seen in this session. There are two types of comments C language supports: single line comment and multi-line comment. Multi-line comment can also be used as single line comment, like here in main function we have used, but single line comment cannot be used as multi-line comment. That's the difference. And one more important thing what we need to make a note over here is comments cannot be nested. A comment cannot be placed within another comment. These are the things what you need to remember about comments, and provide as much comments as you want in your program. That makes your program more readable. So it will give you a clear idea what exactly the code is written for. If at all any logic is there, if at all any declaration is there, if at all any message is there for the user can easily understand, whoever is seeing your program can easily understand what the code is doing. This is regarding comments in C language. The remaining topics we will see in the coming videos. Thank you.
Hi, in this section, we will learn about what a variable is and what are the rules for naming a variable, what are literals and how many literals are there in C language. And at the end, what do we mean by constants and how to create constants in C. Let's start with variables. A variable in simple terms is a storage place which has some memory allocated to it. Basically, a variable used to store some form of data. Different types of variables require different amounts of memory and have some specific set of operations which can be applied on them. To indicate which storage area they belongs to, each variable should be given a unique name. Variable names are just the symbolic representation of a memory location assigned. Here you can see scanf is a function to read the input. A value is given by the user which is stored in a variable, and printf function can use the same variable to display the output. To indicate which storage area they belongs to, each variable should be given a unique name, that is an identifier. Variable names are just the symbolic representation of a memory location assigned. For example, int score equals to 50. Here in this declaration, score is a variable of type integer and it is assigned a initial value 50. Now, this value of a variable can be changed at any stage of the code in the program. Hence, they are called as variables. Let's see the rules for naming the variables. A variable name is any combination of alphabet sets, that is A to Z, digits 0 to 9, or underscore. The first character of a variable must be an alphabet. There should not be any commas or blank spaces in between the name of a variable. No special symbol other than underscore is allowed in a variable name. Example, first underscore name, employee underscore number, etc. Although the names of the variable can be anything which satisfies the just now said rules, but we should always try to give some meaningful names to the variables. For example, first name is always better than giving f name or fn or first n. C language is strongly typed language. What do we mean by strongly typed is? Let's understand with the help of an example. Int number equals to 5, that is an integer variable. Number equals to 5.5, double number. Here, a variable named number is declared and assigned a value of type integer, and when we try to assign 5.5, which is a real value, that is float, we encountered an error on this particular line number. And moreover, the same variable name cannot be used again in the same program to be declared for another type. This is another error. Based on the concepts or the information what we have regarding variables and the rules what we have seen
regarding the naming of the variables. Let's see some variable names and try to find out whether they are valid or invalid variable names. Variable names. First one, underscore value, star value, student underscore ID, student, student with dollar symbol at the end, $A, and the last one is 123 student. Let's see the first one. Yes, just now we have seen the rules that underscore can be given in a variable name. So it is a valid variable name. If a variable name is starting with asterisk, is it valid or invalid? It is invalid, because variable name should always start with alphabet, or we can use underscore. Next, student ID is a perfect valid variable name because underscore is allowed. Only student without any digit or any special character. Dollar symbol is not allowed. Same case, dollar symbol is used. And last one, 123 student. These are some of the examples. Let's see what do we mean by literals in C language. A literal is an identifier or a value which cannot be changed in a program. For example, 1 is an integer constant, 10.4 is a real constant or floating point constant, a single character is a character constant. 1 is an integer literal, 10.4 is floating point literal, a is a character literal. Let's see different types of literals in C language. Integer. An integer is a numerical literal without any fractions or exponential part. There are 3 types of integer literals in C language. For example, decimal with a base 10, octal with base 8, and hexadecimal with base 16. Here are the example. Any decimal value, say 0 is a decimal value, minus 9 is also a decimal value, negative but it is a decimal one, 22 positive integer, it is also a decimal one. Any number which starts with 0 is an octal number. Hexadecimal number starts with 0x. Then we have floating point literals. A floating point literal is a numeric literal that has either a fractional form or an exponent form. For example, negative with decimal point 0, 0.00000234, and the last one is using e minus 5. So you can make a note here, e minus 5 is nothing but 10 to the power minus 5. If it is 10 to the power plus 5, we should write it as e plus 5. Then the last one is a character literal. A character literal is created by enclosing a single character inside a single quotation mark. For example, small case a, uppercase a, or even a number with apostrophes is also considered as a character literal. Sometimes it is necessary to use characters that cannot be typed or has special meaning in C programming. For example, new line character /n. We want to print the contents into new line, /n can be used as a special sequence, that is escape sequence. If you want to give 8 character space between the output of some text, /t can be used, and similar to that question mark /? can be used. These are the escape sequences provided by C language. Backspace /b, form feed /f, new line /n. There are 2 types of tabs are there. We can give horizontal tab, that is 8 characters horizontally, vertical tab 8 characters vertically, backslash, double backslash over here, single quote, double quote, and question mark. These are 9 escape sequences provided by C language, and they are very useful in performing a documented output or displaying a formatted output. Last one is string literals. A string literal is a sequence of characters which is enclosed in a double quotation mark, whereas a character literal is placed under single quotation mark. Here is double apostrophe or double quotation mark. For example, anything that can be placed. First one is hello, is a string constant. Second one, nothing is there, only double apostrophe is there, so we call it as null string constant. And we can see the next one is having some spaces. 6 times we have pressed space bar, so it is a string constant with 6 white spaces. Next one is a string constant having a single character, small a. And last one, prints string in a new line using a new line character, that is /n. And now the last topic of this section is constants. If you want to define a variable whose value cannot be changed, we can use the keyword const in a program. For example, const float, a variable name assigns some value. We know that pi value is never going to change in the program, so declare it as const so that a programmer accidentally also cannot change the value. Note that when we have already declared a variable as const, we cannot alter the value. Here you can see the error. Another type of constants C language supports is using hash define. It is a preprocessor directive. It is one of the preprocessor directive. For example, same thing what we have declared using const can also be declared using hash define. Then what is the difference between const and hash define is? The big advantage of const over hash define is type checking. We can also have pointers to const variables. We can pass them around, typecast them, and any other thing that can be done with a normal variable, we can perform it using const variables. So in general, const is a better option if we have a choice between const and hash define. This was all about variables, literals, and constants in C language. That's all for now. We will see the remaining topics in the coming videos. Thank you.
Hi, in this section we will learn about what do we mean by data types. Next, how many types of data types are supported by C language. Let's start with the first topic of discussion, that is, what does data type mean? The data type of a value or variable is an attribute or property that tells what kind of data that value can contain. Data types include the storage classifications like integers, floating point values, characters, strings, etc. Data types define particular characteristics of data used in software programs and informs the compiler about predefined attributes required by specific variables or associated data objects. Now move on to see different types of data types which are there in C language. Data types are broadly classified into 3 categories. First one is collection of data types called as primary data types or basic data types. Then the remaining 2 categories are advanced data types. First one is user defined data types, contains enum, that is enumerated data type, and type def. Next, derived data type consists of pointers, arrays, structures, and unions. Let's see what do we mean by primary data types. There are 4 primary data types supported by C language. Character, which can be of signed character or unsigned character. Float can be of 3 types: float, double, long double. Integers can be of these many types: simply int, long int, unsigned long int, long int, unsigned long int, short int, and unsigned short int. We will see what exactly the memory spaces occupied by all these data types and what is the difference between signed and unsigned. What is the difference between signed short and unsigned short? What is the difference between short and long? Each in detail when we come for the next topic. And the last under primary data types is void. This is just the introduction part of the data types. That's all about the introduction regarding the data types.
and their classifications. We will see the detailed explanation about data types in the next video. Thank you. Hi, in this section, we will learn about what are basic, that is primary data types in C, and how much memory space these data types occupies. Now, let's start with knowing what are primary data types in C language. First one is int, that is an integer data type which can store a number without decimal point, and it has its range, and the range of the data types are discussed at the end of this section. Let's see the example. This declaration declares an integer variable with name age and assigned with a value 20. If nothing is assigned by the user, then a garbage value will be initialized to a variable. So in this declaration, int is a keyword, is a data type which tells the compiler that age is going to store an integer value in the memory, and appropriate memory location will be allocated in the memory space by the runtime environment. Next, we have float data type which can store a floating point number, that is with a decimal point. Similarly, double can store a floating point number but has a range other than float. Similarly, character can store a single character in it. Void means nothing. Now let's see in detail how much memory space these primary data types in C language occupies. First one, signed character. Character can be of two types. Either it can be signed or unsigned. Character occupies always 1 byte. The size of the data types, what we are discussing over here, is with respect to 16-bit compiler. If it is 32-bit compiler, then the sizes will be and the ranges will be different. So let's start with the first one, signed character or unsigned character. Both, first and second one, occupies 1 byte, that is 8 bits. 8-bit means it will be 2 to the power 8. 2 to the power 8 value will be 256. So if it is signed one, that means negative sign as well as positive sign. So 256 is exactly divided into two parts. Minus 128 to plus 127 will be the range of values what a signed character can store. Whereas an unsigned character, there is no negative sign allowed here. That's why all 256 bits will be for one character. Short signed int, wherever signed comes, it will be both negative as well as positive. So we see here with a simple example again. Say integer takes 2 bytes. So 2 bytes means here 16 bits. 16 bits, take that 16 bits, make it as 2 to the power 16. That results into 256 into 256, 65536, that is 65,536. You divide it by 2, you will get it as 32,768 with negative range, 2 plus 32,767. This is the range of short signed int. Same way, if it is unsigned one, simply 0 to 65,535. And if we say it is only int, by default it is signed int only. So the default value will be signed int. If you want to specify negative values, then you just give it as int or signed int. If we don't want negative values to be included, that is negative range to be included, then declare it as unsigned int. Same case for char also. Float occupies 4 bytes, double occupies 8 bytes, double the range, and long double occupies 10 bytes. And at the end, last column over here specifies the format specifiers for accessing these data types. First one is to access a character, let it be signed or unsigned, percentile C is used. For accessing signed integers, percentile D is used, whereas for unsigned integers, percentile U is used. For long, percentile L is prefixed before either D or U. So it is percentile LD for long signed, percentile LU for long unsigned. Similarly, for float, percentile F, for double LF, and for long double, it is a case sensitive, C is a case sensitive language. We can clearly make a difference over here. So capital L is for long double and small l is for only double. This is the range of the primary data types in C language. When we come for advanced topics, we will see the remaining data types, that is user defined data types as well as derived data types also in detail. That's all for this section. We will see the remaining topics in the coming videos. Thank you.
Hi, in this section we will see the demonstration of primary data types used in C language. Here is the program. We are using all primary data types supported by C language. First one is int, short int, long int, long int, signed short int, unsigned short int, unsigned int. Then we have categories of character data types: char, signed char, unsigned char. Then we have float, double and long double. Here we are trying to see how much exactly the memory occupies by each data type. Here we are using size of operator to know the size of each data type. First one, int occupies percentile D. Size of operator is an operator which returns the size of a given data type. Size of is an operator which returns the number of bytes occupied by a variable for a specific data type. Let's build this. See the logs, no errors, no warnings. Let's run the program. Int occupies 4 bytes. Now, when we have seen the discussion of primary data types and its sizes, we have seen int occupies 2 bytes, that is for 16-bit compiler. And we are executing this one on a 64-bit compiler machine. So here, on a 64-bit operating system, integer occupies 4 bytes. Even signed integer also occupies 4 bytes. Now if you see the difference here, short int occupies 2 bytes, whereas there in 16-bit compiler, both int as well as short int occupies 2 bytes only. Long int occupies 4 bytes. Long int occupies 8 bytes. Signed short int, or simply you call that one as short int, occupies 2 bytes. As well as unsigned int also takes 2 bytes. Any type of character, let it be signed or let it be unsigned, occupies 1 byte. Float occupies 4 bytes. Double takes 8 bytes. Long double takes 12 bytes. If you see here, we are using /n/t as escape sequences. /n is used to display the data in the next line. /t takes 8 character space. That's all regarding primary data types. We will continue with the remaining topics in the coming videos. Thank you.
Hi and welcome to the next online coding challenge on HackerRank. In the last challenge, we have completed displaying a character, a string and a sentence. Let us proceed further to the next challenge. I am clicking on next challenge. Here is sum and difference of two numbers. Here is the fundamental data types in C: integer, float and character. Now we are going to discuss about this integer and float data type. Printf function prints the given statement to the console. Syntax, we know the syntax for printf and scanf, so let us directly jump into the task. Your task is to take two numbers of integer data type and two numbers of float data type as input and output their sum. So we need to declare totally 4 variables, 2 of integer type and 2 of float type. Read 2 lines of input, that is 2 for integers and 2 for floats. Use plus for performing addition and minus operators to perform the following operations: sum and difference of two integer variables, sum and difference of two float variables. Rounded to 1 decimal place. Here is the most important thing. Rounded to 1 decimal place. That means that if I am printing the value, say 2.0 plus 4.1, so the result should be 6.1. Actually, if you don't display using format specifier, it will be printed like this. So it should be truncated to only 1 decimal place. Only 6.1 should be placed. If you say 2.0 plus 3.0, result will be displayed as 5.00000. We should not print all these zeros, just consider 5.0. That is the meaning for this rounded to 1 decimal place. The input format: first line contains 2 integers, second line contains 2 floats. Here is the constraint: integer should be in the range of 1 to 10 to the power 4 and float should be in the same range. The output format is print the sum and difference, both integers separated by a space. Both should be separated by a space on the first line, and sum and difference of the both floats scaled to 1 decimal place should be separated by a space on the second line. So here is the output. Sample input: if we provide 10 and 4, 4 and 2, then 10 plus 4 is 14, 10 minus 4 difference is 6. Similarly, 4.0, 2.0, summation is 6 and difference is 2.0. Sum of two integers, difference of two integers. Sum of two floats, difference of two floats. Here is a brief explanation here. When we sum the integers 10 and 4, we get the integer 14. When we subtract the second number 4 from the first number, then we will get 6. Similarly here. So let us see how we can solve this challenge. Let us proceed further. First of all, identify how many number of variables are required. Here we required 2 integer variables and 2 variables to store sum and difference. So I'll say sum of integers, difference of integers. Similarly, we required 2 float variables and sum of float, difference of float. Now once we have declared the required variables, the first thing is we have to read the values using scanf function. Same way, 2 float values. Once we have read both the integers as well as float values, we will perform the sum of integers and store it in a variable sum of integers. Similarly, difference of integer is also stored in a variable diff of I. Now that we got sum as well as difference of integers, we will store sum and difference of floats as well. Now the last thing is we need to print. Now while printing it, just be careful here. While printing it, sum and difference of both floats scale to 1 decimal value separated by a space on the second line. So first integer in the first line and 2 floats in the second line, and the condition is floats must be scaled to 1 decimal place. While printing floats, we need to scale it to 1 decimal, so we will be using percentile 0.1f. Same thing for the second one also, percentile 0.1f. The first one is the sum of the floats and the second one is the difference of the floats. That's all. And the float values must be printed or displayed into the next line. So I'll be using /n at the end of the first, or we can use /n at the beginning of this one. We have displayed sum of this one, but the difference should also be printed here. Now that we have done with all the required information, let us run the code and check. Congratulations, you have passed the sample test cases. So here is the expected output and we have got this particular output. Let us submit the code. It will be going through all the test cases. Here, congratulations. To continue, just press continue and then you can go to the next challenge. We will continue the next challenge in the coming videos. Thank you. Hi, in this section we will learn about expressions and the precedence in which the expressions are to be evaluated. Expressions are nothing but formulas in mathematics. We will see here how do we write down these formulas in the form of expressions in a program. Once we have done with data types, variables, this is the first thing what we need to learn. That is, how do you evaluate an expression? Now we will be seeing some basic formulas of mathematics. People who don't have the background of mathematics, they need not feel it uncomfortable. I'll just place the formulas and try to convert these formulas into an expression. Now, for converting a formula of mathematics into an expression, what we should learn or what we should know, let us see it. Let us take some basic formulas what we have already learned in our schools. Let us start with the first one, that is area of a triangle. Area of a triangle, A, can be calculated as half base into height. Next one, sum of n numbers. Those who don't know the formulas need not worry about it, just take it as a simple formula, n into n plus 1 by 2. Then comes perimeter of a rectangle, 2 times length plus breadth. Nth term of arithmetic progression series, a plus n minus 1 into d. Roots of the quadratic equation, minus b plus or minus under root of b square minus 4ac by 2a. Then the last one for our discussion, let us take it the formula for displacement, that is s equals to v square minus u square by 2a. Now before going to evaluate these formulas and try to convert these formulas into expressions, let us have one simple example to understand how exactly an expression is going to be evaluated. I'll consider a simple expression as, say, result is equals to, say, a plus b multiplied by c minus d divided by e. Now how do we evaluate this expression? See, evaluation of expression is always done from left to right. That is, the evaluation process will be in this particular direction, left to right. Then which operator should be evaluated first? Is plus 1 should be performed addition first, or asterisk multiplication should be done between b and c, or d and e we should perform slash? So to evaluate such expressions, we have here the precedence. Let us assume the arithmetic operators what we have already seen, that is plus, minus, star, slash, percentile. We give some numbers that is precedence. Precedence is nothing but the priority of the operator upon another operator. That is, say for example, these three operators are here, is having a number larger or bigger than this particular number 1. That means that star slash percentile is having a higher precedence on plus and minus, and moreover parenthesis, that is left and right parenthesis, is having a higher precedence on both set of operations. That is, star slash percentile is having equal priority of 2, whereas plus minus is having a priority of 1, which is less than the priority of this one. So by keeping these precedence in mind, if I want to evaluate this one, B into C will be evaluated first, then D by E will be evaluated next, then from left to right plus and minus both are having equal precedence, so here this one will be evaluated as the third one, and minus will be the last one that is to be evaluated, so fourth one to be evaluated. So by keeping these things in mind, let us try to understand how these formulas are going to be converted to the expressions. Let us begin to convert the first one, area of a triangle. Say half, that is 1 by 2, is going to be there, B into H. How do you write down this one in the form of a expression? Is A is equals to B multiplied by H, and you have slash 2. Here BH is having an operator called as asterisk. Now asterisk and slash both are having same precedence, but the expression is evaluated from left to right, but you give parenthesis for better reading purpose. So this is a best practice to give parenthesis. That means that B into H will be evaluated first, and the result will be divided by 2, and that result will be stored in a variable called as A. Let us see the expression equivalent for this one. Say sum, but we are going to evaluate it, and say N is the first one. Then you have parenthesis. In programming we will be giving asterisk here. N plus 1 as it is, in parenthesis is there, then by 2, then you will write it as slash 2. Let us move on to the next one, that is perimeter of a rectangle. Say perimeter P is a variable, 2 multiplied by length plus breadth. This is a simple one. What we need to do is just have asterisk here. Everything is okay. So I'll just place asterisk over here. Let us see the conversion of this. There are two roots to be evaluated here. One is plus, another one is minus. Let us say root 1. First root, I am storing it in a variable, say root 1, and it is going to be minus b plus. Now we have a square root to be evaluated. We have a square root function in C as well as in C++, sqrt, which is available in a library called as math.h. So we need to include this one by specifying hash include math.h. Sqrt function of b square. Square can be written, that is b multiplied by b minus 4 multiplied by a multiplied by c. I'll write down here 4 multiplied by a multiplied by c. Parenthesis to be closed for this one, and one more parenthesis start from here and close here by. We have 2a, so 2 to be multiplied by a. This is the first root. Same way we will be having the second root evaluation. Root 2 is equals to, only difference that comes is minus b instead of plus, we will be having minus. Same sqrt function of b square can be written as b into b minus 4 multiplied by a multiplied by c. Then this parenthesis is for this one, this parenthesis is for closing this one, divided by 2 multiplied by a. And the last one, that is the displacement formula. This one can be written as v square we are having. So v multiplied by v minus u multiplied by u final velocity minus initial velocity divided by 2 times the acceleration. So here you can see how a formula is converted. The first one, area of a triangle, simply multiplied over here and 2 is getting divided, so divide it at the end. Even you can write it down in one more way. You can even have it in this way as well. I'll provide an alternate for this one. 1 by 2 is nothing but 0.5. So I'll multiply it. 0.5 multiplied by b into h. Both are same. So if you are familiar with formulas, you can give it like this, or by 2 to look it same as the formula, you can give it. N multiplied, whenever multiplication is there, we are going to have star symbol. Whenever division is there, slash. Same way, parenthesis, multiplication is there, so multiplication symbol. So nothing new over here. Multiplication means asterisk multiplication symbol. Here is the only one which is complicated here, because square root is to be evaluated. For including this square root, we must have a math.h header file to be included. And the last one is for calculating the displacement. V square final velocity multiplied 2 times minus initial velocity subtracted, and the value is to be divided by 2a. This is how the expression is going to be evaluated based upon the precedence what we are having it here. Hope the concept is clear. We will see the remaining topics in the coming videos. Thank you.
Hi, in this section, we will learn about what are basic input and output functions in C language and how to use these input and output functions. Let's begin with the C output function. In C language, printf is one of the commonly used output function to display the output into the console, that is, into the monitor. For example, here in this C program, the first line specifies preprocessor directive, that is #include stdio.h, which is a standard input-output file, contains the details about printf, scanf, fprintf, fscanf, similar input-output functions available in C language. Here is one of the function we are using for printing is printf. Whatever code that is provided within double quotation mark will be directly displayed into the console, that is into the monitor. The next input output function is the input one, that is to read the data from the keyboard. In C language, scanf is one of the commonly used input function. There are some other functions are also provided by C language to read the data. We will see those in the later sections of our course, and some among them are getS, getChar, fscanf, etc. Let's see the example using scanf function. Here in this program, first a printf function displays the message to the user, enter a number. With this message, user will be entering a number. Then scanf function is used to read that number from keyboard. Since this variable number is of integer type, we are using %d, and ampersand symbol is used for reading the variable from keyboard. These two function details, that is printf and scanf function details, are available in stdio.h header file, which will be linked by the linker. Let's now see both input and output functions together. Let's have the example demonstrating input and output functions. This program read a character and display its ASCII value. Every character will have its ASCII value. In this program, we are declaring a character variable, asking the user to enter a character, reading a character using
%C format specifier, and the same character ASCII value is displayed using %D. Since characters are read using %C, its equivalent ASCII values will be displayed using %D. So these are the basic input-output functions in C language. That's all regarding input-output functions. The remaining functions will be discussed in the coming videos. Thank you.
Hi, in this section, we will learn about what is an operator, how many different types of operators, and its classifications in C language. Let's start with the first one. What do we mean by an operator? An operator is a symbol or representation that operates on a value or a variable. For example, plus is an operator to perform addition operation, minus is an operator to perform subtraction operator. Similarly, we will be having asterisk for multiplication, slash for division, etc. Like this, there are many more operators provided by C language. C has a wide range of operators to perform various operations. And the types of operators C language provides are: first one, arithmetic operators includes plus, minus, star, slash, percentile. Relational operators includes less than, greater than, less than or equals to, greater than or equals to, etc. Logical operators include logical and, logical or, logical not. Similarly, assignment operators equals to, plus equals to, minus equals to, slash equals to, star equals to, etc. Increment and decrement operators, plus plus, minus minus. Conditional operators and bitwise operators. We will see the details about these operators in the coming videos. Now let's classify these operators. Operators are classified into three categories. First one is unary operators, which contains only one operand along with an operator, which is either prefix or suffix to it. And the next is binary operator, which contains two operands. One is prefixed and another suffixed. And ternary operators, which contains three operands. And there is only one ternary operator, that is question mark followed by colon symbol. Operators under unary operators category are increment, decrement, unary plus and unary minus. Operators under binary operators are arithmetic operators, that is plus, minus, star, slash, percentile. Slash is used for quotients, percentile is used for remainder. Relational operators less than or equals to, greater than or equals to, double equals to is for comparing for equality, not equals to. Logical operators, double ampersand is for logical and, double pipe operator, logical or, exclamation mark, logical not. Bitwise operators and, or, shift left, shift right, complement, XOR.
Assignment operators, single equals to, used as an assignment operator, used to assign a value directly. Plus equals to, adds the current value and then assign the result to the left hand side. Similarly, minus, first subtract the value, then assign the value to the left hand side. Same way, star, slash and percentile. And the last one is ternary operator, also called as conditional operator. We will see the detailed working of these operators in the coming videos. And also, we will have the demonstration for all the operators in C language. That's all for now. We will see the remaining topics in the coming videos. Thank you.
Hi, in this section, we will learn about what exactly an arithmetic operator is, what are the different types of arithmetic operators supported by C language. Let's start with what exactly we mean by arithmetic operators. An arithmetic operator performs mathematical operations such as addition, subtraction, multiplication, division, which gives quotient as the result, remainder, that is percentile, gives the remainder, also called as modulo operator, on some numerical values which includes constants and variables. Let's see an example using these arithmetic operators. Here is the code which demonstrates all these operators plus, minus, star, slash, percentile used for addition, subtraction, multiplication, division and remainder respectively. We are using three variables over here and initialized two variables with initial values as 10 and 4, and when we perform addition, that is plus, it's a normal addition, adds the values of A and B, store the results in C using another operator called as assignment operator, which we will see in the coming videos. Then we are trying to print what exactly the output is. Then minus is used, gives the difference between these two values. Again the same variable is used to store the value, print the result. Then multiplication is done using star operator. Every time we are performing arithmetic operator, we are using the same variable name. In the memory location, first time 14 is stored, then difference between 10 and 4, that is 6, is replaced by 14. Then 10 multiplied by 4, 40 is replaced by 6. Then here comes division, the next one. You can see at line number 12, C equals to A by B, which divides the value 10 by 4. Then gives you the quotient value, that is 2. And at the end, percentile, when we divide 10 by 4, remainder is also 2. Then we are trying to print the result immediately after it. So these are the arithmetic operators supported by C language: plus, minus, star, slash and percentile. That's all regarding arithmetic operators. Remaining operators we will see in the coming videos. Thank you. Hi, in this section we will see a demo demonstrating arithmetic operators in C language. We are using the same program what we have seen while learning the concept of arithmetic operators. Here we are declaring three variables A, B and C. A and B are initialized to values 10 and 4. And C is going to store the result. First, arithmetic operator plus. When A plus B is performed, 10 plus 4 is added and C stores 14 in the memory location. We are trying to print the values. The message gives the output as
A plus B equals 2, percentile D will be replaced by the value of C. Value of C now is 14. So we will get the output as A plus B equals to 14. Next, A minus B. When we are taking the difference, C currently stores 14. Now replaces with a value 6 in the memory location. When we try to print this value A minus B equals to percentile D, you will get the result as A minus B equals to 6. Similarly, when multiplication is done, 40, 10 multiplied by 4, that is 40, is replaced by 6. Similarly, A slash B is going to give you quotient value, that is 2. Let's try to build and see the logs for any errors. No errors. Let's try to run. Here you can see the output. First, A plus B equals to percentile D, that is replaced by a value of C. When we are performing the difference, C now takes value 6, that is replaced by 14. Similarly, multiplication, slash gives you the quotient, and at the end, remainder, when 10 divided by 4 is equals to 2. Here we are giving a message, remainder when percentile D is replaced by a value of A. This percentile D replaces the value of B, and the last percentile D replaces with a value of C. That is the result, remainder. You can see here. When we compare this message now, remainder when percentile D, that is 10, is replaced, divided by value of percentile D now is B, that is 4, is equals to result, that is the remainder, that is 2. This is regarding arithmetic operators in C language, that is plus, minus, star, slash and percentile. That's all in this section. The remaining topics we will continue in the coming videos. Thank you.
Hi. In this section, we will learn about the following. First, what does increment and decrement operators means in C language? What are the different types of increment and decrement operators supported by C language? What is the difference between pre and post increment and decrement? And at the end, we will see an example program using increment and decrement operators. First, we will start with increment operator. An increment operator plus plus increments or increase the value by 1. There are two types of increments. First one is pre-increment, that is plus plus is prefixed for a variable name, and second one is post increment. Here plus plus is suffixed, that is placed at the end. Both will do the same job. Plus plus will increment the value of the variable by 1. Same, variable plus plus also increments the value of the variable by 1. Then, if both does the same task, then what exactly the difference between these two? Let's see the difference between pre and post increment. Pre-increment increments the value of the variable by 1. The same task is done by post increment as well. That is,
this also increments the value of the variable by 1. If we see the example, here we are declaring an integer variable which is initialized to 5 and a pre-increment plus plus a is used. And if we are trying to print the value of a, what will be the output here? A will be incremented by 1 in the memory location and 6 will be printed. Here the same value a, which is initialized to 5, now if it is used in post increment a++ and tries to print the value, same answer you will get here in the memory location 6. Then what is the difference? Pre-increment also increments the value of the variable by 1. Post-increment also increments the value of the variable by 1. In the example, a gets the value 6 after pre-increment and a gets here the value 6 in the memory location for post-increment also. Then the difference comes here. If we have an example like an expression, when pre-increment is used in an expression, here x equals to plus plus a. First, the value of a is incremented by 1 in the memory location. That is, a takes first 6. Then the value is assigned to x. And when we are trying to print the value here, we will get x equals to 6 as well as a equals to 6. Whereas, if we use post increment for the same example, then a value is first initialized to x, then a is incremented later in the memory location of a. Therefore, now x get 5 and a will get 6. So when we try to print the value here in pre-increment, we will get x also 6 and a also 6. Whereas in post-increment, we will get x equals to 5 and a equals to 6. So here comes the difference when we use pre and post increment in an expression. So this is the difference between pre and post increment. Let's see decrement operator. Exactly reverse operation it performs. That is, it decrements the value by 1. Similar to increments, as we have two types of increments, there are two types of decrements. If you see the difference now for decrement, obviously pre-decrement also decrements the value of the variable by 1, as well as post-decrement also decrements the value of the variable by 1. If we use the same value int a equals to 5 and tries to decrement the value minus minus a and tries to print the value here, a will get 4 in the memory location. So the printf statement will print the value a equals to 4. Similarly, for post decrement, a minus minus a value will be printed as 4. So there is no difference as such. Now comes the difference. Here, if we tries to assign minus minus a value to x, first a is decremented, we'll get a value 4 and assign it to x. And if we try to print the value of x and a, you will get 4 and 4. Whereas if we take in post decrement, value a that is original value of A is 5, which is first initialized to X, then it is decremented in the memory location by 1. So X will try to print the value, X will get 5 and A will get 4. Here comes the difference in pre and post decrement. Let us see an example of increment and decrement operators. Here in this program, we are using two integer variables, A which is initialized to 5, B which is initialized to 10. And we are using two float variables, C which is initialized to 5.5 and D which is initialized to 10.5. The first printf statement is using pre-increment operator plus A. Here value of A is 5 and when we are trying to print plus A, first A will be incremented in the memory location and that value will be 6 and 6 will be printed. Same way, for pre-decrement, B value is 10, original in the memory location, and it will be decremented by 1 and then the value will be printed. Whereas in post increment, C value is first printed, then it is incremented in the memory location later. That is 5.5 will be printed, then in the memory location the value is incremented, that is 6.5. Similarly, post decrement first uses D value, that is 10.5, to be printed and then it decrements the value later in the memory location by 1, which makes D to be 9.5. So what will be the output here? We are expecting plus A will print 6, minus B will print 9, C++ here prints 5.5 and D will print 10.5, that is the original values of C and D. Whereas in the first two printfs, the altered values of A and B will be printed. With this example, you might be getting a clear picture about pre and post increment, pre and post decrement operators in C language. We will see another example in the demonstration part of increment and decrement operators, which we will see in the next video. Thank you. Hi, in this section we will see a demo demonstrating increment and decrement operators in C language. Here we are using the same program what we have seen in the last video while seeing the concepts of increment and decrement operators. There are two integer variables A and B which are initialized with values 5 and 10, and there are two float values C and D which are initialized to 5.5 and 10.5 respectively. We are using pre-increment with A, pre-decrement for B, post-increment for C and post-decrement for D. When we use pre-increment plus A, the original value of A is 5, which is incremented by 1 in the memory location, and 6 will be printed. Similarly, minus B is the pre-decrement operator, B, original value in the memory location which is decremented by 1, and then the value will be printed as 9. Whereas it is a different output when we use post increment and post decrement. C++ first uses the original value of C as 5.5 in the printf statement to print the output. Then later in the memory it is incremented by 1, which is 6.5. So if we try to print C in the later section of the program, you will get 6.5 for value C, and D, original value is 10.5, will be used in printf statement to print the value, and then later it is decremented by 1, that is 9.5 in the memory location of D. Let's try to build the project. Let's check for any errors. 0 errors and 0 warnings. Let us run the program. Here you can see the output clearly. ++a, that is pre-increment, first increments the value by 1 and then used in printf statement to print the value. Similarly, pre-decrement uses the decrement operator first to decrement the value by 1. C++ uses the original value 5.5 to print, then later it increments. Similarly, D uses its original value for printing in printf statement and later it decrements the value by 1. This shows the clear difference between pre-increment and post-increment, pre-decrement and post-decrement. Let us see the same program with small modification. We are using an assignment operator here. That means we are using increment and decrement operators in an expression. So what happens when we use pre-increment and post-increment in an expression? In pre-increment, first the value is incremented and it is assigned to the left hand side variable, that is temp A. Similarly, -b first decrements the value and then assign it to the left hand side, that is temp B. Whereas temp C equals to C++ will first assign the value of C to the left hand side, that is temp C, and then it increments the value of C by 1 later. Similarly, D assigns the value to temp D and decrements the value later. So when we tries to print the value before and after increment, we will see the difference in the output. Let's build the project. Check for errors in the logs. No errors, no warnings. Let us run the program. Here you can see the output. Before pre-increment of A and pre-increment of B, the values are 6, 9, and even after increment and decrement pre, you will get the same. That is, first it is incremented, then it is assigned. Therefore, you will get the same value 6, 9 for pre-increment and pre-decrement. Whereas, there will be a difference in the values used in post-increment and post-decrement. Clearly, you can see C++ 5.5 original value, 10.5 original value, then in the memory location of C 6.5 and in the memory location of D 9.5. This clearly demonstrates the difference between pre-increment and post-increment, difference between pre-decrement and post-decrement. Hope the difference is clear with this example. That's all regarding increment and decrement operators in C language. We will see the remaining topics in the coming videos. Thank you.
Hi, in this section we will see what an assignment operator is, what are the different types of assignment operators supported by C language. Let's start with the first one. Let's try to understand what exactly an assignment operator is. An assignment operator is used for assigning or giving a value to a variable. The most common assignment operator is single equals to, which assigns the value from right hand side of equals to symbol to left hand side variable of equals to symbol. The other assignment operators are plus equals to, minus equals to, star equals to, slash equals to, and percentile equals to. That means assignment operator single equals to can be used along with all arithmetic operators, that is plus, minus, star, slash, and percentile. Even though they are less commonly used, these operators are very efficient while coding the programs and acts as the shortcuts. Let's see the description of these operators. First, single equals to can be given in the form of expression as follows. X equals to y means it assigns the value of y to x. Similarly, plus equals to can be written in the form of expression as the current value of x is added to the value of y and stored the result back into x. So instead of writing x equals to x plus y, we can provide a shortcut x plus equals to y. The same is applicable for minus, star, slash, and percentile. As we can see the description over here, x minus equals to y, x equals to x minus y, x star equals to y, meaning is x equals to x star y. Same way slash and percentile. So these operators can be used as shortcuts in the expressions. An assignment operator is the most commonly used operators in a program. That's all for this. The remaining concepts we will see in the coming videos. Thank you. Hi, let's see another set of operators in C language. In this section, we will learn about first what an relational operator is and what are the different types of relational operators supported by C language. Let's start with relational operators. A relational operator checks the relationship between two operands, and if the relation is true, it returns 1. Otherwise, the relation can be false as well. In this case, it returns 0. These operators are used usually in decision making, that is, in if condition, case statements, and loops like for loop, while loop, or do while loop. These are the set of relational operators with brief description about each operator. The first one, double equals to. Remember, single equals to is an assignment operator, whereas double equals to is a relational operator.
The most common mistake students does is writing single equals to in place of double equals to and writing double equals to in place of single equals to. Remember, this type of error is a logical error where the program gets executed but we may not get the desired output. So be careful with this type of statements, operators, that is single equals to and double equals to. Here in the description, 5 equals to 3. Since the left hand side operand, that is 5, is not equals to the right hand side operand of the operator double equals to, it results in false. Therefore the value returned is 0. The next operator is greater than. Left hand side operand 5 is greater than 3. It results in true. Therefore the value returns is 1. Same way, the next one, less than. Since 5 is not less than 3, the condition evaluates to false and the result is 0. Next one, not equals to. As it is clear, 5 is not equals to 3. So it evaluates to true and the result returns is 1. Same way, greater than or equals to. 5 is greater than 3. It may happen that any one of the condition can be true. That is, 5 greater than or equals to 5 results in true. 5 greater than or equals to 4 also results in true. 5 greater than or equals to 3, 2, 1, 0 results in true. So it returns 1. And the last one, less than or equals to, is exactly opposite of greater than or equals to. Left hand side operand should be less than or equals to the right hand side operand to get the result true. So in this case, 5 is not less than or equals to 3, so it evaluates to false and the result return is 0. Remember, these operators are commonly used in if condition, switch statement, for loop, while loop and do while loop. That's all regarding relational operators in C language. We will see the remaining topics in the coming videos. Thank you. Hi. Let's see the next set of operators, that is logical operators in C language. In this section, we will learn about first, what do we mean by logical operators and how many different types of logical operators supported by C language. Logical operators. These operators are used in an expression which either evaluates to true or false. So, an expression containing logical operator returns either 0 or 1. If the expression evaluates to true, it returns 1, or else if the expression evaluates to false, it returns 0. The usage of logical operators are commonly in decision making and can also be used in control statements, that is, in loops, for loop, while loop, or do while loop, but they are commonly used in decision making. Let's see what are the different types of logical operators and their working. The first logical operator is double ampersand. Ampersand symbol returned 2 times is a logical AND. It returns true only if all the operands are true. Let's see the example here. Consider, for example, the value of C is 5 and the value of D is 2. And if the expression evaluates as follows, C double equals to 5 matches 5 with 5 results in true, and D, that is 2 greater than 5, results in false. So one condition results in true and another condition results in false. So the total result evaluates to false. In this case, the second condition evaluates to false. Therefore, if any one of the condition is false, the final result will be false. And if the result of both the conditions are true, then the final results will evaluates to true and returns 1. Let's see the second type of logical operator, that is logical OR. The operator we are using over here is a pipe operator. Vertical lines you can see. This evaluates to true if any one of the condition is true. Let's see the example. If the value of C is 5 and the value of D is 2, then in the expression, the first condition 5 matches with 5 evaluates to true irrespective of the following conditions. Let it be second condition or third condition or fourth condition available in an expression, the result will be evaluates to true. So logical OR operator will results to true if any one of the condition is true. And the last one is logical NOT. It returns true if the expression evaluates to false. It is negation of false is true. So it returns true only if the operand is 0. You can see the example here. Current value of C is 5 and the expression evaluates to 5 matches with 5 results in true. Opposite of true is false. So it returns 0. These are the logical operators supported by C language. That's all regarding logical operators. We will see the remaining topics in the coming videos. Thank you.
Hi. In this section, we will learn about what is size of operator and
What is the usage of size of operator in C language? Size of operator is a unary operator that returns the size of the data. Unary operator means it uses only one operand and returns the size, that is, the memory occupied by a variable or a constant used in the program, such as constants, variables, arrays, structures, unions, etc. So using size of operator, we can find how much size a constant, variable, or array, or structure, or union occupies in the memory. And when size of operator is used, it returns the number of bytes occupied by the operand. Example, int a. Here a is of type integer. We don't know how much memory integer occupies on the current platform on which we are executing the program. If it is 16-bit compiler, integer may occupy 2 bytes. If it is 32-bit compiler, it may occupy different size. If it is 64-bit compiler, it may occupy different size. Even Windows operating system provides different memory structure, and Linux operating system provides a different memory structure for the variables. This is the syntax of using size of operator. Size of followed by either a constant or a variable or the array name or the structure name or union name can be used. Here we are using an integer, that is a variable name. Suppose integer takes 4 bytes. So here x will store 4. The size of operator is commonly used in allocating the memory dynamically, that is malloc, calloc, or realloc. These functions are used to allocate the memory dynamically. Like in linked list data structure, if we don't know how much exactly a node occupies the memory, we can use size of operator to know the size and allocate the memory dynamically. That's all regarding size of operator. We will see the remaining topics in the coming videos. Thank you.
Hi, in this section, we will look at another set of operators provided by C language, that is bitwise operators. As we know that C language falls under the category of middle level language, it provides the user to access the hardware, the bits, that is zeros and ones. In this section, we will learn about first, what do we mean by bitwise operators? How many different types of bitwise operators are there in C language? Let's begin with understanding what exactly bitwise operators are. During computation, mathematical operations like addition, subtraction, multiplication, division, etc. are converted to bit level, which makes processing faster and saves power. That is, whatever mathematical operations are there like addition, subtraction, multiplication and division,
they are usually converted into bit level operations so that machine can understand easily and process it faster. Bitwise operators are used in C programming to perform this type of bit level operations. Let's see the operators which are available as bitwise operators. Here is the list of operators. The first one, ampersand. Remember, double ampersand is a logical operator and single ampersand is a bitwise AND. And the second one is bitwise OR. 2 times pipe operator is a logical OR and a single pipe operator is a bitwise OR. Next one is a cap operator, is a symbol for bitwise exclusive OR, also called as bitwise XOR or simply XOR. The next one is a bitwise complement operator. Next one is shift left. And the last one is shift right. Let us see the truth table for these set of operators. Here is the truth table. Say for example, there are two bits A and B which can contain the possible values. If both A and B are 0, then bitwise AND, bitwise OR, bitwise XOR all results in 0, whereas complement of 0 is 1. So here complement of A, current value of A is 0. So complement of A is 1. Similarly, if A is 0 and B is 1, bitwise AND results in 0, that is false. Bitwise AND results in true only if both the bits of A and B are 1. That is true. Whereas bitwise OR results in true if any one of the bit among A and B is true, that is 1. So we can see here clearly A or B is 1, A or B is 1 for 0, 1, A or B is 1 for 1 and 0, A or B is 1 for 1 and 1. XOR, if both the bits are 0 or 1, that is same, the result is 0. If both the bits are different, that is either 0 1 or 1 0, then XOR will result in 1, that is true. And the last one is complement. 0's complement is 1 and 1's complement is 0. This is just an introduction part of bitwise operators. We will see the details working of bitwise operators in the next video, which is used to demonstrate all the bitwise operators in C language. We will see the remaining topics in the coming videos. Thank you.
Hi and welcome to the demonstration program to demonstrate the bitwise operators. Before going to write down a program, or before going to see how exactly the execution of this bitwise operators are, let us quickly recollect how many bitwise operators are there. Here is a collection of bitwise operators. First bitwise operator is a bitwise AND, then bitwise OR, which is a pipe operator. Remember, double ampersand is for logical and single ampersand is for bitwise AND. Similarly, double pipe operator is for logical OR and single pipe operator is for bitwise OR. Now we have another one is a cap operator. We call this one as a XOR operator or XOR. Then we have tilde operator, which is used for negation purpose, that is not bitwise complement, that is zeros ones, that is zeros complement is 1 and ones complement is 0. And then we have shift left and shift right operators. We haven't seen these two operators working while seeing the truth table. This is the truth table what we have already seen in the last video. In this one we haven't seen the working of shift left and shift right. Let us try to see the working first, then we will demonstrate the program. Let us see the working with the example values here. A equals to decimal value 4 and B equals to decimal value 5. Its equivalent binary number. The first we will start it from this part, that is your least significant digit to the most significant digit to the right side. We call this one as least significant bit also, and this one as most significant bit. Now how this one is going to be, 4 is represented in binary like this. Binary numbers usually starts with 2 power 0, then 2 power 1, then 2 power 2, then 2 power 3, like this it so go on. So for 4, the bit for this one 4 is going to be 1, on, that one bit is on, and the remaining bits are off, that is zeros only. That's why we can see this bit is on for 4 and all the remaining bits are off, that is 0. Now 5 is a combination of this part is 2 power 2 is 4 and this value is going to be 1. 4 plus 1 is 5. So this bit is on and this bit is on, the remaining bits are off, so on. So this is the value of binary equivalent of 5. When we perform AND operation on these two values 4 and 5, let us see bitwise. 0 0, both the bits should be 1, then only the result will be 1, otherwise the result will be 0. So here one is 0, another one is 1, so result is 0 for the first bit. Next one, both are 0, 0. Now comes here, both the bits are 1, then the result is 1. The remaining all the bits are 0 only, so we have zeros here. And its equivalent decimal value, just now we have calculated this one, is 4. So whenever we perform AND operations on 4 and 5, the result is going to be 4. Let us quickly see now bitwise OR operation. For the OR operation, if any one of the bit is true, that is 1, the result is going to be 1. Same example we are taking for 4 and 5. For the least significant bit, we will start 0 0. Any one is 1? Yes, 1. So result is 1. Any one is 1? No, both are 0. So 0. Any one is 1? Both are 1. So it is going to be 1. All the remaining number of bits are going to be 0. So OR operation results in 5, whereas AND operation results in 4. Let us see bitwise NOT. NOT is nothing but negation. How exactly the working of this one is? Let us take an example here. A value as 5. 5 in binary equivalent will be something like this. So the bits 1, 2, 3, 4, 5 bits, then followed by 1, 0, 1. This we have already seen it. Now you take ones complement. Actually, this is not the direct ones complement. Ones complement, exactly you reverse the bits. 0 becomes 1, 1 becomes 0. So there are 5 zeros. So I'll take it 5 ones, then 0, then 1, then 0. Okay. Then now what we do is we again reverse these bits except the first bit. First bit is a signed bit. So 1 remains as it is and the remaining numbers, that is 0, 0, 0, 4 zeros, then followed by this 0 will become 1 here, and this 1 will become 0 here, and this 0 will become 1. Now for this one you add plus 1, that is, it will become 2's complement, zeros and ones and ones, 1, 2, 3, 4, then 1. Now when you convert this one into its decimal equivalent, remember 0 means positive sign and 1 as the most significant bit indicates negative sign. That means you consider what exactly the equivalent decimal for this one is. 4 plus 2, that is 6, with a negative sign, so it will become minus 6. That's how here becomes answer as minus 6. Then we have XOR operation. XOR is very simple. When both the bits are same, the result is going to be 0, and when both the bits are opposite, then the result is going to be 1. Consider it, same example, 4 and 5. Here within the first bit only, both the bits are opposite, zeros and 1, then only the result is 1. Otherwise 0 0 0, 1 1 also 0, same bit, 1 1 is also same bit, 0 0 is same bit, 0 0 same bit. So you consider this bit as well as this bit, you consider 1 as well as this one. If both the bits are 1, then also the result is 0. If both the bits are 0, then also the result is 0. Let us consider the next two bitwise operators. One is shift right, another one is shift left. In simple words, if you want to remember, shift right is nothing but division, whereas shift left is nothing but multiplication. Like we says 20. 20 divided by 2, what would be the answer? 10. 10 divided by 2, what would be the answer? 5. Like that, we have 20 here. 20 multiplied by 2, what would be the answer? 40. 40 multiplied by 2, what would be the answer? 80. Like that it proceeds. Why we are taking only 2 for division as well as multiplication? Because binary number. 2 is a binary number. So bits zeros and ones are 2 bits. That's why here we are considering it as divided by 2 as well as multiplied by 2. Let us see the working of this one. 20 in its binary form is, this is 0, 2 power 0, 2 power 1, and this one is 2 power 2, and this one is going to be 2 power 4. So that means that it is going to be 16 plus 4, that gives you 20. When we say shift right, right means every bit is now going to be shifted. You can see 1 is placed at the third position in the result one. Now 1 has been shifted from this position to the second position, and 0 is removed, that is discarded. So I can just say something like this, 1 0, and this again 1 is again shifted, so it's now going to be 0 1 followed by remaining all zeros. If you consider this one as a equivalent decimal number, you will get it as 10. Same way, if you shift it one more time, this 1 will be shifted here, so 1 is shifted here, this position, and this 0 shifted to this particular position, and this 1 is shifted to this position, zeros are shifted, all zeros are shifted, and 1 0 is added. Now let us see shift left. As a fresh values, we will consider 20. 20 binary equivalent is 0 0 0, 1 0 1 0 0. This is the binary form of 20. If we perform shift left, this 1 is into the fourth position, will come into the third position here. You can just see 1 is placed into the third position, and all the bits are shifted, and 0 is appended at the end. So 0 is appended at the end. That means that the value is now multiplied by 2. You will get it as 40. So if you take this one into its decimal form, you will get it as 40. Same way, if you shift one more time, this 1 is now shifted from this position to this position, like that. 0 is shifted from here to here, 1 is shifted from this position to this position, like that. If you consider it, it will become 80 in its decimal form. Let us see the working of this by executing it. So I'll just run the program and show you the output first. Here is the output. We are going to get it in the form of a truth table. Let us quickly have these values. Possible values of I and j, we are considering it here. All the truth tables. 0 0, both the bits are 0, result is 0. Any 1 is 0, again 0. Any 1 is 0, 0. Here comes both the values are 1, then only the result is going to be 1. Whereas for OR operation, any one of the bit is 1, like here, any one of the bit is 1, result is 1. Any one of the bit is 1, result is 1. Both the bits are 1, anyhow, result is 1. Not means negation. 0's complement is 1 and 1's complement is 0. And here bitwise XOR, to remember this one, if both the bits are of the same, that is if they are off or on, let it be 0 0, let it be 1 1, result is going to be 0 only. Whereas if one is 0, another one is 1, or first one is 1, second one is 0, then the result is going to be 1. Then here we have bitwise shift right. As I said that it is nothing but division. When you take 20 divided by 2, you will get 10, and 10 divided by 2, you will get 5. Like that, bitwise shift left is going to be multiplication. So this one is going to be 40, and 40 when again multiplied by 2 gives you 80. And here are some more examples. Here we have taken it, already solved this one. 4 and 5 gives you result 4. OR operation when you do, result is 5. XOR operation when you do, 1. And NOT operation, this we have already seen it using 2's complement, that is first 1's complement, then reverse the bits except the most significant digit, that is for sign bit. 1 is for negative and 0 is for positive. So we got the result as -6. We have already solved this one. Here is the program. A value 4, B value 5. We are displaying this message bitwise AND. We are getting at the top. If you remember, this is at the top. Bitwise AND is the message what we are getting it here. And to get a tab, that is a space in between I and J and this result, we are taking /t over here and trying to print the data using 2 for loops, because we are trying to display a matrix form of data, that is 2-dimensional data. What is that we want to display it? I value 0, J value 0 to be started. So I value 0, J value 0, I value and J value, and the next one, that is the result what we are going to get, it is I and J. Here is I and J result, that is here we are performing bitwise AND operation. Similar to this one, here we have bitwise OR operation, I or J. NOT operation, single for loop is required, because for one digit 1 it is 0, for 0 it is 1. And for XOR also we are having 2 for loops. And for shift left and shift right, we have considered a different value over here. You can just see 20 we have considered. When we have performed one time shift right, we got it as 10. Second time we got it as 5. Similarly, shift left, one time shift left 40, second time shift left 80. And here is the last one, that is bitwise AND operation on A and B. What are the values of A and B? Here we have considered 4 and 5. So 4 and 5, result of this one is going to be 4. And bitwise OR is 5, bitwise XOR, this one is 1. And the last one is negation, that is going to give you -6. That's all regarding bitwise operators. We will see the remaining topics in the coming videos. Thank you. Hi, and welcome to another online coding challenge on HackerRank. Today's challenge is on bitwise operators. Let us see the objective of this challenge. This challenge will let you learn about bitwise operators in C. As we know, the bitwise operators are AND, OR, NOT, shift left and shift right. Let us see among these operators how many are there in this challenge. We know the working of bitwise AND, bitwise OR and bitwise XOR. These are the 3 operators involved in this challenge. Let us say a decimal 3 is there whose equivalent binary is 0 0 0, all zeros, last 2 bits are 1, and for decimal 5 its binary equivalent is 101. If we perform AND operation on this 3 and 5, result is true or bit is 1 if both the bits are 1. Here it's the only one possibility over here. Both the bits are 1, then the result is 1. otherwise all are different. 1 0 different, 0 1 different, 0 0 not true, only 1 1 it's true, so it is 1. Its decimal equivalent is 1 again. Same way, if you perform OR operation, in OR operation any one of the bit is 1, the result is 1. So here both are 1 1, here any one is 1, yes 1, true, any one is 1, yes 1. So here it is triple 1, that is nothing but 7. XOR, if opposite bits, or you can say both the bits are different, then only the result is going to be 1, otherwise the result is 0. Say for example, here until this part all these are 0 0 0 0, so result is going to be 0, and this one is 1 1, so it's going to be 0 again. But for these two things, 0 1 it's 1 and 1 0 it is 1, so its equivalent decimal number is 6. This operation of bitwise we have already came across in our practice session, as well as we have solved some programming challenge as well. Let us see the task over here. You are given a set of numbers 1 to n. We need to find here the maximum value of a and b, which is less than a given integer k, where a and b, among this a is always less than b, are the two integers from the set, this set. Similar to this one, we have to find the maximum value of a or b as well, again which is again less than an integer k. Same way, we have to find the maximum value of XOR also, same conditions applies. Input format, the only line contains two space separated integers, n is given and k is given respectively, and the constraint is n ranges from 2 to 10 to the power 3 and k ranges from 2 to n. And the output format is, the first line should contain the maximum possible value of a and b, second line contain maximum possible value of a or b, and the third line, this is actually, should contain maximum possible value of a XOR b. If sample input is 5 4, then sample output should be this one. How it is? Let us say n is 5, k is 4. So set contains possible values of 1 2 3 4 5. All possible values of a and b, let us see here. It is nothing but, for a value of a equals to 1 here, b value will start from next 2 3 4 5. This is the one possible set of values. Then for a equals to 2, b values are 3 4 and 5. Then again for a equals to 3, we have b equals to 4 and 5, and for last one a equals to 4, b equals to 5. We will be performing all three operations here. First time a and b, a or b, a XOR b. How it is done? Let us see one example over here. A value is 1. It is nothing but 0 0 0 0 0 0 0 1. B value is 2. 0 0 0 0 0 0 1 0. Now when we perform a and b, and nothing is common in this one, so everything is going to be 0. This is AND. For OR, this is for OR. Similarly for XOR, so its decimal equivalent is 0, this decimal equivalent is 3, this decimal equivalent is also 3. Similarly, let us say for example, if I pick up this example once again, I'll take a value as 2. 2 means 0 0 0 0 0 0 1 0. B value is 5 and 0 1 0 1 0 1. A and B, nothing is common in this one, you know. When we perform AND operation, nothing is common, so we will get all zeros. OR, so here it is a and b is 0, that's why. When we perform OR means 0 comma 1 0 1 1 1 0 1 0 1 1. This is nothing but OR. Same way XOR, both the bits are different, then only you will get 1, otherwise both the bits are same, you will get 0. This is XOR. So this one equivalent is 0, decimal equivalent 7, and this is 7, that's why here it is 0 7 and 7. Now how we will perform these steps is, remember this one is going to be accomplished using nested for loops, that is nested loops, one loop within another loop. So if I take one index as say starting index is 1, then this j index whatever is there in this one inside values, how many values it's taking for one possible I value? For one possible I value it's taking I plus 1, I plus 2, I plus 3 until it reaches last value in the set. So we will say it's starting from I plus 1 and until it is n, it's going to be continue. I plus plus, here it is now going to be j plus plus. Now here is what is the possible maximum value here we have for AND for k equals to 4, which is less than k equals to 4 is 2. So if we select among this maximum value, what we will get it for AND is 2. Similarly, the maximum possible value of this one is 3, maximum possible value. Here is again maximum possible value for this one is also 3 for XOR. That we will do it here, one if condition. So we will take one variable, say maximum for AND we will take one variable, maximum for OR we will take one variable, and maximum for XOR all initialized to 0. Whenever we get a value greater than this value, we will replace it here. So let us quickly write down the code and check for the test cases. Let us start writing the code. I will be declaring the variables maximum for AND operation assigns 0, maximum for OR operation also assigns 0, as well as maximum for XOR operation is also assigned 0. We required two for loops, that is nested for loops. So I value starting from 1, I less than or equals to n value, this one is given as a parameter, first parameter. J value starts from I plus 1 until n again and again j plus plus. What we need to do over here is we need to perform AND operation. So let us take one integer variable and perform AND operation among I and j. Store the result in X. Similarly, let us take Y variable here and store the result of I or j, OR operation, bitwise OR. Similarly, let us take a Z variable and store XOR operation. So these three variables, that is X, Y, Z, contains bitwise AND, bitwise OR and bitwise XOR. Now how do we find the maximum is, let us check the condition that bitwise AND is available in a variable X. So if this X is less than the value of K that is passed as a parameter, and that is logical and X should be greater than the maximum AND. So we have stored initially 0. If it is so, then you just immediately replace this value. What is that value? X value, and store it in max AND. Same condition applies for the remaining two as well. So first thing, if X is less than K and X is greater than max of AND, then X will be stored in max of AND. That means that when we get a value greater than the maximum currently what we have in this variable max AND. Same thing repeats for OR operation, same thing repeats for XOR operation as well. Now once we are done with storing the values here, this for loops, two for loops that is going to be there here will be closed, and after coming out of the for loop we will print the output. So how the output is going to be printed? First %d, that is AND operation result, then in the next line we will print OR operation result, then in the next line we will print the last one. So the first one is going to be max of AND, and second one is going to be max of OR, and the third one is going to be maximum of XOR operation. Okay, that's all is the task what we have here. In the task sample output, what we need to print it, first line AND operation result, second line OR operation result, and the third line XOR operation result. we have done with that one. Let us run and check how exactly this one goes through the sample test cases. Yes, it has cleared the sample test case, that is when we perform AND operation. Yes, this is the output what we got it and is the expected output. Now we are ready to submit the code for the remaining test cases. Let us submit it. Here are the remaining test cases, almost 14 test cases including test case 0. Success is the message given by the compiler and it has gone through all possible test cases and it is perfect. So we earn 15 points with this challenge, so that now we have the points 140 out of 200, and here you can see at the top that we are 60 more points behind for the next star. So the message is congratulations, you have solved this challenge and we are ready now for the next challenge. That's all regarding bitwise operators and this challenge. We will continue with the remaining challenges in the coming videos. Thank you. Hi. In this section, we will see a unique operator provided by C language named as ternary operator. Earlier to C language, we used to have only unary operators and binary operators. C has introduced a new operator named as ternary operator. In this section, we will learn about the following. First, what is a ternary operator? Then, we will see the working of a ternary operator in C language. And at the end, we will look at the usage of a ternary operator. Let us begin with understanding what is a ternary operator is. A ternary operator uses two symbols, question mark and colon. Earlier to ternary operators, we have unary and binary operators. Let us try to see the working of it. Here is an operator with one operand is called a unary operator. So whenever in an expression, if an operator is placed along with one operand, it is named as unary operator. Example, a++ is an increment operator, post increment operator plus, a post decrement operator, -a unary minus operator, ++a pre-increment operator, and -a all are unary operators. Here operators are plus, minus, plus, and only one operand is there, that is a, in all the operations. So we named this one as unary operator. Then comes binary operators, that is an operator with two operands. It is placed something like this. Example, a plus b. Plus is an arithmetic operator, performs addition on these two operands a and b. Similarly, a minus b, arithmetic minus, performs subtraction on these two operands a and b. And star, that is again a arithmetic operator, performs multiplication on these two operands a and b. Similar to these two unary and binary operators, we have a third category of operator named as ternary or conditional operator, where we have three operands. That's why the name is ternary. Why the name conditional operator? Because it can be used as an alternate to the conditional statement. We will see this one at the end of this section. Example of a ternary operator. Say in an expression, B assigns a question mark with some value 1 colon with another value, say 0. If an expression in the first part, that is a, what is the value of a is, if it is true, by default a non-zero element results into true and 0 element results into false. Consider here, if a is non-zero, then b will be assigned a value 1. Else, if a is 0, that is false, then b will be assigned a value 0. Now, in place of a, it is actually an expression. So this is the simplest form of expression, we are considering it here. By default in C language, whatever non-zero element a contains, it is assumed to be true, otherwise 0 will be considered as false. We will see in detail about the expressions now. Here see the working of a ternary operator. Here is the syntax used for declaring a ternary operator. Expression 1 question mark, expression 2 colon, expression 3. The expression 1 will be evaluated always. That means whatever the value is there at the first before question mark, which is assumed to be expression 1, will be evaluated, and the execution of expression 2 and expression 3 depends on the outcome of expression 1. That means that if the outcome of expression 1 is non-zero, just now what we have seen, if a value is non-zero, then 1, that is expression 2, will be evaluated or assigned to b. Otherwise, expression 3, that is in our example 0, will be assigned to b. Let us see the usage of a ternary operator. Ternary operator can be used as a replacement of if-else statement. That's why it is named as a conditional operator also. Say for example, if we have a conditional statement, if a is greater than b, then a variable max assigns a value of a. Otherwise, if the condition results in false, max will be assigned a value of b. This statement of if-else can be written in a simplest form using ternary operator as follows. Here it is. Max assigns a greater than b, that is the condition or expression is evaluated. If it results into true, then a value will be assigned to max. Otherwise, if a greater than b results into false, then max will be assigned the value of b. It is exactly the same way what we are executing using if-else, and it can be done in a single line or single statement. So this is a very powerful operator, ternary operator. And one more thing, within this first expression 1, you can again have sub expressions or nested expressions. Then again within a, that is second expression 2, we can again have nested, that is we can have a nested expression as well. That's all regarding ternary operator in C language. We will see the remaining topics in the coming video. Thank you. Hi and welcome to the programming challenge. Here in this programming challenge, we will be finding the largest of any three given numbers using special operator provided by C language, that is the ternary operator. Ternary operator uses two symbols here. One is question mark, another one is colon. First of all, let us try to find out what exactly the problem statement is. The problem statement over here is to find the largest of three given numbers. Let us take for example a some number, b some number, and c some number. First situation where a is greater than b and c. So what would be the criteria over here is A must be greater than B as well as A must be greater than C. Then only we can declare that the first number is greater. Otherwise, another situation. Say for example, A is a number where B is another number, but here C is the largest one. Say consider 20. In this situation, the first condition A is greater than B is true, but when we consider A is greater than C is false. That means that when any one of the condition, that is either A greater than B or A greater than C is false, then we can check among these two numbers. What is that? B and C. Whichever is greater, we will say that number is greater. Here in this situation, B is greater than C? No. That means that C is the largest one. Consider another situation where A is 10, B is 30 and C is 20. In this situation, A greater than B is false. We need not check with C, or if we check with C also, this condition might be true or false. But in this particular case where A is not greater than B, that means that either B is greater or C is greater. So we need to check among these two numbers. So if B is greater than C, that is true, then we know that B is the largest one. So these are the three possible situations because there are three numbers over here. Before proceeding for three numbers, let's test for two numbers first. Say A is 20 and B is 10. First case. When we say A is greater than B results in true, we will say A is the largest one. Second situation, when A is 20 but B is greater than 20, then the result what we are checking over here results into false. When we say A greater than B results in false, then we say B is the largest one. So first we will try to implement the largest among two given numbers. Then we will go for the largest among three given numbers. This is general examples what we have seen using condition checking, but we have to implement this one using ternary operator. So using ternary operator, let us see how it will work. Let's say in this particular scenario, I'll take a variable, say result. I'll check first condition, say A greater than B. If A is greater than B, question mark, what result should store? Result should store A. Otherwise, that means else, I should store B in it. So this is the scenario where A is greater than B. So what result will store now is A. If it results into true, let us say second situation, if A is not greater than B, that is results is false, then B value will be assigned to result, that is 30 will be assigned. Same way you want to implement here using three variables or three numbers, then it will be nested over here something like this. For the first number result to have the largest one, A must be greater than B simultaneously, that is and, logical and we are using it over here. A must be greater than C. If and only if these two condition occurs, then we can say result can hold which value? A value. If this results into true, that is the first case. Let us say if it is not, then we can check for another condition internally. That means that either B can be greater or C can be greater. That means I can check one more condition over here, nested one. That is, if B is greater than C, then question mark, which one is greater now? B value is greater. Otherwise, what is left out is C. If we continue like this, say for example, if it is second case means A is greater than B, but it is not greater than C. So this condition is false here. So this part will be executed. What is this part is? B greater than C results in false. False means C value will be assigned into result. So that means that greatest is 20. Consider third situation. In third situation also, this condition A greater than B and A greater than C is false, because we know that 30 is greater. So here this condition fails. Else part will be executed. That means that B greater than C is true. When this condition is true, that means the first part of this one will be assigned to the result. What is there here? 30. So in this case 30 will be assigned. Let's try to implement this one using C program. First thing, how many number of variables are required? First I'll declare all the required variables here. Then give a message to the user. Let us first implement for 2 numbers, then we will implement, then we can change the same program or modify the same program for 3 numbers also. So enter any 2 numbers. Now I got 2 numbers in A and B. Okay, then I'll say result equals to, the first condition is A greater than B. If it is so, then we will assign A value, otherwise we will assign B value. Then we will print the result using printf statement. First number is A, second number is B, and the result is now stored in a variable result. Right now we don't require this third variable, so I'll just remove time being this third variable. Let us try to compile and check the result over here. Oh, there is an error over here. We have used dot instead of comma. Let's rebuild again. Here you can see no errors, no warnings. Let's proceed further. Running. Enter any 2 numbers. 100, say 50. We got the output as the largest among 50 and 100 is 100. We have read the first number. We can see over here the first number inputted over here is 100 and the second number inputted is 50. We are checking the condition over here, A greater than B. Yes, it results into true. True means A value is now assigned into which variable? Result. So now result is holding A value. That's why the largest among this message, what you are getting, largest among percentile D, largest among first percentile D is A, this number A. Then second percentile D is B, that is 50, is result. What is this percentile D is? The result one. Result is now storing A value. If we have, say for example 50 here and a value greater over here, say for example 80, then this condition fails. Whenever the condition is false, B value will be assigned to result, that will be 80. Let's test for this, 50 and 80. You can check the output over here. Greatest among 50 and 80 is 80 is the largest one. Let us quickly modify this one to work out with 3 numbers. So I'll declare a variable. Again one more variable is required. So I'll read one more variable here, that is ampersand C. So one more percentile D is required over here. So 3 numbers we are reading. Now what would be the possible changes? If A is greater than B and A is greater than C, in this situation we know that the greatest among these 3 is A. Otherwise we will start one more parenthesis here and we will check among these 2 numbers A and B. If B is greater than C, then we know that B is the greatest one. Otherwise, which one is the greatest one? C is the greatest among these 2 numbers. We will close this parenthesis over here and let us try to print the result greatest among percentile D, comma percentile D, and percentile D is, that means I have added one more thing over here, that is C. Let's build and run the program for the 3 possible one. First case, I'll give A as the greatest one, 10, 2 and 5. As we know that 10 is larger than 2 as well as larger than 5. So we got the result is to be stored as 10. Fine. It's working for all possible input values. That's all for this programming challenge. We will see in the coming videos the remaining number of programming challenge. As we proceed for taking up the topics, we will take the challenges based upon that particular topics. Hope you are ready for the next programming challenge to see in the next coming videos. Thank you. Hi. In this section, we will learn about the following. What do we mean by precedence of operators? That is operator precedence. And what is associativity of the operators? And at the end, we will see the order in which the precedence and associativity is evaluated in C language. Let us begin with understanding what do we mean by operator precedence. To understand this, let us consider if we have an expression, say C assigns the addition of two numbers, say 10 plus 20. Everyone knows how this expression is evaluated and what is stored in variable C. So what C contains now? C contains 30 because now plus is having only two operands to evaluate. So it evaluates the result 10 plus 20 and store the result in C, that is 30. And if I have another expression, say C assigns 10 plus 20 multiplied by 2, then here comes what exactly the value of C should be. Now in this case there are two possibilities. That is, first 10 is added with 20, that is 30 is multiplied by 2 to get 60 and C stores a value 60. Or first 2 is multiplied by 20, that is 40 is added to 10 to give the result 50. What is appropriate answer for this? Let's try to understand this. Here is the operator precedence. So if an expression contains more than one operators to be evaluated, then in this scenario C language uses a predefined rule for assigning the priority for the operators in the expression. Which one to be evaluated first? Just now example what we have seen, plus and star, that is multiplication, both are arithmetic operators. Which one is to be evaluated first is decided by the rule of priority named as operator precedence. So this rule of priority for the operators to evaluate is named as operator precedence. Using this operator precedence, all the expressions are evaluated by the compiler. Then let us consider now the expression something like this. Say I have an expression, result stores a plus b multiplied by c. If a contains 3, b contains 2 and c contains 6, then what would be the result to be evaluated? Is the result equals to 30 or is result equals to 15? How? If I evaluate first addition, that is 3 plus 2, then I'll get 5, and 5 is multiplied by 6 to get 30, or shall I multiply first 2 with 6 such that I'll get 12, then 12 is added with 3 to get 15. Which one is appropriate result? Here is the rule which we are going to now apply, something called as operator precedence. That means that every operator will be having some priority or weight, using which it is decided by the compiler that which one should be given the first priority to execute. So what if the expression contains multiple operators of the same priority? Here, say example, I have an expression something like this. Result assigns a divided by b multiplied by c plus d. In this expression, slash and asterisk both are having same priority. Now, which one should be executed first will be decided based upon the associativity factor. So here is, if a equals to 10, b equals to 2, c equals to 5 and d equals to 3, what would be the answer we can expect it for result to be stored? Shall result store 4 or shall result store 28? There is a lot of difference in the answer. What is that? Let us start here. How do we get 4? We have first multiplied 2 into 5, that is 10. 10 divided by 10 results in 1. 1 is added with 3 to results into 4. But if I divide 10 by 2 first, that is 10 by 2 results into 5, multiplied by 5, that is 25, which is added to 3 to results into 28. Which one is correct? This one will be decided by the associativity of the operators. That means that is arithmetic operator evaluated from left to right first, or is arithmetic operators evaluated right to left first? That is decided by the following associativity factor. So all the operators will be having predefined precedence as well as predefined associativity. Let us see now here what is associativity first. So if two operators of the same precedence, that is same priority, is available in an expression, then comes associativity of the operators, which indicates that the order in which they are going to be executed, that means slash is to be executed first or star is to be executed first in our previous example. There are two types of associativity. That is, first one is right to left. Some operators are having right to left associativity. That means that whenever they appear in the expression, they are to be evaluated only from right to left. Same way, some operators are having left to right associativity. That means that whenever they appear in the expression, they are to be evaluated only from left to right. Then what are the operators to be evaluated from right to left, and what are the list of operators to be evaluated from left to right? Let's see here. Here is the category of operators we are having. Very long list of operators are there, among which the first and most important operator which is to be executed first, come first priority basis, is parenthesis. Parenthesis will be having the first priority among all the list of operators provided by C language. Then comes square brackets. Then comes arrow operator. Then we have unary operators, that is unary plus, unary minus, negation, that is not, so on. All the unary operators are evaluated right to left. Multiplicative operators, that is arithmetic operators, star slash and percentile will have more priority or higher priority than plus and minus. You can see all these 5 operators, that is star slash percentile plus and minus, all are arithmetic operators, but among them 3 are having more priority on plus and minus. And you can see to the rightmost column, that is only unary operators are evaluated right to left, and conditional operators, that is nothing but ternary operator, is evaluated right to left, and assignment operators including equals to is evaluated right to left, and the remaining all operators are evaluated left to right. Then comes in the sequence shift left operator, shift right operator, then relational operator, less than or equals to, greater than or equals to, equality also called as comparison operator, double equals to, not equals to. Then comes in bitwise operator also there is priorities, that means bitwise AND is evaluated first, bitwise XOR is evaluated next, then bitwise OR is evaluated, followed by logical AND, that is double ampersand, logical OR, that is 2 times pipe operator, followed by conditional operator, followed by all assignment operators using plus, minus, star, slash, percentile, and so on. And at the end, comma is the operator with the least precedence. Comma will be given the least priority. These are the set of operators and their associativity with the precedence. That is, we can say the operators from top to bottom are having priorities in descending order, that is highest priority to the lowest priority. And remember, associativity is only for unary, conditional and assignment operators, whereas remaining all the operators are evaluated from left to right in an expression. Hope the concept of precedence and associativity is clear. That's all for now. We will see the remaining topics in the coming videos. Thank you.
Hi. In this section, we will learn about what do you mean by flow control, how many different types of flow controls are there in C language. Let us start with the first one. What do we mean by flow control? As the diagram here shows how the flow will be sometimes straight, sometimes up and down, depending upon the requirement. So in programming also,
we need to control such flow of execution of code. Let us try to understand this first. When we run the program, every program in C language starts its execution from main function, and by default it executes sequentially starting from the first line which is encountered in the main function, then followed by second line, then followed by the third one, and so on. Each and every statement is executed one after other. Say, if a program contains 10 lines, first line declares a variable, second line gives a message, and so on. So the program execution starts from the first variable declaration, giving a message, performing some calculation. Whatever sequence we provided in the main function, the program execution follows the same. However, there happens some situations when we need to execute some statements based upon some conditions. So it's not always going to be sequential flow of execution of the code. Example, say there are some confidential files are there which are to be displayed to the users. If user provides some authentic credentials, then only we can show the files to those users. That means here some condition arises. That is, if a user is authentic user, then only the file is to be displayed or given permission to access. Similarly, we may come across some situations in our programs when we need to execute the set of statements repeatedly. Say, for example, printing numbers from 1 to 100. The task of printing the number is going to be repeated for 100 times. So there are two solutions here. Either we can write down the numbers using printf statements by typing printf statements 100 times, or we can use some mechanism using which only one printf statement keeps on changing the value, will print the values 100 times. Obviously, the second solution is better than the first one. Say, for example, we need to send some offer emails to all clients. It has to be repeated for n number of times. Then control statements in programming handles such situations. That is first case where we need to show the confidential files only for authentic users. Conditional statements comes into picture, whereas you want to repeat some task for n number of times, then loops will comes into picture. So conditional statements, repetitive statements, whatever the names you give it, all comes under control statements. Then control statements are divided into three categories. First one includes simple if condition is true, then execute some set of statements. If condition is false, then ignore the set of statements. It is called simple if. Second type is if else. If the condition is true, execute some set of statements. Else, if the condition is false, execute another set of statements. Next, nested if condition within another if condition. And the last one is else if ladder. If some condition, else if some condition, else if some condition, so on. If we have a ladder to form, we call this one as else if ladder. So these are the four types of decision statements under control statements of C language. The second category is loops, also called as iterative statements, also called as iterations. So we can call these control statements as loops, iterative statements, or simply iterations. These includes for loop, while loop, and do while loop. And the last category of control statements is case control statements. This one is an alternative to else if ladder. There are some keywords in these control statements. If is a keyword here in the first decision control statements. Else is also a keyword. In the second one, for is a keyword, while is a keyword, and do while. Do is a keyword and while is a keyword separately. In the third one, case is a keyword and switch is also a keyword. Here in this section, we are just seeing what exactly we mean by flow control and how many types of flow controls are there. The detailed working of these flow controls we will see in the coming videos. That's all about flow controls introduction part. The remaining topics we will continue in the coming videos. Thank you. Hi. In this section, we will learn about what do we mean by decision control statements and how many different types of decision controls provided by C language. As we have seen in the introduction part of flow control, that there are three types of flow controls. First one among them is decision control statements. Second one is loops. And the third one is case control statements. Among those three, the first one is decision control statements. Decision can be made based upon certain conditions. That decision can be either true or false. So statements in a program or instructions in a program that results in either true or false are something referred to be as decision control statements. So based upon certain conditions, we want to execute some set of instructions. But that condition, what we are checking, is called as decision control statement. Zero indicates false, and any other number that is non-zero number indicates true. The outcome of decision control statements will be either 0 or non-zero. That is either true or false. The first form of decision control statement is simple if. If you remember, there are 4 types of decision control statements. Simple if, second one is if else, third one is nested if, and the last one is else if ladder. Now we will see in detail about all these 4 decision control statements supported by C language. This will be the format of simple if condition. Using flowchart, we will try to understand how exactly simple if decision control statement works. The arrow up over here indicates the flow of control which is coming, and condition is checked, if condition. The outcome of if condition will be either true or false. If the condition results in true, we can have a set of statements to be executed. And if the condition results in false, simply ignore those set of statements and the flow of control continues with the other set of statements in the program. So ignoring here indicating by using bypass, if the condition is not satisfied, then the result will be 0, that is false. The set of statements will be simply ignored. This is the first form of simple if. Let us have an example to understand simple if statement. Here is the program to display a number if it is negative. In this program, we are asking the user to enter a number. User can enter any number, either positive or negative. Now, in line number 7, we are using simple if condition. If condition is the number is a variable in which the value entered by the user is stored. If this number is less than 0, this condition will either evaluates to true or false. If the condition evaluates to true, then the printf statement will be executed and user will get the message as you entered %d, that is the number whatever entered by the user. So %d replaces the number. And if the condition is false, say for example, user has entered a positive number, say 4. 4 is less than 0, false. Simply this printf statement will be ignored. That is bypassed. So that the next statement in the program, that is at line number 9, the next printf will be executed. Suppose if the condition is true, line number 8 printf will be executed, as well as line number 9 printf is also executed. Whereas if the condition is false, simply line number 8 printf will be ignored and line number 9 printf will be executed. So by default, the program execution will be like this. Program execution starts from main function. Then a variable number is declared is of type integer. Printf statement is executed by giving a message to the user. User will be entering a number and we are reading using scanf statement. Till now it is sequential. But at line number 7, we are using decision control statement if. And if the number entered by the user is negative, then line number 8 will be executed, followed by line number 9, then 10, then the program will be terminated. And if the number is positive, line number 8 will be bypassed, that is ignored, and line number 9 will get continued execution. Then line number 10 and the program terminates. Hope with this example, if condition is clear. One more thing over here, I want to make a point. At line number 8, we are giving 8 spaces before printf statement using tab. Even if you don't give that also, the program execution will be same. No difference in the output. But this printf using tab specifies proper indentation. That means that we want to show that this printf at line number 8 belongs to if condition. That is, if the condition is true, then only this statement is going to be executed. It is not mandatory for the programmer to give a tab, but a well indented and well documented program will be having such sort of tabs such that this printf and the printf at line number 9 can be distinguished. So in the coming programs also, I'll show you all the codes in this proper indented manner. The next category of decision control statement is if else. Let us try to understand with the help of a flow chart. The up arrow indicates the flow of control of the program. When it comes to the condition is evaluated, that is executed, and the result will be either true or false. If the condition is true, then we have some set of statements to be executed. Earlier, in simple if the condition is true, we are executing the set of statement. Otherwise, we have simply ignored and bypassed that statements and continued with the next statement. Here, if the condition is true, we have the code of if to be executed. Else, that is, if the condition is false, we have the other set of statements to be executed, that is indicated by else code. So if the condition is true, if code is executed and ignoring else code, and if the condition is false, else code is executed and if code is ignored. Let us try to understand with the help of an example. Here is an example program to check whether a given integer is odd or even. Line number 1 includes a comment. Line number 2 including stdio.h. Line number 3, program execution starts from here. Line number 4, declaring an integer variable. Line number 5, asking the user with a message to enter an integer. Line number 6, reading that integer using %d format specifier, and ampersand is used for address.
Line number 7, if condition. Here the number percentile operator is used with 2. Remainder you will get, say for example, if number is 4 percentile 2, remainder is 0. So 0 matches with 0. That means it is an even number. So if the condition is true, we are giving a message to the user that percentile D, that is replaced by the number, is an even integer. Otherwise, else, if the condition evaluates to false. Say for example, if number divided by 2 results in non-zero number, then the condition is false and else part will be executed, giving a message to the user percentile D, that is the number, is an odd integer. Now let us see the third category of decision control statements, that is nested if. Up arrow indicates the flow of control. If condition 1 is evaluated, the result is either true or false. If the condition is true, then second condition is checked, if condition 2. If this condition is also true, then statement A is executed. Else, if second condition is false, statement B will be executed. Let us assume if first condition itself is false, then the flow of control comes to check the third condition. If condition 3 is evaluated and if it results in true, statement C will be executed. Else, if condition 3 is false, statement D will be executed. So after executing statement A or statement B or statement C or statement D, we are directly executing the next statement in the program, that is statement X. Here nested if is one if condition is placed within another if condition. So second condition, condition 2 is placed under condition 1, as well as condition 3 is also placed under condition 1. Else part. This type of if condition within another if condition is called as nested if. Let us see an example of nested if. Checking whether two numbers are same, or first one is greater than second one, or second one is greater than the first one. Line number 1, hash include stdio.h is a preprocessor directive. Second line, program execution starts here. Line number 3, declare two integer variables. Line number 4, giving a message to the user to enter two integers. Now at line number 6, we are executing a decision control statement. If number 1 is greater than number 2, if it evaluates to true, we have another condition. If number 1 is equals to number 2, then it is giving the result as percentile D is equals to percentile D.
else. That is, which else? This else belongs to the inner if. That is, if it is not equal. We know that number 1 is greater than number 2 because it is not equal. In the first if condition, we have checked if number 1 is greater than or equals to number 2, and within this if, the second condition evaluates if number 1 is equals to number 2. If it is false, then we know that obviously it is greater than. So the next else part will be executed as printf number 1 is greater than number 2. Say for example, the first condition itself is false. Then the else part at line number 14 is a else for if condition at line number 6. That means that the number is neither greater nor equals. That means that it is obviously less. So a printf statement at line number 15 prints result number 1 is less than number 2. Else part of line number 10 belongs to if condition of line number 7, and else part of line number 14 belongs to if condition of line number 6. One point over here to be noted is we are using flower braces everywhere, like else part flower braces start, printf flower braces closed. When we have single line to be executed, we need not include flower braces as a block. But for clear understanding of flow of execution, we have used these flower braces. So one point to be noted here is a block can contain one line or multiple lines. Better to give a block for multiple lines. Hope this example for nested if is clear. Let's move on to the last category of decision control statements in C language. That is if else or else if ladder. Here is the ladder. Let's say the first condition evaluates. It either evaluates to true or false. Let us assume that first condition evaluates to true. Then statement 1 will be executed. Else, that is if the condition is false, second condition will be evaluated. If this condition is true, statement 2 will be executed, and if this condition is also false, then the next condition will be evaluated, and so on. N number of statements, n number of conditions we can give. This forms a ladder form of statements, that is one else within another if. So it is forming a ladder. That's why it is named as if else ladder. Let us have an example for if else ladder. Same checking of two numbers for equality, that is either it is equal or greater or less, can be done using if else ladder. The same program used for nested if, we can even use it using if else ladder. First one, program execution differs from line number 8. That is, at line number 8, we are checking for equality. Let us say if number 1 is equals to number 2, then give a message to the user that both the numbers are equal. Else, if they are not equal, that is condition is false. Say one number is 4, second number is 2. So obviously 4 does not matches with 2. So condition at line number 8 is false. So else part at line number 11 will be executed to check another condition. That is, if number 1 greater than number 2, 4 greater than 2, say true, executes the printf at line number 12, that 4 is greater than 2. Let us say number 1 is 4 and number 2 is 6. So neither line number 8 condition is true nor line number 11 condition is true for 4 and 6. Therefore, else part will be executed and the printf at line number 15 gets executed, which gives a message 4 is less than 6. Hope this example gives you a clear picture about if-else ladder. Let us quickly recollect what we have seen in this section. We have seen the 4 forms of decision control statements. First one is simple if. Second one is if-else. Third one is nested if. And the last one is here if-else ladder. We will see the programs on decision control statements in the coming videos, in which we will demonstrate and execute these programs. We will continue with the remaining topics in the coming videos. Thank you.
Hi, in this section we will see a demo demonstrating the first conditional statement, that is simple if. We will use a program using simple if condition to find whether a number entered by the user is a negative number or not. The program execution starts from main function. We are declaring one variable, number, of type integer. We are giving a message to the user to enter any number, either positive or negative, and reading that number using scanf function. At line number 12 is the simple if condition. If the number entered by the user is less than 0, then the following printf statement will be executed. That is, the entered number is %d replaces the number and it will be printed. However, if the number entered by the user is not negative, then the statement at line number 13 will be ignored and statement at line number 15 will be executed. So the condition evaluates to either true or false. If the condition is true, both the printf statements will be executed, that is at line number 13 and at line number 15.
else. If the condition is false, then only line number 15 message will be displayed to the user. Let us build, check for any errors in the logs. Can see no errors. Run the program. Enter any number, either positive or negative. Let's test for both. Let us say first positive number I am entering. You are getting only one message. From line number 15, you are getting a message here. Welcome to if. Now if you see closely here, we have came across the escape sequences. 9 escape sequences we have seen. Among them, we have used /n/t. Now here we are using /double quotation mark. What for it is? If we want to display double quotation mark in the message, then /double quotation mark should be used. Now see here, as the number entered by the user is positive, that means this condition is false. So the statement followed by this if here 50 is not less than 0, so you will not get this message to be displayed. This is only for demonstration purpose. It can be any other statement other than printf statement. So based upon certain condition, you want to perform some calculation, then you can place those statements within the block of if. Let us rerun the program again to test for negative numbers. Say I am entering. So this time negative number I am entering, which is less than 0. Since the condition evaluates is true, you are getting the message as the entered number is %d replaces the value of the variable number which we have just now entered, and along with statement at line number 15 also gets displayed. So these are the possible input values what we can give. So we have seen both the outcomes here for negative numbers as well as positive numbers. That's all using simple if statement. The next video we will see about if else. Thank you. Hi, welcome to another demonstration session of conditional statements. Here we will see the second form of conditional statement, that is if else. Earlier to this section we have demonstrated simple if condition. Here we will demonstrate if else condition. Let us use this program to demonstrate if else condition, that is the program to find whether a given integer is odd or even. Line number 11 is the conditional statement. If number %2, percentile is a arithmetic operator which gives the remainder, that is modulo. Say for example, if number is 10, 10 %2 gives you remainder 0. 0 matches with 0, condition results in true. If the condition is true, printf percentile d, that is the number 10, is an even integer. Else, if we enter a number from keyboard other than even number, say for example 11 or 5 or 7, then the remainder will be non-zero, that is 1. So 1 not equals to 0, condition is here 1 equals to 0, condition is false, else part will be executed, you will get a message percentile d is an odd integer. Let us build and run the program. Enter a number, say 10. 10 is an even integer. Since the condition is true, you will get this particular message. 10 is an even integer. Let us run once again. To enter odd number. So 11 is an odd integer. This message you are getting it from else part. Printf percentile d is an odd integer. Again, we are using a block using flower braces here. It is not mandatory if a block contains single statement. That means that we can remove this statement and execute, you will get the same result. (1002) is an even integer. I'll run once again. 121 is an odd integer. So block is not mandatory if there is single statement, and it is mandatory if there are multiple statements. That's all regarding if-else condition demonstration. The coming programs we will see in the next video. Thank you. Hi, welcome to another demonstration session of conditional statements. Here in this program, we will demonstrate the third category of decision control statement, that is nested if. What do we mean by nested if? Means when if condition is placed within another if condition. Here we are showing only one hierarchy, that is one if condition is placed within one if condition. It may happen that the nested if, that is the inner if, can be again nested depending upon the requirement. Let us start over here. We are reading two numbers from the keyboard, and at line number 11 we are checking one condition with the given two numbers, whether the first number is greater than or equals to second number. This is the relational operator we are using in the condition number 1, greater than or equals to. This will either evaluates to true or false. Let us say if a number 1 is greater than or equals to number 2 is true, then the control enters the block. The second condition, that is at line number 13, will be executed to check another condition if both are equal. If it is also true, then statement at line number 14 will be executed. Else, if they are not equal, that means that the first number is greater than the second number, then only the condition at line number 13 will be false. So you will get a message from line number 16 that number 1 is greater than number 2. Else, this else at line number 18 belongs to the first if condition at line number 11. This else means if the number 1 is neither greater nor equals, that means it is less than the second number, then the statement at line number 19 will be printed. Let's see all three possibilities here by running the program. Build, check the logs, run the file to enter any two integers. We will give all possible combinations here. First possibility, first number greater than second number, say 100, and second number is say 20. Obviously, when we give this particular message over here, the first condition is true. 100 is greater than or equals to 20. So number 1 now stores 100 in the memory. Number 2 now stores 20 in the memory. And the first condition is true. Enters the block, checks one more condition. Are they equal? No, they are not equal. That means that they are satisfying the first condition, but they are not satisfying the second condition. That means else part will be executed and gives a message that the first number is greater than the second number. Here is the result. Result is percentile D is greater than percentile D. This percentile D replaces number 1. This percentile D replaces number 2. This is the first case. Let's run again to check for equal. Let's say 100 and 100. That means that the first condition is true as well as the second condition is also true. So this if is nested to this one. So this if will be executed only if the first if condition is true. So here you will get 100 equals to 100. Let's run for the third input values and say 100 and say 200. Obviously, the first condition is false. 100 is not greater than or equals to 200. Automatically else part will be executed. It never enters this block. This block will not be entered at all. So else part will be executed to get the output as result percentile D, that is number 1, that is 100 here, is less than number 2, that is 200. Hope nested if concept is clear with this simple example. Anyhow, in the coming videos, we will see more examples using all if condition, else if condition, nested if condition, as well as if else ladder as well. But here, time being, we are just demonstrating to understand the basic concepts of nested if condition. Hope the concept is clear. Okay, we will continue with the remaining topics in the coming videos. Thank you. Hi, welcome to another demonstration session of decision control statements, in which we will see the last form of decision control statements, that is if else ladder. In the decision control statements, we have already covered with simple if, if else, and nested if. This is going to be the last form of conditional statement, that is if-else ladder. While seeing the concepts of conditional statements, we have seen how a ladder is formed with if and else. A simple example to demonstrate how exactly if-else is. The same program, we are using it over here, what we have used for nested if, to check whether two numbers are same, or first number is greater than the second one, or first number is less than the second one. But the logic is somewhat different. There we have used nested if. Now we are using if-else ladder. Condition at line number 11 checks for equality of two numbers entered by the user if number 1 is equals to number 2. Say for example, if both the numbers are same, then the statement at line number 12 will get executed. And if this statement is getting executed, that means that no other condition will be checked. Assume that the condition at line number 11 is false. Then else if, one more condition at line number 14, we are checking whether the first number is greater than the second number or not. Say this time number 1 is greater than number 2. The statement at line number 15 will get executed, which prints the result as the first number is greater than the second one. Else. This else at line number 16 belongs to the if condition at line number 14. So if the first condition is false, second condition is checked, and if the second condition is also false, the statement at line number 17 will get executed as the first number is less than the second number. Let us build and run the program. We will give all possible three cases over here. Say if two numbers are same here, the first condition is if both the numbers are same. Say for example 10 and 10. Then and there only the message will be printed as percentile d equals to percentile d. Number 1 equals to number 2. Let us say for the second input values, I'll give the first number greater than the second number. So first condition is false, else if will be evaluated at line number 14 to print a message that the first number is greater than the second number. And let us see the third case of input values where the first number is less than the second number. So here in this case, first condition is false, second condition is false. Obviously the last statement in the else part will be executed. Hope with this the concept of if-else ladder, that is using if and else if in the program of C language, is clear. We will see the remaining topics in the coming videos. Thank you.
Hi and welcome to another online coding challenge from HackerRank. The next challenge in our list of challenges is using conditional statements, or you can say a problem involves if and else statement. Let us see the objective of this challenge. If and else are two of the most frequently used conditional statements in C and C++, and they enable you to execute 0 or 1 conditional statement among many such dependent conditional statements. We use them in the following ways. If this executes the body of bracketed code starting with statement 1 if condition evaluates to true. As you are familiar with if else ladder and nested if else. So let us directly jump into the task. Very simple problem this one is, and the task is, given a positive integer denoted with a variable n, we have to do the following things. First one is n is minimum 1, maximum 9. Then print the lowercase English word corresponding to the number. Example, 1 for numerical 1, 2 for numerical 2, etc. If n is inputted as greater than 9, then print this message, that is greater than 9. Input format is, the first line contains a single integer denoting n, and the constraint is n value should be in the range of this one. Output format, n is between 1 and 9, then print the lowercase of English word corresponding to the number, otherwise print this message. Say for example, numerical 5, English equivalent word 5, then for numerical 8, 8. If it is 44, then this message has to be printed. Very simple one, as we have already solved it, so this doesn't take much time. So let us quickly write down the code and try to see how exactly it works. Here is the place where we have to put down the code. Required variables, I need a variable n, so I'll quickly declare the variable and I'll read the contents from the keyboard. So once I got the value in n, I'll check the condition over here as, say, if n equals to 1. What I have to print it in this one is, I have to print ONE1, that is English equivalent word. From here onwards, I have to put else part. So else, again one more if condition, n equals to 2. Now I'll copy down the code from here. So till now we have done it till 9. Else for the last time, if it is not in the range of 1 to 9, we have to give a message. So very simple thing, we have declared an integer variable, read that variable. If it is numerical 1, print 1, if it is 2, then 2, so on up to 9, otherwise else. Need not check if condition here, just print greater than 9 for any value. Let us run the code. Here is the sample test cases are cleared. Congratulations is the message what we got it. Let us submit the code and check. Yes, it has cleared all the test cases and we have earned 10 points. So now the score is 125 out of 200, which you can see it over here. Now 75 more points to get it the next star. So a very simple problem, similar to this problem we have already solved it. So we just earned 5 more points with this challenge. We will continue with the remaining challenges in the coming videos. Thank you.
Hi. In this section, we will learn about the following. What do we mean by case control statements? How case control statement works? What is the syntax of using case control statements in C language? And at the end, we will see an example which demonstrates the usage of case control statements in C language. Case control statements are the third category of flow control statements in C language, where we have already covered the first two, that is decision control statements and loop control statements. This is the third among the flow control statements in C language. Case control statements are commonly referred as switch case or simply switch statements. there are two keywords used here. One is case, another one is switch. So it is commonly known as switch case statements. The switch statement allows us to execute one code block among many alternatives available. There are multiple options are there where you want to execute any one of the option among the given set of options. Then switch is the correct choice in this particular scenario. A switch statement tests or evaluates the condition with the value of a variable and compares it with multiple options, that is, you call it as cases. Once the case match is found, a block of statements associated with that particular case gets executed. Let us see the working of switch case. There are two keywords used over here. One is switch, another one is case. One condition is evaluated at the beginning using switch keyword. Once the conditional statement gets executed, it evaluates some value. Based upon that values, we provide some cases. 1, case 1, case 2, case 3, so on up to case n. If the conditional statement evaluates matches with the first case, that is true, then the statements under case 1 will get executed, and it is mandatory to use a keyword break. What happens if we don't use break, and why we should use break, we will see at the end of this section. Then, if conditional statement matches with case 2, automatically the second case statements will get executed. Or if it matches with case 3, or so on up to n cases. Let us say if the conditional statement evaluated at the top does not matches with any one of the cases provided here, then the default statement will get executed. After executing statement from case 1 or statements from case 2 or statements from case 3 or statements from default case, statement after switch will get executed or outside switch case block. Here is the syntax for switch case. The expression or the condition is evaluated at the top. Then case 1. If the expression matches with the first case value 1, then statements under case 1 will get executed. Otherwise, if expression evaluated matches with the value 2, statements under case 2 will get executed, and so on. Now if you see carefully over here, we have not given break statements for case 1, case 2, but we have given break statements for case 3 and case 4. What happens? The flow of execution will be something like this. The expression will be evaluated first. The value of the expression will be checked with case 1. If it matches, it executes the statements under case 1. Let us say in the first instance 1 matches with the value evaluated by the expression. Then here statements under case 1 will get executed, statements under case 2 will get executed, statements under case 3 will get executed, and then when break is encountered, the control comes out of the switch case block. Since we have provided a break for case 3, let us say if the value evaluated in the expression matches with case 2. So the flow of execution will be start from case 2, then case 3, then it terminates when break is encountered. That means that a break is mandatory for all cases provided in the switch block. So that when case 1 gets executed, control should come out of the switch block so that no other cases should get executed. Similarly, if expression evaluates a value which matches with case 3, then directly case 3 will get executed. When break is encountered, it will not go to case 4 or any other cases after case 3, and control will come out of the switch block. And the last point over here is, if there is no match with any of the cases provided, neither 1 nor 2 nor 3 nor 4, none of the cases matches, then the statements under default will get executed. So default here is a keyword. Even switch is a keyword, case is also a keyword, break is also a keyword. Similarly, default is also a keyword, and all cases along with default should contain a colon followed by the set of statements. If it is single statement, there is no braces required. If there are multiple statements, then flower braces are required for each cases. Hope this syntax is clear. Let us now move on to see example using switch case. This program demonstrates the syntax of switch case in C language. The current value of x over here is 3. 3 now matches with 1. Case 1 does not matches with 3. Case 2 does not matches with 3. Case 3, yes, 3 matches with x value 3 here. Flow of control executes case 3 statements. Let us assume if x value is other than 1, 2 and 3 here, then by default, that is the default keyword will get executed. So statements under default is choice other than 1, 2 and 3 will get a message to the user, and break will terminate the block of switch. We will see a detailed example demonstrating switch case statements in the coming videos. So for now, that's all regarding case control statement. We will see the remaining topics in the coming videos. Thank you.
Hi and welcome to a programming challenge. We have to find the largest among 3 given numbers using if-else condition. The same problem we have already solved using ternary operator. The only thing is we need to place this one using if-else condition. Let's quickly describe the problem statement over here. We will be given 3 input values A, say B and C. Here there are 3 possibilities. What are those 3 possibilities are? Let's describe it over here. Say for example, A is the largest among 3 numbers. Second case, consider B is the largest among 3 numbers. And third case, consider C is the largest among 3. In this 3 scenarios, we have to check the condition and it should satisfy all 3 possibilities. How do we achieve this one is, say for example, let's start beginning with if. If A is greater than B as well as greater than C, that means that here we should have both the conditions to be satisfied. So we will be using one operator over here, logical operator. This one is logical AND. If the condition is to be true, then first condition should be true as well as the second condition should also be true. So if A is greater than B as well as A greater than C, then we know which one is largest one. A is the largest one. So we can give a message to the user using printf statement that A is the largest one. Otherwise, else, the next condition. What would be the next condition? Here, if it fails, any one of this condition fails, either this one fails or this one fails, we know that either B is greater or C is greater. Here the condition is B should be greater than C, then only we can give a message that B is largest one. That means that B should be greater than C. Then only we can give a message that B is the largest one. Else, we know that which one is the largest one among this? Here is the scenario. C is the largest one. So here A is largest in the first case, second case B is largest, otherwise C is the largest one. Simple if else can be used to achieve this particular task. Let us write down the C program. Let's quickly declare the required number of variables over here, A, B and C, and say give a message to the user to read all the three numbers. Now once we got all three values in these variables A, B and C, we can check the condition now. A must be greater than B as well as A must be greater than C. Then only we can give a message to the user. This is the message we are trying to print is %D is the largest among these three. So A is the largest, what we are trying to print over here. Otherwise, we will check one more condition. What is that one? If B is greater than C, that means that here we are checking the condition as A greater than B and A greater than C. We will get this message only if this condition is true as well as this condition is true. Then only the condition evaluates to true. Otherwise, else, we know that either A is not greater than B or not greater than C. That means we will check the condition B is greater than C. Then in this scenario, B is the largest one. Otherwise, if it is true, otherwise means false, we know that C is the largest one. Let's proceed over here. B is the largest one is the message. Else, C is the largest one is the message. Let's try to build and check the output. First one, let's give A as the largest one, 100, 20 and 50. The message what we are going to get over here is 100 is the largest among 100, 20 and 50. Let's give another input where B is the largest one. Here we can see the output. 60 is the largest among 20, 60 and 33. And for the last test of input values gives the largest one is say C. Here is 80 is the largest among 50, 40 and 80. Perfect. So here using if else, if this condition is true, we are giving that A is the largest one. Otherwise, either B is greater or C is greater. So if this condition is true, this is the message that B is the largest one. Otherwise, C is the largest one. Hope you got the solution for this programming challenge. We will continue with the next programming challenge in the coming videos. Thank you. Hi and welcome to another programming challenge. Here the problem statement is find the roots of the quadratic equation given is ax square plus bx plus c equals to 0 and comment upon the nature. Those who are from mathematical background knows exactly how we find the determinant. Anyhow, I'll show you how to find the determinant as well. If the determinant is equals to 0, the nature of the roots are real and equal, and if the determinant is less than 0, nature is roots are imaginary, and if the determinant is greater than 0, the nature of the roots are real and unequal. Make a note over here that roots will be evaluated only if the determinant is either greater than or equals to 0, not for the case of less than 0. That is, roots will not be evaluated for this particular scenario. Roots will be evaluated for these two situations, that is either 0 or greater than 0. Now, I suggest you to pause the video and pen down the logic and write the program. If you want some solution guidelines, then you can proceed further. Here are the solution guidelines to find the roots. First, what we need to do is to find the determinant, and the determinant is found by using b square minus 4ac, and the roots are evaluated only for two possible cases, that is for equals to 0 or greater than 0. So these are the two roots which are evaluated as minus b plus 1 root minus b minus square root of b square minus 4ac by 2a. We have a mathematical function provided by C language as sqrt, which is available in a header file math.h. Using these guidelines, you can continue to find the solution of this programming challenge, or you can watch the next video to find the solution. Thank you. Hi and welcome to the solution for the programming challenge to find the roots and the nature of the roots. The problem is, we will be given a quadratic equation of the form ax square plus bx plus c equals to 0. Here we need to have the input values as a, b and c. Using this a, b, c, we will be finding first thing is the determinant. Determinant will be found as b square minus 4ac. Once we know there are three possibilities over here, it can be equals to 0, it can be less than 0, or it can be greater than 0. If it is equals to 0 here, then roots are real and equal. If it is less than 0, then roots are imaginary and we need not calculate the roots over here in this case. If it is greater than 0, it is real and unequal. In these two situations, we need to find the roots, and the roots will be calculated as, say, root 1 will be given as minus b plus under root of b square minus 4ac by 2a, and the second root will be calculated as minus b minus under root of b square minus 4ac by 2a. First thing what we need to calculate is this part, determinant. Then we can say whether the root is imaginary, real and equal, or real and unequal. Then if it is less than 0, we need not find these roots. Otherwise, these two roots will be calculated and stored in some variables and print this one. The only thing we need to concentrate over here is we have to find the square root over here. Using a function we can use sqrt, which is available in math.h. So by keeping these things in mind, let us write down the program. First thing is, let us read the values from the user. Once we are done with reading the values, let us first declare these variables as well. The required number of variables are a, b and c is of integer type, and we need to store the result of determinant. So I'll be declaring a determinant over here. Simultaneously, root 1, first root I'll say r1 and second root I'll say r2 are the variables which are required. Let us calculate determinant over here. Determinant is nothing but b square. B is multiplied 2 times, so I'll just write it down, b multiplied by b, that is b square, minus 4ac, that is 4 multiplied by the value of a multiplied by the value of c. Result is now stored in determinant. First thing what you can check the condition is if the determinant is less than 0, then you know that it is going to be the imaginary roots. When roots are imaginary, we need not continue. Otherwise, what are the things we have to consider it over here? If roots are not imaginary, then we have to find the roots as well. Let us say R1 is the first root. Minus B, since it is unary minus, I'll place it in parenthesis, minus B plus SQRT is the function what you can use it. We have already found the determinant over here. We have found the determinant and the result is stored in a variable det. That det we can use it over here. Determinant. This determinant, it should be divided by 2 multiplied by the value of a. Similarly, I can use the same one to find the second root. Only difference is, and the root is now minus. Since we are including SQRT function here, we have to declare #include math.h. This is the header file required for SQRT function. Now, once we are done with calculation of these two roots, now it may happen that the determinant can be equals to 0. If it is equals to 0, then the nature of the root is real and equal, else real and unequal. Once we are done with this, let's see what we have done here. Here are the variables required. ABC are of integer type and determinant. Since determinant is of float type and roots are also of float type, we have declared it as float. Reading the values of ABC, finding the determinant, and if it is imaginary, no need to calculate the roots. Otherwise, calculate the roots and comment upon their nature. Nature, if it is equals to 0, real and equal, otherwise real and unequal. Let's build and run the program. ABC 2, 3 and say 4. Roots are imaginary. Let's see how the values are calculated here. B square minus 4AC, that is nothing but 3 into 3 minus 4 into 2 into 4. 9 minus 32 will give you minus 23. Yes, roots are imaginary here. Let's run for another input value. Let's run for another input values. Here it is. Let's see B square minus 4AC calculation here. B square is 25 minus 4 into 2, 8, 8 3s, 24. That is 1. So it is not equals to 0. It's greater. So it says real and equal. Similarly, you can check for the third input value, that is equal as well. Let's run for the third input value. This is the third input value what we have. So here B square minus 4AC will be 4 square is 16 minus 4 into 2 into 2. That gives you 16 minus 16 is 0. That is nothing but real and equal. So we got all three possibilities over here. Equals to 0, less than 0 as well as greater than 0 also. Hope this one matches with the solution. That's all for now. We will see the remaining challenges in the coming videos. Thank you. Hi and welcome to the programming challenge. In this programming challenge, let us see the problem statement. Energy charges in electricity bill. We have to find the energy charges consumed in electricity bill of a customer. Let us try to see the case study first here, what this case study tells. Here, electricity consumption is recorded in terms of kilowatt hour, or you say simply units, by the electricity meter installed in our premises. A kilowatt hour is equivalent to running an appliance of 1 kilowatt, that is 1000 watts, for 1 hour. Here is the main point. What we need to concentrate is the meter reading is subtracted from the previous meter reading to come up with the units consumed for the period. The units consumed are then applied to a slab-based tariff structure to come up with energy or electricity charges. Every electricity department will have their own tariffs. The tariff structure, what is provided over here, is as follows. Say, for the first 200 units consumed, we have 0.5 per unit. The amount is to be charged. Next, 200 units, that is from 201 to 400. The amount is to be charged 0.65 per unit. Next 200 units, that is from 400 to 600, are charged based upon this value 0.8 per unit, and anything which is above 600 is charged based upon 0.9 per unit. Now this amount can be anything, that is it can be a dollar or pound or any currency. Now our problem over here is to find the charges of the electricity bill generated based upon the tariff structure shown here. Now what I suggest you is to pause the video and pen down the logic and calculate the amount charges and find the total charges of the electricity bill. For those who are interested in some guidelines, they can follow up here, they can continue in the video. Here are some of the solution guidelines which we will be discussing over here, which may help you in finding the solution easily. Here are some of the solution guidelines. Here are the charges as per the tariff structure what we have seen just now. First 200 units, charges are 0.5 per unit, and for the remaining 200 units, that is from 201 to 400, the amount is to be charged is 0.65 per unit. Similarly, from 401 to 600 and above 600, 0.9 per unit is to be charged. Now, what would be the possible calculation over here? Let's see. For the first 200 units. First 200 units, let us assume that the number of units can be anything less than 200 or equals to 200. If I am assuming that if number of units are say 150, then that value I am considering it over here as say A, that is the number of units. If it is less than or equals to 200, that will be say 150. If it is multiplied by 0.5, then this value is A1. I am assuming this particular variable as say A1. So this particular amount is going to be 75. For the remaining 201 to 400, let us assume that the number of units consumed is in between 200 to 400. Then the charges before 200 is already calculated, that is 75, which is there in a variable say A1. Now is to be added over here. So that A1 is to be added with the remaining set of calculation, that is to be performed with 0.65 per unit. 0.65 per unit is for the number of units in between 201 to 400. Say if it is 300. For 200, we have already done the calculation here, that is stored in A1. So that plus only for 100, 0.65, it is going to be 65 plus 75. What is going to be generated over here is 140. Say for example, if it is between 401 to 600, then same thing, I am going to repeat it over here. The result what we obtained it over here, that is B1, is now going to be added with the calculation of 0.8 into C. And for the remaining D units, we are calculating it over here. And for the remaining D units, we are calculating it over here. C1 plus 0.9 multiplied by D is going to give you D1. So the total charges can be any one among this. It can be A1 if the number of units ranges from 0 to 200, otherwise it will be B1 if it ranges from 201 to 400, Same way it will be C1 if it ranges from 401 to 600, and it will be D1 if it is greater than 600. Let us take an example over here. Say I have the number of units are 530. First 200, same tariff structure we are taking it over here. Let us say for first 200 units, it will be calculated something like this. 0.5 multiplied by first 200 units will give you 100. And for the remaining 200s, that is 100, whatever we have already calculated, plus now the number of units are multiplied by 0.65 and 200. So total number of units consumed till now is 400 units. 100 plus 130 it is. So it will be 100 plus 130 will give you 230. Let us say the remaining, how many remaining are there here? We have already subtracted, we have already done the calculation for 400. So how much are left out? 130 units are left out. So it will be 230 plus 0.8 multiplied by this 130 units. What is left out? Will give you 230 plus 0.8 multiplied by 130 will give you 104, which will result it into 334 is the total charge for 530. Hope this will fetch you some idea to put down the code and solve the problem what we have seen just now. All the best for the solution. Those who wants to see the solution for this one, they can watch the next video and match the solution. Thank you. Hi and welcome to the solution for the programming challenge of generating the electricity bill charges. The charges are calculated based upon the tariff structure what we have seen. Let us quickly recollect the tariff charges. If the number of units are less than or equals to 200, the amount to be calculated as 0.5 per unit, and if the number of units are between 201 to 400, then it will be 0.65 per unit, and if it is between 401 to 600, it will be 0.8 per unit, and anything greater than 600 units should be calculated with 0.9 per unit. Now based upon this data, let us say first of all declare the required number of variables. Say I am saying number of units and the charge. Let's read the number of units from the user. Once we are done with reading the number of units from the user, first thing what we need to check is whether user has entered correct number of units or not. Say if the number of units are less than 0, then immediately give a message to the user and terminate the program. Now if the number of units are less than 0, we are giving a message to the user and terminating the program. Let us say if it is not less than 0, then we have to perform the calculation as follows. First thing is check if the number of units what is entered by the user is ranging from 0 to 200. So I am using over here and because it should be greater than 0 as well as the number of units must be less than or equals to 200. If it is so, the charges are going to be 0.5 multiplied by the number of units. Else, if the number of units might be ranging 201 and number of units less than or equals to say 400. In this case, we will calculate the charge as follows. Charge is equals to first charge is now going to be already done for 200 units, that is multiplied by 0.5 gives you 100. So 100 added with the calculation, that is 0.65 multiplied by, we have already done the number of units for 200, so just subtract this for 200. Okay, if it is in the range of, else if, what would be the range? Between 401 to this one, then the charges will be, this time it's going to be minus 400, and the calculation should be done with 0.8, and we have to add 230, that is the charge from the previous calculation. Same thing, if anything which is greater than 600, anything which is greater than 600 will be now calculated as 390 plus, here the charges are going to be done with respect to 0.9 subtracted from 600. Now we got the output in charges. Once we got the output in charges, just print it using printf statement. The total charges are percentile. Now once we are done with this, let's try to build and run the program. Here the number of units consumed, say same example what we have seen, say 530 I'll give. You can see the total charges are 334. How it is done? Let us take an example. Let us see how this calculation is done over here. We have number of units as 530 in this example. First 200, that is multiplied by 200 will give you 100 first of all. Then remaining 200 will give you 130. Now the left out units. So here we have done with 200. Here we are done with 200. Here we are done with 200. So 200 plus 200, 400 units are already consumed. So how many number of units are left out is 130. 130 units which are here currently, 530 minus 400 will give you 130. 130 multiplied by 80 will give you 104, that is 104. 104 added with 230 will give you over here as 334. So this is how it's going to be done. This is one example with the range of number of units is less than 600. Let us take another example. Let us take this time an example of number of units as more than 600. Let us say 700. Let's see now. The number of units are 700. How the categorization of this 700 will be? First 200, then next 200, next 200, and we are left out with 100 more. So for this 200, it is going to be, amount is going to be this 100 plus. Then for the remaining this one we have 230 plus. Then for the remaining we have 390 plus. 390 plus the remaining amount that is left out over here, that is for 100 units multiplied by 0.9 will give you 90. So 390 plus 90 will give you the answer 480. Hope this matches your solution. We have seen two different input values. You can work out with remaining input values as well. That's all for this programming challenge. We will see the remaining programming challenges in our coming videos. Thank you.
Hi. In this section, we will learn about what do you mean by loop control statements, how many different types of loops provided by C language. Let us recollect the concepts of flow control statements we have already covered in a separate video. There are three types of flow control statements provided by C language. First one, decision control statements, includes simple if else, nested if, and else if ladder. And the second category of flow control statements are loops, includes for loop, while loop, do while loop. And the last category of flow control statements are case control statements. So loops is the second type of flow control statements. Let us try to understand first of all, what do we mean by loops? A loop is a set of statements which gets repeated, also called as iterations. Say, for example, there is a task of printing a number from 1 to 100. This can be done in two ways. First, use printf statement in C language 100 times, or use a mechanism of loop control statements and use printf only once by changing the value to be printed. Obviously, the second mechanism is better than the first one. Now, this is just a simple example to understand where exactly loops comes into picture. So, iterations or loops are used in a programming language to repeat any task for n number of times. Let us come to the types of loops provided by C language. There are three types of loops which are provided by C language: while loop, for loop, and do while loop. Loops in a programming language plays a very crucial role because it develops the programming skills of a programmer. Whatever logic a programmer wants to develop, loops are the best place to develop their programming skills. So we will focus on these loops in detail. First, we will see each loop working in a separate video. We will have a separate video for working of while loop, a separate video for working of for loop, and a separate video for do while loop. Then we will see all possible combinations of the loops, that is, a for loop within another for loop called as nested for loops, also a for loop within while loop, and a while loop within for loop, and so on. So this video is just to give you an introduction about loops and how many types of loops are there in C language. Now, in the coming videos, we will see all these types of loops in detail. Thank you. Hi, in this section, we will learn about how while loop executes, What is the syntax to be followed for while loop in C language? And at the end, the detailed working of this loop. Let us start with the flow of execution of while loop. The arrow at the top specifies the flow of execution of program control, which now executes the while loop. First thing is a condition is evaluated using a test expression, and the test may result into either true or false. If the condition or test evaluates to be true, then the flow of control enters the block or the body of the while loop will be executed. After executing the statements under while loop body, then the flow of control again goes back to test the condition once again. Again, if the condition is true, the same thing is repeated. That is, the body of the while loop gets executed and the condition is tested again. This process is repeated until the test expression results in false. Once the test expression results in false, the while loop terminates. So I'll repeat once again. First, the condition, that is the test expression, is evaluated, and if the condition evaluates to true, then the body of the while loop gets executed, and again the test expression is evaluated, and this process is repeated until the test expression evaluates to be false. Once the condition or test expression evaluates to be false, then the body of the while loop gets terminated. Let us now see the syntax. How do you write down the while loop in C language? Here is while is a keyword followed by opening parenthesis and condition or test expression, and at the end closing parenthesis. Within this two parentheses, we can provide a test expression or conditional expression. If it results in true, the statements here gets executed, and again the control goes to test the condition, and the process gets repeated. That is, the statements will get executed again if the condition is true, and if the condition is false, the while loop will be terminated. That is, the flow of control will not enter the block of while loop. Then immediately the next statement after the while loop body will get executed. Let us see the detailed working of while loop. Here is a simple example. The first line here declares a variable called as power, which is initialized to 1, and it is declared as integer data type. This statement is called as initialization, and it is not a part of while loop, and it must be declared before while loop starts. So any type of initialization should be carried out before starting the while loop. Now, while is a keyword. Within parenthesis, we have a condition over here. That is, power less than or equals to n by 2. Whatever condition is there, if it results into true, then flower braces specifies the body of the while loop. In this example, we are using only one statement, that is power equals to 2 into power.
we may have multiple statements to be included within this body of the while loop. We have already came across this part that braces are optional. It's not mandatory if it consists of single statement, but braces are mandatory if there are multiple statements to be executed simultaneously. I'll repeat once again. Before starting the while loop, whatever initialization is required, we can have initialization before the while loop. Then comes while, condition checking. If the condition evaluates to true, flow of control enters the block, execute the set of statements, again checks the condition, and if the condition is again true, again enters the block and again executes the set of statements. And this process is repeated until the condition specified here is false. This is just an introduction part of while loop. So what we have seen is how while loop gets executed, what is the syntax of while loop, and the detailed working of while loop. Hope the concept of while loop is clear. In the next video, we will see the next loop control statement, that is for loop. And one more thing, we will see a demo demonstrating a while loop in the coming videos. Thank you. Hi, in this section, we will see a demonstration of the working of while loop in C language. Here, in this program, we are trying to find the factorial of a given number. Here are the required variables. We have declared it over here of type integer. For storing the factorial of larger numbers, you can even declare these as long int as well. User will be entering a number, reading it using scanf. Next part is the initialization part. As we have already seen the basic concepts of loops there, the syntax specifies initialization takes place before while loop starts. So in this initialization part, we are initializing the variables factorial as well as I. I is an index using which we are iterating it. So the variables are number using which we are reading the number. I is an index using which we are iterating through the loop, and factorial is a variable in which the result factorial is stored. Let us see the working of while loop here. While I less than or equals to number. Let us assume here number equals to 5. I value is currently 1. 1 less than or equals to 5 is true. The control enters the block of while loop. Execute two statements over here. Factorial multiplied by I value and store the result back into factorial. So for the first time, factorial is 1, I is 1, 1 into 1, 1 is stored. Then I plus plus makes I value to be 2. The next time the condition checked is 2 less than or equals to 5 is true again. Enters the block. Factorial is equals to current factorial value is 1 and current I value is 2. 1 multiplied by 2, factorial now stores 2. I is incremented now, that is 3. 3 less than or equals to 5 is true. Enters the block. Factorial is equals to current factorial value is 2. 2 multiplied by 3 is 6.
So factorial now stores 6. I value is incremented to 4. Next condition check is 4 less than or equals to 5. Again true. Enters the block. Current factorial value is 6 multiplied by current I value is 4. 6 multiplied by 4 is 24. Is again stored back in variable factorial. Now I value is incremented to 5. 5 less than or equals to 5. Again the condition is true. Factorial current value is 24 multiplied by current I value is 5 and the result is 120. Stored back the result into the variable factorial. This time when I value gets incremented, I value is now 6. So while 6 less than or equals to 5 condition is checked and the test expression fails here, the result is false because 6 less than or equals to 5 is false. The control comes out of the while loop and executes the next immediate instruction, that is at line number 21. We will get a message as the factorial of percentile d replaces the value of the first variable, that is number. So you will get it as the factorial of 5 is percentile d next replaces the value of factorial, which is now storing 120. Let us build and check for any errors here. No errors. Let us run and check the output. Enter a number to find the factorial. Let's say 5. The factorial of 5 is 120. As we have seen the detailed working, we are getting this message. We are entering a number here. Logic is here. And finally, we are getting the output using this particular printf statement. Let's enter another value. Factorial of 6. 6 multiplied by factorial of 5 is 120. So 120 multiplied by 6 gives you 720 again. So this program is used to just demonstrate the working of while loop. I hope the concept of while loop working is clear. We will see more examples using while loop as well as other loops, and we will see the logic, how to solve the problem and how to develop the programming skills. We will continue the remaining topics in the coming videos. Thank you. Hi. In this section, we will learn about how for loop executes, what is the syntax to be followed for loop in C language, and at the end, the detailed working of for loop. Let us start with the first one, that is the flow of execution of for loop. For loop is the most common loop used in C language, and it is the easiest one of all the loops. It consists of 3 parts: initialization, condition checking, also called as test expression, and third one is updating the expression. Usually update expression is carried out using either increment or decrement operator. We will see with the different examples.
Let's see the first part, initialization. In while loop also, initialization takes place before while loop gets start. But in for loop, initialization is a part of for loop. Then the condition is evaluated, that is the text expression is evaluated, and if it results in true, the body of the for loop gets executed and the expression is updated. And again the test expression is evaluated. If the condition is true again, then the body will be executed and the process continues until the test expression evaluates to be false. Once the condition becomes false, the for loop terminates. Let us see the syntax of for loop in C language. Here is for is a keyword, then we have initialization. Here we are showing you the step-by-step process. First step that takes place in the execution is initialization. Then from initialization, the control goes to check the condition. Then the condition either evaluates to true or it evaluates to false. Assume that if the condition evaluates to false, so you can see here 3b, if false, an arrow that is coming it outside, that is line number 7, statements outside the loop. Assume that the condition is true, that is 3a. If it is true, then the control comes to execute the body of the loop, that is statements to be executed within flower braces. Again, if there are multiple statements, then flower braces are mandatory. If there is single statement to be executed within for loop, then flower braces are optional. After executing the set of statements, step number 5 goes to update. Once the updation takes place, that is the 6th step, the control goes to condition checking again. Say this time also, if the condition is true, then 3a will be executed, so that the control again comes to execute the statements under the body of the loop. Otherwise, if the condition is false, then the control comes outside the for loop, that is directly the 7th step, statements outside the loop will be executed. Let us quickly have a review of what we have seen here. First step is initialization. We can perform initialization of variables if it is single variable or multiple variables also permitted. If there are multiple initializations, then we can use comma operator to separate two initializations. Then once initialization takes place, the control goes to second step, condition. Condition may evaluates to true or may evaluates to false. First, let us assume if it is true, 3a. Fourth step, control comes to flower braces to execute the statements under the body of the loop. Then, after the last statement gets executed, step number 5, control goes to updation. Whatever updation requires, we can update the value. After updating it, control again goes to check the condition. Now, this condition will be always either true or always be either false. if there is no updation provided. So it is always a programmer's responsibility to provide a proper updation. Once the updation takes place, control goes to condition checking. This process repeats until the condition is true. Once the condition becomes false, then 3b, if false, control directly goes out of the for loop to execute the statements outside the loop. This is the most common loop used in C language, and it is easier for understanding because all three things are placed within the same parenthesis. And one more thing, initialization, condition checking and updation are separated using semicolon. And all these three things are placed under parenthesis, left parenthesis and right parenthesis. Hope the syntax of for loop is clear. Now we will go to see the detailed working of for loop. Take an example here. Initialization expression over here or initialization step is initializing a variable I equals to 1. Depending upon the problem requirement, we can initialize the variable either to 0 or 1 or 10 or any other value. Once this initialization takes place, the second step is control goes to check the condition, and if the condition is true, then the control comes to execute the body of the loop. After executing the body of the loop, the control goes to update the expression. Earlier I was 1, now I value is incremented using increment operator, that is post increment operator. Here you can provide either pre-increment or post increment. Doesn't make any difference. Where it makes the difference is in the expressions. So after updating I value, control again goes to check the condition. So now next time I value is 2. So the condition is checked again. First time 1 less than or equals to 10 is true. Second time 2 less than or equals to 10 is true. Third time 3 less than or equals to 10 is true. Fourth time 4 less than or equals to 10, and so on. And the last time 10 less than or equals to 10 is true. The loop body gets executed for the last time, and then I value gets incremented such that I will be now 11. So now check the condition. 11 less than or equals to 10 is false. Now the loop gets terminated. That is your 3b will get executed because the condition is false, and the control goes to execute the 7th step, that is the statements outside the body of the for loop. Hope this working of for loop is clear. Anyhow, we will see with an example of for loop in the coming video to demonstrate the for loop in detail. The coming topics we will see in the next video. Thank you.
Hi and welcome to the practice program. Here in this program we will see how exactly the ASCII values are accessed in C language. First of all, what do you mean by ASCII value? ASCII stands for American Standard Code for International Interchange, where every character will have its decimal, octal and hexadecimal values. So we have a set of the alphabet set that is supported by C language in both the cases, that is from capital A to capital Z and from small a to small z. will have its ASCII value stored in computer's memory, and these ASCII values are, for uppercase, ASCII value starts from 65, then 66, then 67, so on up to the last one is 90. Same way, small cases also have ASCII values as starting from 97, 98, then 99, and so on. The last one is 122. If you observe over here, capital A, that is uppercase A, and small case a, ASCII value, the difference is 32. So if at all you want to change the case from upper to lower, you have to add the ASCII value 32 and reverse. If you want to convert from lower to upper, you have to subtract the ASCII value 32. Then you can get its equivalent upper or lower cases. First of all, what we are doing it over here is we are declaring one character variable I, and this character variable I is now taking the first character as the starting character A and the last character is Z. We are incrementing the value of I and trying to print first one is the character, that is I. The ASCII value of, say for the first time, small a will be printed here, and its equivalent ASCII value is printed in decimal form. So this I value, same I value printed in decimal will be its equivalent ASCII value will be printed, that is 97. Next time it will be incremented and pointed to B, and we are printing it over here. ASCII value of B is, the next one is percentile D1. Same way it will go on and print till the last ASCII value. Then another for loop, next time we are printing the upper cases. Uppercase starts from here, capital A to capital Z. Same thing we are trying to print it over here is first I. This time percentile C now gives you capital A, and its equivalent ASCII is now going to get 65. Same way in the loop, when I is incremented, the next character, then so on until which character we are accessing it, the last one is Z, capital Z now gives you the last ASCII value is now going to be 90. Since these are multiple data elements we are accessing it, we have a loop over here both for lowercase as well as for uppercase. So this program is just meant for demonstrating how exactly the ASCII values are accessed. So whenever you say percentile C, character will be printed, same value I, percentile D if you are printing, its equivalent ASCII value will be printed. Okay, now let us build and check for any errors here in the logs. No errors, no warnings. So let us run and check the output. Here you can see the ASCII equivalent of small a starting from 97, then 98, then 99. Alphabets are moving on till here small z is 122, and immediately after that one more for loop we are using to print uppercase A, equivalent is 65, and so on till the last one, that is Z, is 90. This is just to demonstrate how exactly the ASCII values are used in C language. That's all for now. We will continue the remaining topics in the coming videos. Thank you.
Hi, welcome to the demonstration session of for loop. The program is used to demonstrate here is the same program what we have used for demonstrating the while loop, that is finding the factorial of a given number. Here is the logic only that changes is in line number 14. Instead of while loop we have a for loop here. Now you can see the difference is there. In the while loop we required some initialization. That initialization we have done it before. Now you can do is you can remove this initialization and place it using a comma operator. So multiple initializations, if at all we have, we can provide multiple initializations using comma operator. So two initializations are required, one for an index I to iterate through the loop, another one factorial which is going to store the result. So it is initialized to 1, and the second part of for loop is condition checking, that is until I less than or equals to number we have to iterate the loop, and the last part is updating, that is changing the value of the index through which we are iterating it, that is incrementing it, I plus plus. Even you can use plus plus I also here, both are same. Within the loop we have only one statement, that is factorial multiplied is equals to, that is assignment operator we are using, multiplication is equals to, which means that factorial is equals to factorial multiplied by I. Let us see the working over here. I is initialized to 1, factorial is initialized to 1. Let us say, take an example, number is 5. So 1 is less than or equals to 5, true. Enters the block. Execute the statement, factorial is equals to factorial multiplied by I. So I is 1, factorial is 1. So for the first time factorial is 1. I value gets incremented. Next. Then checks the condition again after incrementing. Yes, 2 is less than or equals to 5, true. Again enters the block. Factorial is equals to, current factorial value is 1 multiplied by 2, result now stored is factorial 2. I is incremented, so I value is 3 now. 3 less than or equals to number is true. Enters the block. Calculate factorial is equals to, current factorial value is 2. 2 multiplied by 3 is 6. 6 value is now going to be stored in factorial. Again I is incremented, that is 4. 4 less than or equals to number, true. Enters the block. Factorial is equals to 6 multiplied by 4 is 24. So 6 replaced by 24 in a variable factorial. Next time I value is incremented, and again 5 less than or equals to 5 is true. Enters the block. Calculate factorial is equals to 24 multiplied by 5 is 120. For the last time when I value gets incremented, I value is now 6, which makes the condition 6 less than or equals to 5 false. Loop terminates here and executes the statement at line number 18, that is giving a message that the factorial of percentile D replaces the value of number, that is 5, is percentile D replacing the value of factorial that is currently holding 120. Let us build and check how it works. Run the program, demonstrating the working of for loop. Same problem but solved in a different way. You can see the factorial of 6 is 720. You can give any other input to check the output. The factorial of 4 is 24. So here for loop is much compact and easy when compared to while loop. Obviously there is no confusion in while loop as well, but programmers who used to do programming in C language loves working with for loop, because it is much easier for all the three things to placed at one place. that is initialization, condition checking, and increment, that is updating also. So all at one place will make a programmer easy to code. This is just a simple demonstration demonstrating the working of for loop. In the coming videos, we will see the working of do while loop and we will see the working of nested loops as well. That's all using for loop. We will see the remaining topics in the coming videos. Thank you.
Hi and welcome to another online coding challenge on HackerRank. Today's challenge is on a for loop. Objective is, in this challenge you will learn the usage of a for loop, which is a programming language statement which allows the code to be repeatedly executed. We have already gone through the looping structures. We have three loops. One is for loop, another one while loop, and the last one is do while loop. All three loops will have first initialization, then condition checking, then increment or decrement part. These are the three things which are involved in all the three loops. That's what the syntax is given over here. First expression 1 followed by the semicolon, then expression 2 followed by the semicolon, then expression 3. This is nothing but initialization, then condition checking, then increment or decrement. Here is expression 1 is used for initializing variables. Everyone knows the working, so I am not going into the detail of this one. Let us quickly move on to the task. The task of this programming challenge is, for each integer n in the interval from a to b given as input, if say for example n ranges from 1 to 9, then print English representation of it in its lower case, that is ONE1 for numerical 1, then TWO2 for numerical 2, and so on. Else, if n is greater than 9 and it is an even number, then print it is even. And if n is greater than 9 and the number is supposed to be odd number, then print odd. And the input format is, the first line contains an integer a and the second line contains an integer b. The constraint of this problem is the interval a and b should be in the range of minimum 1 to maximum 10 to the power 6. And the output format is print the appropriate English representation, that is even or odd, based on the conditions described in the task section over here, what we have described. Make a note over here, the interval that is given a to b should belongs to the integers range, that is minimum value is a and maximum should be b, and it will be from a, then the next number is a plus 1, a plus 2, a plus 3, so on up to the last number, that is b. Let us see the sample input. Here 8 a value, 11 b value. So the range is 8 to 11. 8 to 11 we have numbers as 8, 9, 10 and 11. But the range of a and b should be from 1 and it should be until 9 only. Then what about these two numbers then? If it is becoming greater than 9, that is if n is becoming greater than 9, then there are two possibilities. Either the number can be even number, then print even, or the number can be an odd number, then print it is an odd number. Say for example here there are two numbers 10 and 11. How do we come to know that this number is a even number or odd number? Whenever the number n exceeding 9, then you take this number and divide with 2. If the remainder is supposed to be 0, then you print this one as even number if it is true. Otherwise, if it is false, then print this one as odd. That's all. So here these are the two numbers. 10 is a even number. See, for 8 English representation 8 is printed, for 9 NINE 9 is printed, but for 10 even is printed, for 11 odd is printed. That is the task what we have to do. Now, how we can accomplish this one? We have the English representation of numbers, that is from 1, then 2, then 3, then 4, then so on up to 9. These has to be stored in an array. Say 1 represents this one, so the next one immediately has to be followed by 2, then and so on, and the last one is to be represented as NINE. This is to be placed within an array. So with this particular guidelines, let us try to code and check how exactly this challenge can be solved. I hope the concept is clear. I'll just repeat it once again. A value and B value will be given to us. A is the starting range and B is the last range. Within this one, if at all the value is less than 9, directly print the English representation. If it is exceeding 9, then check whether it is odd or even. Then print it appropriate message, even or odd. So for doing so, we will be storing this 1, 2, 3, 4, 5, 6, so on up to 9 in one particular array, that is in a character array. Let us now proceed to write down the code. First thing what we need to do is declare a character array. I'll be declaring a character array of some words here, say English words. I'll say words of some say 10 size I'll take, and I'll initialize this as to be from index 0, it is now going to be point, so I'll store 0 also. So we have declared a character array of size 10 where we have given all the representations for all decimal values equivalent. Now the next immediate thing what we have to do is iterate it from A to B. For that one we will be using a for loop. I'll be using it for iteration purpose. Starting index is A. I less than or equals to B. Now first thing what we have to check is the number, that is I index, is becoming greater than 9. If it is so, then check whether it is odd or even. How do you check for odd or even? Divide it using modulo operator with 2. So I'll say if I percentile 2 equals to 0, then we know that this number is an even number. So I'll just say printf even, else it is odd. Once this condition of I greater than 9 is false, then immediately else part will be executed. Then here we have to print its English equivalent what we have stored it in an array. So I'll say percentile s, and in the next line we have to print the next one, word of I. Array name is, here we have stored word. So use the same array name over here to print. If it is 4, its equivalent word of 4 will go to that particular index and it will print. That's all regarding the code. Let's run and check. Okay, that was a wrong answer because of this upper cases we have used. Since it has given here the English representation in its lower case, so we have given now in lower case all this one, and now let us run code. Yes, it has gone through the sample test case. Since that English representations we have given in upper case, it was not accepting, so we have changed it now to lower cases here. Yes, success, compiler message. It has cleared all the test cases from test case 0 to test case 5. Expected output. So we have earned 10 points here. You are now just 5 points away from the third star. That's all for this challenge. We will continue the remaining challenges in the coming videos. Thank you.
Hi. In this section, we will learn about the following. First, let us try to understand how do while loop gets executed. Next, what is the syntax to be followed for using do while loop in C language? Detail working of do while loop, and at the end, and the most important is
the difference between while and do-while loop. Let us first start with the flow of execution of do-while loop. This type of loop in C language is exactly the reverse of while loop, where in while loop the condition or test expression is evaluated at the beginning, whereas here in do while loop the test expression is evaluated at the end. First one, the flow of execution enters do while body without checking any condition. So whatever the statements to be executed under do while loop will get executed first. Then the flow of control comes to check the condition, that is to evaluate the test expression. There are two possibilities. Either the test expression may evaluates to true or it may evaluates to false. Let us say if the condition or test expression evaluates to true, then the control again goes to execute the do while loop body, that is the statements under do while loop, for the next time. The process gets repeated until the condition is false. Once the condition becomes false, the control comes out of the do while loop body and executes the next statement followed by do while loop. Let us see the syntax of do while loop. Here there are two keywords. Do is a keyword and while is also a keyword. Flow of control first enters the block of do while loop to execute the set of statements provided as block of statements here. Then the condition is evaluated. If the condition is true, then the control goes again back at the top to execute the block of statements in that sequence which is provided in the do while loop body. The process gets repeated until the condition is true. Once the condition becomes false, the do while loop gets terminated. So this is the syntax to be followed whenever do while loop has to be used. Let us see the detailed working of do while loop. First step, initialization is not a part of do while loop, as initialization is a part of for loop. Even initialization is not a part of while loop. It is done outside the while loop. Similar to that, initialization here is done before the keyword do. Then the next step, do. Do or perform or execute these set of statements from statement 1 to statement n. Then we have updation process here. After updating, the next step is check the condition. Condition may evaluates to true or condition may evaluates to false. If condition evaluates to true, the control goes back again at the top to start execution of statements once again. If the condition is false, simply exit the loop. So I'll brief this working once again. The first step is initialization. Second step starts do while loop. The keyword do is encountered, so the block is entered first and executes the set of statements sequentially. Statement 1, statement 2, statement 3, unless and until there are further loops or if conditions are provided. If these statements are sequential, then they execute in that order only. That is the third step. Fourth step, update or update expression. Then the next immediate step is to check the condition. And condition may evaluates to either true or false. If it is true, repeat the statements once again. And if it is false, terminate the loop immediately. Hope the working of do while loop is clear. At the end of this section, now we will see the most important points, that is the differences between while and do while loop. In the last video, we have seen the working of while loop. Let us quickly recollect it. Initialization takes place first. While, check the condition. If the condition is true, enters the block. If we have multiple statements, braces are required. If it is single statement, braces are optional. Enters the block. Again check the condition. Process is repeated until the condition is false. It is exactly opposite in the case of do while loop. Initialization anyhow the same. First step only. Now here in do while loop, first execute the set of statements, update the value, then check the condition at the end. Here in while loop, we are checking the condition at the beginning. Let us list out these differences here. Initialization is done at the beginning. So as in do while also, initialization is done at the beginning. Condition checking is also done at the beginning in while loop, whereas condition checking is done at the end in do while loop. In while loop, it checks the condition, and if the condition evaluates to be true, then executes the set of statements within the body of the while loop. Whereas in do while loop, first executes the set of statements in the body of do while loop, and then at the end checks the condition. It's quite opposite. Here in while loop, if the condition is false at the beginning itself, that is for the first time when we are checking the condition, if the condition is false for the first time itself, then while loop execution will not take place. That is, the flow of control will never enter the while loop body. Here in do while loop, even the condition is false for the first time, this will be executed at least once. And there is one more small difference we have not mentioned over here is, while loop syntax does not make use of any semicolon, whereas do while loop makes use of semicolon at the end. That you can see the last difference is there is no semicolon here in the while loop, whereas there is a semicolon at the end of do while loop. So this is about the working of do while loop and the differences between while and do while loop. So where exactly we must use while loop and where exactly we can use do while loop? Probably all loops can be interchangeably used, that is for loop, while loop or do while loops can be used interchangeably. But the main purpose of using do while loop is in those cases where you want to execute the set of statements at least once, irrespective of the condition. Let it be, the condition is either true or false. You want to execute the set of statements minimum or at least one time. Then we must go for do while loop rather than using while loop. Example, we want to display a menu to the user. 1 for insertion, 2 for deletion, 3 for subtraction, and so on. 4 for exit. If user presses 4 at the first instant itself, then we may not repeat the menu once again. Say for example, if user presses 1 and wants to continue again, then we can go for continuation again. The same menu is displayed once again to the user. So this is where do while loop comes into picture. I hope the difference is very clear about while and do while. We will see the demonstration for each loop control statements with individual videos. That's all for now. We will see the remaining topics in the coming videos. Thank you.
Hi, welcome to the demonstration section of do while loop in C language. Here we are demonstrating a do while loop usage with the help of menu driven application. The main advantage of using do while loop is we can execute the set of statements under do while loop at least once, even if the condition provided in the do while loop is false for the first time itself. That is, even though the condition is false, we can execute the set of statements at least for once. So what is that one time statements we want to execute? Let's see here. Here, set of printf statements gives a message to the user showing a menu. A menu displays options as follows: 1 for addition, 2 for subtraction, 3 for multiplication, 4 for exit. We are asking the user to enter their choice. User will be entering the choice. We are reading it in a variable choice. It is an integer variable, so %d is used. Here we are using switch case statement. Switch choice. Say for example, user enters 1. Case 1 it matches with. So we are giving a message in case 1 as addition is %d. This %d now replaces the value of the first number plus second number, that is 100 plus 50. Immediately we are using a break statement. We have seen the working of switch case. There we have seen the significance of using break statement. If we don't give break statement, then all the cases will get executed until the last, even including the default one. So wherever the break is given, the block will be terminated. Say for example, if an user enters 2, case 2 will be executed, where we are subtracting the value, and in case 3 we are multiplying the value, and default, that is when user enters any other option other than 1, 2, 3 and 4. So the syntax terminates for do while loop is here. This is the flower braces terminating for switch case. This flower braces is terminating for do while. Return 0 here, since main function return type is integer. Let us build, check for errors, run the program. Message is displayed now. The first number is 100 and second number is 50. We are having options here: 1 for addition, 2 for subtraction, 3 for multiplication, 4 for exit. Let us enter the choice 1. 1 for addition, that is 150. Same message is repeated once again, that is same printf. Then again I'll say 2 for
subtraction. Then 3, case 3 will get executed now. That is, multiplication is 5000. Again I want to perform addition. Yes, the same thing, I can do it. 2 for subtraction, 3 for multiplication, 3 for multiplication, 2 for subtraction. I can repeat as many number of times as I want. So when I press any other options, say for example 5, it's displaying the message, wrong choice, enter again. And it is displaying the menu also once again. The usage of do while loop is mainly in menu driven applications, where a menu is to be displayed at least once, even if the condition is false for the first time also. So this scenario cannot be used using while loop. So this is the big advantage of having do while loop. That's all regarding the demonstration of do while loop. We will continue with the remaining topics in the coming videos. Thank you. Hi, in this section we will learn about the following. What do you mean by break and continue statements in C language? How break and continue works? Where should we use them in C language? First thing is, what is a break? Obviously, the break statement ends the loop immediately when it is encountered. Break here is a keyword followed by semicolon. Wherever it is used in a loop, that loop will be immediately terminated without further executing the remaining set of statements in that loop. Loop can be any among for loop, while loop, or do while loop. So here there is a continuation in the flow of execution. There is a break. How does it works? Here, in all three possible loop control statements, that is in while loop, do while loop, as well as in for loop, we can use a break statement to terminate the loops without further executing the remaining set of statements. First, in while loop, while syntax is first condition is evaluated, then block will be entered, while loop body will get executed. Within this one, based upon certain condition, or directly we can give break also without any condition, but usually the purpose of giving a break is to discontinue or break the flow of execution of the loop. So here break takes the control out of the while loop immediately. In do while loop, after executing the set of statements, if the condition here in if condition evaluates to be true, then break will take the control out of the while loop without testing the condition even for one time. We have gone through the execution of while and do while as well as for loops in the earlier videos. So I am now just concentrating on break statement. So break statement takes the control out of the loops immediately. Same way in for loop also, break statement takes the control out of the loop. Break is a keyword followed by semicolon makes it an executable statement. Then continue statement in C language. What do we mean by continue? The continue statement skips the current iteration of the loop and continues with the next iteration. Some situation arises where we don't want to continue the current execution of the loop. We just want to skip and continue with the next values or remaining values. So we can use a continue keyword. Continue is a keyword followed by semicolon makes it a continue statement. So there is a continuity in the flow of execution. How does it works? Let's see. Say for example, while loop is there, or we can take it any other loop to understand. Checks the condition first. If the condition is true, statement 1, statement 2 and so on, the set of statements gets executed. If based upon some condition, we just want to skip the remaining set of statements, that is statement 3 and statement 4, then continue if we give, control will jump at the top of the while loop to continue the execution for the next iteration. So for the current iteration, statement 3 and statement 4 are not executed, even though they are part of the while loop. Say for the next time, if the condition is true, statement 1 gets executed, followed by statement 2, and now if this condition is false, statement 3 will also get executed, statement 4 will also get executed, and the while loop continues in the same manner what it is supposed to be executed. So wherever in the iteration we want to skip the current iteration, then we can use continue statement. Break will take the control out of the loop in which it specifies. Continue will take the control back to the top of the loop to skip the remaining set of statements in the current iteration. Hope the difference is clear. We will see an example to demonstrate the usage of break and continue in the coming videos. So for time being, that's all regarding break and continue statements in C language. We will continue with the remaining topics in the coming videos. Thank you.
Hi. In this section, we will learn about the following. What is a nested loop? And what is the syntax for declaring a nested loop? And at the end, we will see an example program using nested loop. In the earlier videos, we have already covered up what exactly a looping structure is. We have three categories of looping structures provided by C language. One is for loop, another one while loop, and the third one is do while loop. And the conditional statements, if condition, that is simple if else, nested if, and if else ladder. Within conditional statements also, there can be nested if. That means one if condition can be placed within another if condition. In a similar fashion, loops can also be nested. We can create code that embeds one loop inside another loop. This is something referred to be as a nested loop. Nested loop means a loop statement
inside another loop statement. Therefore, it is commonly known as loop inside loop. Now, any type of loop can be nested within another type. That means that a for loop can be nested within while loop, or for loop can be nested within do while loop. Even while loop can be nested within for loop or do while loop. Same way, do while loop can be nested within for loop or while loop. So here, any loop type can be nested within another type. The most common among this nesting is the for loops. Nested of for loops are used for iterating through the columns and rows of the data placed under matrix, that is usually a two-dimensional array. Even if we have multi-dimensional array, then there is a requirement for accessing the data through loops. That is something referred to be as nested loops. So most commonly used loops in this scenario will be the for loops. Even in our programs also, we will be preferring to access or iterate it using for loops only. Let us see the syntax for declaring the nested for loop. As I earlier said that all the three loops can be nested. There are three looping structures provided by C language. All three can be nested. Let us start with the first one, that is, how do we nest or how do we provide the syntax for declaring nested for loop. Here it is. One for loop referred to be as the outer for loop. Another loop which is placed inside that loop is known as the inside for loop or inner for loop. For each value of outer for loop, all the values of inner for loop will get executed. That we will see it with the help of an example. Syntax is: inside for loop is placed within the outer for loop. If there are multiple statements, then a block of statement is provided with the help of flower braces for each of the loops. Similar to this syntax, we have the syntax for declaring nested while loop. While condition, then again one more while condition, that is, we have one while loop within another while loop here. So these are the statements which are part of the inside loop, and whatever statements that are placed outside this flower braces are part of outer while loop. And here is the syntax for declaring nested do while loop. Do, flower braces starts, and again one more do while loop starts. When the first do while loop, that is the inner one, gets completed, the statements of the outer loop is there. Even before the starting of the second, that is inner do while loop, we can provide some of the statements to be executed for outer do while loop as well. All the three syntaxes what we have seen are for nested of their own type, that is for loop within another for loop, while loop within another while loop, and do while loop within another do while loop. But it is not mandatory that every time you must follow the same rule. That's why here make a note of this particular point. There is no such hard rule that a loop must be nested inside its own type. In fact, there can be any type of loop nested inside any type of loop, and to any level. You can get it into 2 level, 3 level, 4 level, n number of levels you can go until your requirements permits. And at the end, we will have an example program using nested loop. Here is the program to print the prime numbers between range of 2 to 100. Here is the program. We have two for loops over here. For I equals to 2, I less than 100. It's not including 100 because we know that 100 is not a prime number. Whatever values that lies from 2 to 99, let us check each and every number. Whichever is prime number, we will print it using a printf statement. What is the logic behind this program is, we know that for every number, their factors lies exactly half of that number. Say for example, 10 is there. Last factor for 10 is 5. And if 20 is there, last factor for that one is 10. So here, what we are doing in inner for loop is, we are iterating from 2, j equals to 2, initialization. And here the condition is j less than or equals to I by j. Until we reach half part of that particular number, we need not traverse the complete number also. Then what we are doing within this inner for loop is we are checking one condition by dividing the outermost index value, that is I, whose ranges from 2 to 99, taking each number and dividing it with j. We know that if we get a remainder 0, then 0 negation will be always true. If negation of 0, that means that for a number, say for example 4 or 6 or 8, 9 or any number which is not a prime number, you will get definitely remainder to be 0 when you provide I percentile j. So whenever we get remainder to be 0, 0 negation value is going to be 1. That is, if 1, that is true, then break. Need not continue for that particular number. Break provides discontinuity of this inner for loop and continue for the next value of I value. And if we come out of this loop, we are checking one condition over here. That means that if j value gets incremented until we cross the factor of that number, then we print that yes, it is a prime number. So on, all the values till 99 are going to be printed. Let's have a program demonstration for the same program what we have seen to print the prime numbers between 2 to 100, that is actually 2 to 99. Same program over here. This is the outer for loop iterating from 2 to 99 and inner for loop iterating from 2 to half of that particular number, whatever number we are taking it over here. If the remainder gives you 0, we know that negation of 0 is going to be true, breaking the loop and checking. If it is greater, that is j value is greater than I by j, that means that it is a prime number. Let's build this program, run this file to check. Here is the first one, that is when we are getting this message as here, percentile d is prime, I value is 2. We are taking this particular one, j less than or equals to 2 by 2, that is going to be 1, never enters this loop. We know that j, that is 2, greater than 2 by 2, that is 1. Yes, it is a prime number, it is printed. Even for 3 also, this will never enters the for loop. Let us say for 4, I value equals to 4. Now j value equals to 2, j less than or equals to 4 by 2. 4 by 2 is 2, that is for the first time. When we divide that value, that is 4 percentile j, 4 percentile 2 is going to give you remainder 0. 0 negation over here is true, break the loop. So we are not going to print that value, that is 4 is not printed over here. You can just see the output, 3 is printed and 5 is printed. How 5 is printed? Let us see. I value, when it is incremented to become 5, j value will be 2. So 5 by 2, absolute value is going to be taken and that is going to be 2.5. Since it is an integer value, not a real one, it's going to store 2. So when we divide it, this value, that is I percentile j, 5 divided by 2, you are not going to get the remainder as 0. So j now became greater than I by j value. Yes, j value got incremented from 2 to 3 and coming out of the loop, 3 greater than 2 over here is true. 3 greater than 2 in case of 5. So you are going to get the output here as 5 is a prime number, which is the output over here. Same way, if it is 6 incremented for the next time I value, then j equals to, j less than or equals to 6 by 2. Obviously 3 until 3. Yes, condition is true. We will enter it over here. And when I, that value is going to be 6 divided by j value, that is 2, we will get remainder 0. 0 negation is going to give you 1. That is true. If true, break. So for 6, it's not going to print it. So on all the numbers till the last number you can see over here, 97 is the prime number, is the last number that is going to be printed here. So that is the logic behind the working of nested for loops. That's all for now. We will continue with the remaining topics in the coming videos. Thank you.
Hi, let us take another programming challenge here. In this problem statement, we have to perform two tasks. And the first task is print the multiplication table for a given number in the format given. And here is the format. Example, 5 multiplied by 1, 5, 5 multiplied by 2, 10, and so on. 5 multiplied by 10, 50. Output should be in this particular format. This is the first task. And the second task is print n number of such tables. That is, example, if n equals to 6 is the input value provided by user, then print tables of 2, 3, 4, 5 and 6. These are the two tasks should be done. Now, I suggest you to pause the video and pen down the solution. Okay, here are some of the guidelines which I'll be discussing it over here for task number 1. Using these guidelines, you can achieve the task very easily. This is going to be our task is to print a multiplication table for a given number. If you closely observe this table, here we have 5 to be printed, that is the input provided by user, that is n, and here n is a constant. Then the multiplication symbol has to be printed here as it is, which is also constant. But here if you closely observe, first time I am printing 1, then let us come to this output later on. Next time it is 2, that is the incremented value. So this one is a variable, that means every time its value is getting changed. So let us take this variable as say I, and this variable what we have inputted say assumed to be n. What exactly this output is? This is going to be n multiplied by I. That is, for the first time n is 5 and I is 1. So you are going to get 5. When I value is getting incremented from 1 to 2, then it is now printing 10 over here. When I value is incremented to 3, then 15 is printed, and so on until I value is 10, you are going to get the output as 50. So same thing, n into I is to be printed, I is to be printed, and n is to be printed, along with multiplication symbol has to be printed, as well as you can see here equals to symbol should also be printed as it is. Hope this one will give you a clear picture to achieve task number 1. Let us proceed to get some guidelines for achieving task number 2. Here are the solution guidelines for achieving task number 2. Let us say if input value n is 5, then we have to print the tables of 2, 3, 4 and 5. So 2 table, 3 table, 4 table and 5 table. Provided if the value of n is 5, you have to print the table of 2, you have to print the table of 3, you have to print the table of 4, and at the end you have to print the table of 5 as well. So it depends on the value of n what is inputted by the user. Those many number of tables we have to print: 2 table, 3 table, 4 table and 5 table. So here I suggest you to put down your logic and write down the program and then check the solution what I am going to provide in the next video. Until then, all the best for the solution. Thank you. Hope you have done with the solution of printing a multiplication table for a given number, and there were two tasks in that programming challenge. The first task is to print a multiplication table and the second task is to print n such tables. Let us begin with the solution here. Those who have done with the solution, you can match the solution over here. Now recollect what exactly the problem is. Here is the solution guidelines what we have discussed. Let's quickly recollect it over here. For the program, we need a for loop or while loop or do while loop, any loop. So let us take a for loop, and this one is going to be the input from the user, and this one is going to be an index or a variable in a loop. And here this part is going to be the multiplication of n with I, and these things are constant, that is printing multiplication value and equals to. So based upon the requirement, let us quickly write down a loop over here. Let's say for loop. What we need in this printf is we need to print 5 multiplied by 1 equals to 5, 5 multiplied by 2 equals to 10. That means that 5 value should be the input given from the user. So let's read that particular input over here. So let's declare integer n and give a message to the user to enter. Now once we are done with reading a number over here, let's try to print that value here. %d multiplied by %d will give you some result in %d. What are these %d's are? First value, that is this %d, is nothing but the value what we are inputting from the user, and this %d is nothing but the I value which is going to change, that is a variable from some 1 to 10 which is incremented every time by a value 1, and here the last one should be a multiplication value of I and n. So here the first one is n, second one is I, and the last one is n multiplied by I. These values are to be printed. After printing first one, I need to get it into the next line. Output should be in next line. I am using 1/n for printing the output into the new line. Let's build and run the code. Enter a number, say 8. So 8 multiplication table. Let's run again with a different value. 5 multiplication table, run with a different value. So it's working perfectly. So the first task is achieved here. You can match the solution. We are reading a number, iterating it from 1 to 10. These are the values which we are going to print it over here using I, and these are the values what we are inputting from the user, and this is the multiplication value of n and I. Now what is our second task is, for a given number of n, we have to print n such tables. Here is the solution guidelines what we have seen. If n equals to 5, that is n equals to the input value whatever given by the user, we have to print the tables starting from 2 table, then 3 table, then 4 table, then 5 table. That means here these values are going to change now. 2 table for the first time, 3 table for the next time, 4 table for the next time, 5 table for the next time. These inner values remains same. That is, we are iterating inner for loop or inner loop from 1 to 10, but outer loop changes from 2, 3, 4 to 5 if input is 5. If it is 6, 2, 3, 4 and 6. Let's begin here. We will add one more for loop as a outer for loop into j equals 2. Your outer for loop will be how many number of times we have to iterate it. From j equals to 2, j less than or equals to, so now say n and say plus plus j. So this table has to be printed based upon now j value, not n value. So it's going to be j and j multiplied by I. After printing the first table, we want to print the next table. I'm giving one more slash n over here. Let's check. Let's enter a value n equals to 5. Now you can see when I am entering a number 5, the output is 2 stable first, then 3 stable, then 4 stable, then 5 stable. Let us re-enter. If I give 9, then starting from 2 table, then 3 table, then 4 table, then 5 table, then 6 table, then 7 table, 8 and 9. Perfectly. Hope you got the solution. That's all for now. We will see the remaining challenges in the coming videos. Thank you. Hi, welcome to another programming challenge, and here is the problem statement for you. Find the reverse of a given number. Read a number from the user and find the reverse of that particular number. Example, if the input is 1, 2, 3, 4, then we should generate the output as 4, 3, 2, 1. This is the challenge. Now, I recommend you to pause the video and pen down the logic. If you want the solution guidelines, then you can continue the video. Here are the solution guidelines. Read a number, say in a variable n. To reverse n, say for example, we have a number 1, 2, 3, 4. We should start extracting its last digit. Here is the last digit for the number, that is 4. Now, how do we obtain this 4? We can obtain and we can get this 4 using this operator. Then we will store this 4 in a variable, say remainder. Take another variable, say reverse, initialize it to 0, and then calculate this one. Reverse multiplied by 10 plus current value of the remainder. Every time you take that, because every digit it's going to form over here a number. Its position is unit, tens position, hundreds position, thousands position. So every time 110 is going to be multiplied. So we are multiplying this one with 10 and we are storing the result in a variable, say reverse. Now the next step is, once we got remainder is equals to 4, initial n value was 1, 2, 3, 4, which should be now reduced to 1, 2, 3. That we can get it using this operator slash, which makes you 123 to be left out. Then we can repeat from step 3 until the number is greater than 0. Hope this input will fetch you some details and you can pen down now and get to the solution, or watch my next video for the solution of this particular programming challenge. Until then, see you. Thank you. Hi, welcome to the solution for the programming challenge to reverse a given number. Here we are ready with the template to write down the program. Those who have already done with the logic, what we have discussed in the solution guidelines. You can verify your answers over here. Those who have not done with the solution, they can just revise the logic once and try once, and then you can check the solutions. Anyhow, I am going to generate the solution over here. Let's start. First thing is, we have to get a number, that is, give a message to the user. Okay, we got the number in a variable n. What we should do with this number? Let's iterate it using a loop. How long shall we iterate it? Until the value of n is greater than 0. 3 steps we have to perform it over here. We have to extract the last digit. To extract that last digit, let's take a variable, say remainder. I am taking it as remainder, assigns whatever n is there. Take mod operator, divide it with 10, you will get it in a variable remainder. I'll declare the appropriate variables over here, say remainder, and one more variable, say reverse, which is initialized to say 0. Okay, once we got remainder in this particular one, for example 1 2 3 4 is our input, so we got 4 in this particular variable. What about this 123? It should be now replaced with original value in a variable n. So n is equals to n/10. That is the quotient part. 123 will be getting over here. Now, as we have seen in the solution guidelines, we should take a variable, say reverse, takes the original value of reverse is 0 currently, multiplied by 10, and add the remainder whatever we got it. This one should be repeated in a loop. Once we are done with the while loop, give a message to the user using printf statement. So this is the simple logic what we have. Let's try to build and check the output. Enter a number. Same number we have inputted over here. You can see the inputted number is 1234 and we got the output as 4321. Hope the solution is okay. You can work out with any other loop as well. While loop I have taken it, you can take for loop or do while loop as well. That's all for this challenge. We will see the remaining challenges in the coming videos. Thank you. Hi and welcome to another programming challenge. Here the problem statement for this challenge is: find whether a given number is a palindrome number or not. First of all, what is a palindrome number? A number which can be readable from both the ends, that is from left side as well as from the right side, the same way. Example, if the input is 343, then it is said to be a palindrome. Say I have a number, say 456. This number is not a palindrome because providing a reading from left to right and providing a reading from right to left does not fetch me the same value. Whereas for 343, if I read it from left to right, it gives me 343. Even for right to left also, it gives me 343 only. So this type of numbers are known as palindrome numbers. Then what would be the logic? Those who have already solved the programming challenge for reversing a number will find it very easy to find whether a given number is a palindrome or not, because first of all we have to reverse a number. So I suggest you to pause the video and pen down the logic. There is a small twist in this programming challenge. If you carefully concentrate on that logic, then you can easily find out whether a given number is a palindrome or not. And if the input is say 123, just now what we have discussed, if I am performing reading from left to right and from right to left, it does not gives me the same number. So here while reading in reverse I am getting 321, whereas while reading in forward direction I am getting it as 121. So it is not a palindrome number. Hope the logic is clear. Let's have some solution guidelines which may help you in solving this programming challenge. Here is, read the number, say store it in a variable n. Store n in a temporary variable. This is the twist over here. The simple logic is we are using one temporary variable. Why there is a need for this variable is because during the process of reversing a number, which we have already covered in the previous programming challenge, if I have say 123 as a number, then while performing the reverse of this particular one, I am dividing this number first time to get it first 12, then again 2, then again you got final value of n to be stored as 0. That means that we have lost the original value 123. So to retain that, we are taking one temporary variable. If the reverse number matches with the original number, then it is said to be a palindrome. Otherwise, simply give a message that it is not a palindrome. So all the best to you. Pen down the things and put down the logic based upon the solution guidelines over here, and the solution will be provided in the next video. Thank you. Hi and welcome to the solution to find whether a given number is palindrome or not. Now, what is the logic behind finding whether a given number is palindrome or not? Is simply find the reverse of a number. That we have already done in the previous challenge, so that doesn't require much effort. So I'll quickly jump into the solution to generate the reverse of a number. Then once we find the reverse of a number, then we will see how we can check for a palindrome number or not. Let's begin. Once you are done with reading a number, declare the required set of variables here. Say n, say reverse, initialize it to 0. The same logic what we have used there. I'll be using one temporary variable as well. One variable, say remainder, are the set of variables. Now let's make use of while loop for iterating it until n value is positive. The three steps. What are the three steps required? Remainder we have to find. Then we have to take n as the remaining value, that is the quotient part. Once you got the quotient in n, then store it in a variable reverse as. Once you are done with this, we have to check at the end with the number, but we lost the number, original number. For that one, I'll be using one temporary variable over here to store the original number. That you can check the condition here if that temp is now matching it with the reverse number. If it matches, give a message that it is a palindrome number. Else, now once we are done with this, let's see by running the program. Enter a number. The number 121 is a palindrome. Let's run for another input value. 123 is not a palindrome. So what is the logic behind this code is, the first step is calculating the remainder. Say let n equals to 121. For the first time, remainder will be equals to this one what we have, and n value will be equals to this part, that is 12. Next time what you are doing is, next step what we are doing is, we are calculating reverse equals to original value of reverse is 0, so that we are taking it over here, 0 multiplied by 10 plus the current value of remainder is 1, that will fetch you 1. This is for the first iteration. Now check again, n value, that is 12, is greater than 0. Yes, true. For the next time also, enters the block, calculate remainder. What is the remainder now? You are going to get 2 this time, because 12 divided by 10 percentile is the modulo operator, which will give you 2. Then when n is divided by 10, this time it will be 1. And now the new value for reverse is equals to, current reverse value is 1, which is now multiplied by 10 plus current remainder is 2. So it's now going to take 2. 10 plus 2 will fetch you 12. That is there in reverse after the second iteration. Now you check the condition once again. Current value of n is 1, which is still greater than 0. So enters the block and calculate the remainder. When 1 is divided by 10, remainder is now going to give you 1. When n/n is executed, this time you will get 0 here as the quotient. And in the third iteration, reverse value will be, current reverse value is 12 multiplied by 10 plus the remainder for now is going to be 1, which will fetch you 120 plus 1 will give you 121. Yes, we got 121 in which variable? We got 121 in reverse variable. And we have already stored n value here. That means currently temp is storing a value 121. When we match it over here, when temp equals to reverse, yes, it matches and gives you a message, this one. This is an example for a number which is palindrome. Let's take an example for a number which is not a palindrome. Say for example, n equals to 123. For the first time, when remainder is calculated, it is going to give you this value 3 because of percentile. So 3. Then here n will be this time same thing, 12 will be there, and reverse is equals to 0 multiplied by 10 is 0, 0 plus remainder will give you 3 after the first iteration. Next iteration, n is greater than 0. Yes, it is true because 12 is greater than 0. Continue. 12 percentile 10 will fetch you 2 as the remainder in the second iteration, and n value will be replaced by n/10, that is the quotient part, that is 1. And reverse, what you will get it now is most important here. Current value of reverse multiplied by 10 plus current remainder value is 2, which will give you 32 after the second iteration. Still 1 is greater than 0, so this condition is true once again. Enters the block and calculate remainder. Now remainder, what you will get it as 1, and quotient you will get it as 0, and finally this time it's going to give you 32 multiplied by 10 plus remainder is 1, so it's going to give you 320 plus 1, that is nothing but 321. Now when reverse is storing this particular number and temp is now storing 121, this number, when you are trying to match these two numbers, there is no match. That's why here you will get this condition fail and else part will be executed, so number is not a palindrome, will be printed. Hope this logic is clear, and you can apply any loop instead of while loop. You can even take for loop or do while loop. While loop is most suitable here, that's why I have taken it while loop here. That's all for this. We will see the remaining challenges in the coming videos. Thank you. Hi, here is the programming challenge. The problem statement is print the following Pascal triangle given below. Now, the task is to print the asterisk in this particular form such that it forms a Pascal triangle. Now, I suggest you to pen down what are the requirements. First thing is we need to print asterisk 6 times for the maximum number of times, and the number of lines that are to be printed is also 6. Concentrate on the problem statement and try to generate appropriate solution. Now, I'll be providing some solution guidelines using which you can have an approach such that you can easily solve the problem. Here is the first one. Count the maximum number of asterisks to be printed. Here, in this case, it is 6. Next, print asterisk 1 time in first line, 2 times in second line, 3 times in third line, and so on till 6 times in the last, that is 6th line. If you follow this pattern, then you may get some idea how to print this asterisk. In between, we have some spaces and tabs. So use appropriate spaces and tabs wherever necessary. Obviously, we require nested loops to accomplish this task. I'll give you a hint. One loop is required to print number of times, that is the task to be repeated, and within that loop you need to have again iteration using some loop to print spaces and asterisks. Now here I suggest you to pause the video and pen down and write down the code with your own. If you are done with writing down the code, then you can match and see the solution what I am going to give you now. Let's have the solution to print this Pascal triangle. Let us begin the coding part to have the solution to print the Pascal triangle. I am including, say, stdio.h header file, assuming that I'll be using a printf statement. Main function starts and ends. Obviously, since we are having return type as integer, I am providing return 0. Now, what is the first requirement here? We need to print asterisk how many number of lines that we have identified. It is to be 6 times. So I'll use an iteration. You can use any loop. I'm using a for loop over here. For I equals to 1, I less than or equals to 6, I plus plus, iterate it, and this has to be repeated for 6 times. Now what is there to be repeated in this particular for loop is we have to give spaces for which we use another loop, and we have to print asterisk for which we will be using another loop. So first, one for loop for printing. So for this for loop, I'll be using another index, and this index starts from reverse one. That is, spaces should be maximum to minimum. That is j greater than the value of I till it reaches 1 for the first time, next 2, next 3, like that it has to be. So j has to be decremented. Within this for loop, I just need to print the spaces, only one space. Now in this for loop, we have to print the values from, say, 1 until it reaches the value of I. That means asterisk is to be printed 1 time for the first time.
So what is we are going to print it over here is asterisk. Asterisk is to be printed. For the first time it is till 1. Next time I value is 2. So asterisk is to be printed 2 times. Next time 3. Asterisk is to be printed 3 times, and so on. Now here, after printing asterisk, we need to go to the next line. So we required a new line escape sequence. Now, once we are done with this one, let's have some formatted print over here. So I'll be using tabs. Now, how many number of variables we are using it in this program is, we'll declare all those variables here, I, j and k. Hope this one will fulfill the requirement, whatever we have to accomplish the task. Let's try to build. Check for the errors over here. No errors, no warnings. Run the program, and here is the output. We can see here, for I equals to 1 to 6, here 1 line, 2 line, 3 line, 4 line, 5 line, 6 times we have to repeat. For this one we required the outermost for loop, and within this one, so here 4 tabs are printed. That means the output is printed using this tabs, 4 tabs. That's why the output is printed here. Now this for loop j equals to 6 and j greater than 1, this is used for printing spaces. Here are the spaces. You can see the matching over here, asterisk actually to be printed here, but we are providing first spaces over here such that star is to be printed after that. So star is printed here. After printing that star, we are going to the next line and again repeating the same task. That is, I value is now 2, so it is to be printed 4 times space. Like that, the output is going to be printed. I hope it matches the solution what you have. That's all for now. We will see the remaining topics in the coming videos. Thank you.
Hi, and welcome to another online coding challenge on HackerRank. Today we will take up a challenge, sum of digits of 5-digit number. The objective is, in order to get the last digit of a number, we use a modulo and slash operator here. When the number is modulo divided by 10, we get the last digit. To find the first digit of a number, we divide the number by 10 until the number is greater than 10. At the end, we are left with the first digit. Here the task is, in this challenge, you have to input a 5-digit number and print the sum of the digits of that number. Here is the input format. The input contains a single 5-digit number, say n. Constraint is minimum n should have this one and maximum n should have this range. And output is, we have to print the sum of the digits of that particular 5-digit number. Say for example, sample input is 10564. We should get the sample output as 16. So how to get this one? Let us see it here. The process is 10564 is the number given to us. You take this digit. How do you get this particular digit? You divide n modulo 10. Then you will get this number 4. You store this particular one in a variable, say remainder, and we will initialize a variable, say sum, to be 0, such that for the first time we get a remainder value as, so here current remainder value is 4, so we will sum up. Sum is equals to sum plus remainder, so you will get it as 4 here. Now what is our number remaining over here left out is the quotient part. How do you get the quotient part? You use slash operator. Then you store the result back again in n. Then sum is again performed. That is, sum plus is equals to remainder. We have already done this sum remainder, this part one time. So these three steps are to be repeated. Let us see first of all 1056. How do you get this 1056? With this step, n equals to n slash 10. So when we say n is equals to n slash 10, we get the quotient 1056. You take this again 1056, again you divide it with 10. So that this time you will get a remainder 6. So current remainder value is 6. When you perform sum plus is equals to remainder, then you will get 4 plus 6, that is nothing but 10. Now again n is equals to n slash 10 will give you 105. So 105, again give it to this modulo operator, then we will get 5 as the remainder. Then we perform sum plus is equals to remainder again, 15 you will get, n is equals to n slash 10 will fetch you 10. Then when you again perform modulo operator, then 0 is the remainder, then 0 plus 15 is 15 only, then n equals to, now left out is 1. Lastly, when you perform n percentile 10, 1 is the remainder, that you will get it here. Then sum plus is equals to remainder will give you 16. When you divide now n equals to n slash 10, this time you will get n value as 0. So these three steps must be repeated until n is not equals to 0. We can use a while loop or for loop or do while loop, anything to perform this operation. Say for example while loop, if we are taking, place the contents into while loop. So repeat this process until n becomes 0. So here we get the output as 16. Hope the working is clear. Let us put down the code and test. Required variables, I'll be declaring a variable sum, initialize it to 0. We got here already n, we need not read the value. We can use a while loop or do while loop as well. While n not equals to 0, we have to perform 3 steps. What are those 3 steps are? We need a remainder, so I'll be declaring a remainder as well. Remainder is equals to n percentile 10. First step. Second step, n equals to n slash 10. And the last step is to sum up this value. And at the end, printf. That's all. Let's run the code and check. Yes, it has gone through the sample test case perfectly. We got the output as 16 as expected. Let us submit the code now. It started the remaining test cases. Here is success. Gone through all the test cases. We have cleared this challenge as well. So we have earned 15 points. Now you are left out with only 15 points for the next star. Here you can see 15 more points to get your next star. So that's all regarding this sum of digits of a 5-digit number. We will see the remaining challenges in the coming videos. Thank you. Hi and welcome to another online coding challenge on HackerRank. Today's challenge is printing a pattern using loops. In this problem, you need to print the pattern of the following form containing the numbers 1 to n. Say for example, if n value is 4, then this pattern has to be displayed. How the pattern is, let us see that in detail, but what are the other things and constraints are given, let us look into this one. Here is the input format. The input will contain a single value, that is n. It can be 4, it can be 5, it can be 6, or it can be any other value ranging from 1 to 1000 it can be. And the output format is print the pattern mentioned in the problem statement. Just now what we have seen. Let us say for example, if the sample input value n is 2 and this should be the output. You can see over here, this is printed in the form of a matrix. Whenever the data is to be processed in the form of matrix, it is nothing but accessing row as well as accessing column. So whenever we are accessing row and column, we need one index to access row, another index to access column. that can be accomplished only using nested loops. So here n equals to 2 is there. How many number of elements we have to print it over here is 3. If n equals to 4, it will be 7 elements we have to print it. So that pattern we will see it here. Say for example, here is n equals to 5. So total number of elements what we are having it over here is 9. So what is the length of this one is, length will be always equals to 2 times the number of elements minus 1. Here also you can see current n value is 7. So we are having total of 13 elements in each row. But what exactly the pattern we have to follow? First row, that is nothing but row 0, will contain all n values, whereas in row 1, that is in the next row, only the last 2 elements are n value, but in between what we have over here is n minus some value. What is that some value is? Let us say 1 here. Next row, when we come for next row, row 2, last element is n, and second last and second element is going to be n minus 1, whereas the remaining set of elements are going to be n minus 2. So it's increasing over here. First time it was only restricted till n minus 1 here for row 1. Now it is including n minus 1 as well as n minus 2 elements, including n as well, n at the end. Same thing, if I proceed further, say for example this one, these two end values are n, then these two end values are n minus 1, and again these two end values are n minus 2, then followed by the remaining set of elements will be now n minus 3. It's going on adding until we reach one value here. Again the pattern has to be repeated in the reverse way. So how we can do this one? Here is the value that is getting changed over here. Initially let us assume it is n minus 0. Now it is n minus 1, n minus 2, n minus 3. So in general we will take this one as n minus some minimum value. That minimum value can be ranging from 0 for the first time, next 1, next 2, next 3, next so on. So if we keep on calculating and printing the value based upon this n minus min, then we can easily print the output. The same thing has to be followed over here. For the first one, n minus 0 is printed. Next, n minus 0 is printed here and here, whereas for the remaining set of elements, all are going to be n minus 1. The same, here the end one is n minus 0, then these two elements are n minus 1, then the remaining set of elements what we have is to be repeated for n minus 2. For doing so, we will be calculating minimum value 3 times. Minimum will be calculated based upon the number of rows and number of columns. Whichever is minimum, we will take that minimum value here and substitute, and we have to print this number. So by taking this particular logic, let us try to write down the code and see how exactly it works. Here is the editor in which we will be completing the code. N is already declared and n is already read using scanf statement. So we need not read this value n. Let us proceed now to calculate the length first of all. So I'll declare length over here and I'll say length is nothing but 2 multiplied by n minus 1 will be the length. Just now what we have seen. Then we require to access row as well as column. For that one we will be taking nested for loop. How long shall we continue? Till we reach length. Then we need another for loop inside. This one is for column. Again this one also starts from 0. And column also should proceed till we reach length. Within these two for loops, what we need to do is we need to print, but before printing we need to calculate minimum. Let us declare a minimum variable, and minimum can be say for example, if row is less than column, then obviously we will take the value of row. Otherwise, we will take the value of column, whichever is minimum. But this is not the only case. Min will become, that is minimum value. Current minimum value, just now what we have calculated, if it is less than length minus the number of rows. If it is so, then we will take current minimum only. Otherwise, whatever length is there minus the number of rows minus 1, since row is starting from 0. Otherwise, minimum will take minimum minus, if minimum is less than length minus column, then obviously we will take min. Otherwise, same thing applies for column also. I'll say column minus 1. Now we got minimum in min variable. So using this one, we will print %d, and we will be using one space over here to print. And what is the value to be printed is n minus min, what we have seen it. Coming out of one for loop, we have to print the next line. That is, the contents are to be printed into the next line. That's all regarding the code. Let us run the code and test. Yes, it has gone through the sample test cases here. And let us quickly submit the code. It is processing for the remaining test cases. Total of 15 test cases it has. Yes, you just solved all the conditional and loops challenges in C, and we earn 30 points for this one. 70% of this task is over, and we need only 30 more points to get the next star. That's all regarding printing the patterns using loops. We will see the remaining online challenge in the coming videos. Thank you.
Hi. In this section, we will learn about what is goto statement and labels in C language. What is the syntax? How is the working of goto statement is there? And at the end, we will look at some of the drawbacks of using goto statements. What is goto and labels? Goto is a keyword in C language among the 32 keywords provided by C language. Whenever this goto is encountered by the compiler, it searches for its equivalent label preceded by goto. So this is also referred to be as unconditional jump. Without any condition, we are going to that particular label, and from there the program execution continues. The goto statement can be used to jump from any part of the source code to anywhere within a function. The goto statement allows us to transfer the control of the program to a specified label. Now, this label can be a user-defined identifier followed by colon. It can be a user-defined name. We will see with the help of an example what exactly a label is. So, we can transfer the control of the program from a specific statement to a statement provided by a label. Let us see the syntax for declaring a goto statement. Whenever a goto statement is encountered, the control goes to a specific label followed by colon. Then what are the statements provided after that label? The flow of execution will continue to execute those statements. That's why it is also called as unconditional jump. Here is the working of goto statement. In a program, we can have multiple labels to be provided. Let us say I am having 3 labels over here. Label 1 followed by label 2 followed by label 3 before each statements. Say statement 1, statement 2 and statement 3. If I don't have a goto statement, then what happens? The flow of execution will be directly statement 1, then statement 2 and then statement 3. After execution of statement 1,
if I say go to label 3, then the flow of execution will go directly searching the label 3 and execute statement 3. So here there is no condition checked. Go to a specific label, control goes to that statement and execute it. That's why it is called as unconditional jump. It is not recommended for a programmer to use a go to statement because there is always a chance of a programmer getting confused where exactly the flow of execution is. Let us see a program using goto and labels so that we can have a clear idea how exactly goto statement executed. Here is a simple program which is trying to print numbers from 1 to 10 without using a loop. Here is first line in the program declares a number of integer type and initialize it to 1. Immediately followed by that one we have a label. I am considering the name of a label itself is the label. You can provide any user defined name. Now the program continues to execute for the first time printf %d n. Current value of n is 1, that is getting printed. Then n++ will make the value of n to incremented by 1. So now the current value of n becomes 2. If n, that is 2, less than or equals to 10, that is true, I am saying go to label. Control goes to label part. Again it prints the value, that is 2 is printed this time. Then 2 is incremented to 3. Then 3 is less than or equals to 10, true. Again go to label, then print the value 3 and so on. Once we have n value reaches to 10 for the last time, 10 will be printed. Then when n++ is encountered and it becomes 11, 11 less than or equals to 10 is false, then goto will not get executed and the program terminates. If you see carefully this particular program, we are not using any loop, but this statement printf n++ and condition is getting executed for a specific number of times using goto statement. There is always a chance of a programmer getting confused where exactly the flow of execution is. So there are certain drawbacks are there with these statements which makes a programmer not advisable to use this goto statement. Here are some of the drawbacks among them. The use of goto statement is very highly discouraged as it makes the program logic very complex. So we should not make the program logic to be complex. In fact, we should try to make the logic as simple as possible. So with goto statement, there is always chance of getting confused while tracing the program as well. So if we get confused while tracing the program, then the logic becomes very complex. The use of goto makes the task of analyzing and verifying the correctness of program very difficult, particularly those involving loops. We know that a loop is going to execute for a specific number of times. Within that loop, if we make use of goto statement, then we should clearly have an idea when exactly the control goes to that label and when exactly the control comes back again to the loop to continue the flow of execution. One more thing is, instead of using goto statement, we can just simply avoid goto statement with the help of two more statements provided by C language. That is, one is break, which takes the control out of the loop, and continue, which takes the control to the top of the loop to continue for the next index of that iteration. We have already covered these two topics, break and continue, in a separate video. Those who want to see the topics break and continue, they are advised to see the video first and then you can continue with this video. Here is a very popular personality, Jarne Stroustrup, who has developed C++. He said a very good thing about goto statement is the fact that goto can do anything is exactly why we don't use it. So there is always a chance of a programmer to do anything with that goto statement, but we may get confused with this particular statement if it is misplaced or if it is wrongly used. That's all regarding goto and labels in C language. We will continue with the remaining topics in the coming videos. Thank you.